will be a Starfreelancer. Learn new skills. Set your goals. Increase your skills. Browse over 100 plus videos and ebooks. Jump to starfreelancer.eu.
So in the last video, we started work with the pattern and the matcher classes, and we saw some results when the entire string or character sequence matches the pattern. Now that's good, we need to do that in some situations, but how can we find out the occurrences there are and where they actually occur? So for that we're going to use the find, the start and the end methods. So let's actually have a look at that. So we can try looking for occurrences in a string by creating a loop. So we're going to do int count equals 0 and while matcher dot find, that's the find method. Then every time it finds a match we're going to increment our counter. Then we're just going to print out occurrence plus count plus then matcher dot start is where the match started plus 2 plus matcher dot end, which is obviously where the match finishes. So as you can probably guess, the find method looks for occurrences of a pattern used to create the matcher. Now when it finds one, the internal state of the matcher instance is updated and we can then call the start and end methods. You can see me doing that on line 73. So the start method returns the index of the first character in the match, and the end method returns the index of the character that occurs right after the last character in the match. So we have two occurrences of H2 in our pattern, which you can see above, and so we should expect to see two occurrences printed to the console. So let's actually just run this and see what happens. Now, obviously something didn't work. So all we're seeing is the true, which is the result of the code on line 68 printing out matcher.matches. So the loop, in other words, didn't actually find anything. Well, there is a reason for that, and that's because we can only use a matcher once. So matchers have an internal state that's updated whenever we use it. And if you recall, I said that when we talked about find. So the matcher is updated, and then we can use the start and end methods. But when we called the matches method, so that we could print true false to the console, the code on line 68, the internal state of the matcher was updated in such a way that we have to reset the matcher before we can use it again. So we'll do that by using the reset method. So basically the line before, I'm going to do matcher dot reset to reset the internal state so that we can use the matcher again. So let's now run that. Alright, so we're getting better this time because we've now got some output. We've got occurrence 1, then colon 0 to 179. So it's good in the sense that it's giving us something, but it's obviously not what we expected to see. So what's actually going on now? Well, the regular expression we use to determine if H2 occurs anywhere in the text isn't specific enough when it comes to pinpointing how many occurrences there are and also where they are. So we had to use a broad expression with the matches method because the entire text had to match. Now because we used such a broad expression, there's only one occurrence of a match, which in this case is the entire string, and the start and end indices are for the entire string. But now we're looking to find the occurrences within a string. So we don't need the entire string to match, we only care about matching parts of the text. So we can then go back to using H2 as the regular expression. So let's go back and change the pattern on line 65. We're going to change that to just H2, the less than and equal sign, so it's actually a standard HTML tag. So now if we run this, we can see that we've now got the right results. We've got two occurrences, and that's obviously the code here, H2 and H2. Keep in mind that the index returned by the end method is actually the index for the first character that comes after a match. Now this obviously works what we've done, but when you're using a matcher to find multiple occurrences of a pattern, there's actually an easy way to do it. Now we can actually use what's called a group. So to use a group in a regular expression, we use parentheses. So in this case, we're going to use the regular expression as we've got on line 65, but we're going to surround that in parentheses. So we're going to come up here and change that, the regular expression, to parentheses like so. And keep in mind that the parentheses aren't part of the pattern that has to be matched. When working with groups, we access them using the group method in the matcher class. So one version of the method takes an int parameter, which is the group number. This is for the group method in the matcher class. Now when working with groups, the entire character sequence is group 0, so when we want to access a specific group, we actually start counting from the number 1. So let's actually look at an example. We're going to use groups to find occurrences of H2. So what I've done is I started making a change to line 65, but I'm going to just undo that. And what I'll do is instead, I'll kind of come down here and we're going to create another string. String H2 group pattern equals, and parentheses, then the H2 tag we're looking for. So left and right parentheses surrounding that. Then we're going to do a pattern, group pattern, is equal to pattern.compile. That's going to be H2 group pattern. Then we're going to do matcher, group matcher. Set that equal to group pattern dot matcher. And we're still going to use the original HTML text that we've got defined on line, or starting on line 58. And then we're just going to print out to see whether we actually have got a match initially. And we'll just use the group matcher dot matches. And because we've done that, we now know that we need to do a reset if we want to reuse a matcher. So it's going to be group matcher dot reset. And then we're going to do while group matcher dot find. And we'll just do a printout of occurrence plus group matcher dot group. We're going to put 1 in parentheses there. All right, just going to move that up a little bit. So here we've updated the regular expression that we're going to compile, which is on line 78 with parentheses now. And note that the loop is now different to what it was when we were using the previous matcher.find. For each occurrence, we call the group method with the value 1. And we have more than one occurrence, but we only have one group in our regular expression. So group 0 is the entire character sequence. So group 1 is our H2 in parentheses group, which is the one that's defined on line 78. So let's run this and see what happens. And you can see we've got a false there for the match. Then we've got our 2 occurrences showing. So not very exciting, but we know that there's 2 occurrences of H2, but so what? It would be nice to be able to extract every H2 from the text in its entirety, which would include the opening tag, the text, and the closing tag. So this is actually very easy to do. All we have to do is change our regular expression to match the opening tag, the H2 text, and then the closing tag. So let's actually go ahead and try changing something to see how that would work. So we're going to come back up to our group pattern, H2 group pattern, and we're going to put a dot after the parentheses, and a star, then start the tag /H2, the closing H2 tag, like so, and that has to have an ending parentheses. Then we get rid of that first closing parentheses. So we're surrounding the entire regular expression in one parentheses there because that's our group. So basically what we're saying here is that we want the opening tag, the closing tag, and everything in between. And if you remember that the dot means any character, and then the star quantifier means 0 or more. So dot star in this case will match 1 or more of any character. So if we actually run that, it's starting to look like what we want, but clearly it's not exactly what we want. Because what's happened is the regular expression has grabbed everything from the opening tag of the first H2 to the closing tag for the second H2. So the question here would be, does that match our regular expression? Well, actually, yes, it does. After all, the strings that we got start with H2 and ends with a /H2 and has text in the middle. But it's just obviously not what we're expecting. And the reason this is happening is due to a concept that I haven't discussed yet: greedy quantifiers versus reluctant or lazy quantifiers. So the star quantifier is what's called a greedy quantifier. So it'll grab as much text as it can. So when it's doing its matching, it doesn't actually stop at the H2, the closing H2 tag. It actually keeps going to see if more of the character sequence can result in a match. So in our example, grabbing more text can still result in a match, as we've seen here. Now we want to use a lazy quantifier, one that does the minimum amount of work. So once it finds a match, it doesn't keep looking to see if it can include more characters in the match. So it may still find more matches in later parts of the character sequence, but each match will contain the minimum number of characters required for a match. Now the question mark quantifier means 1 or 0 occurrences is a lazy quantifier. So we can use it to turn a greedy quantifier into a lazy quantifier by actually adding it after the quantifier. I know that sounds confusing, but we'll see an example of that. Now, since it wants no or only one occurrence, the moment the greedy quantifier that it's modifying finds a match, it will stop grabbing text. And that's obviously what we want to do here, so that we can actually separate our H2 occurrences. And the reason that it will stop at that point is the question mark quantifier will be satisfied at that point. So let's give that a try. So all we really need to do is come up to our pattern on line 78, our H2 group pattern, and put a question mark straight after the star quantifier. And again, by adding the question mark after the star, we've turned the star quantifier into a lazy quantifier. So now that when we run this, we should see we've got separate occurrences of H2 now, the H2 tags. And you can see we've now got two versions there. We've got our subheading H2 tags and the text in between, and likewise for the summary as well. So now you've seen how we could use matches to parse HTML code, and hopefully you're now thinking that's a little bit more exciting than what we've done so far. One quick note though, if we weren't interested in empty H2 tags, and they're tags with no text between the opening and closing tag, we'd use the regular expression H2 dot plus question mark and then the closing H2 tag instead. So the plus, as opposed to the star, wants one or more occurrences, whereas the star will accept 0 or more occurrences. And we can also use multiple groups. For example, if we just wanted the text between the tags and not actually the tags themselves, we could change that up a little bit. And so here we're going to add another tag to our text group. So let's write some new code here. So we're going to do string H2, we'll call this text groups, is equal to, and it's going to be now left parentheses, the H2 tag, the right parentheses, so that's our first group. We want another group now, it's going to be parentheses dot plus question mark, parentheses, and then our closing tag, which is going to be parentheses and a closing H2 tag. Close that up with the parentheses as well. So we've actually got 3 groups defined there now. Then we'll do pattern H2 text pattern is equal to pattern.compile. That's going to be our H2 text groups. Then we want a matcher. H2 text matcher is equal to H2 text pattern dot matcher. And we're matching on HTML text still, the original HTML text we've defined. And then we just do our while loop. It's just going to be pretty much the same as the other one. So it's going to be H2 text matcher dot find. We're going to print out the occurrence H2 text matcher dot group, but we're going to actually output group 2 here. So remembering, we're trying to extract the text between the tags and not the tags themselves. So we've defined 3 groups on line 88. We're looking for a pattern that matches H2 dot plus question mark and then the closing H2 tag. So we want the H2 part of the match to be assigned to group 1, remembering that group 0 is the entire pattern, and the dot plus question mark part of the match, that should be assigned to group 2, and then the closing H2 tag part of the match should be assigned to group 3. So you can see that in the while loop, I've written out the parts that are assigned to group 2, and that should correspond to the H2 text, in other words, the text between the H2 tag and the closing H2 tag. So let's run this just to confirm that it works. And you can see we've got subheading and summary outputting, which is the text between the opening and closing H2 tags, so that's working nicely. Now you can actually also use matches to find and replace parts of a string using the replace first and replace all methods. Now for more information about other methods in the matcher class and what you can do with them, I suggest you refer to the matcher documentation, and I'll just bring that link up for you. Very useful information on this link on Oracle's website. Lots of good information there about matches, so make sure you do check that out and read up on it to see what else you can actually do with this class. Alright, so I'm going to finish the video here now. In the next one, we're going to talk about using logical operators when writing regular expressions. See you in the next video. So at the end of the last video, I alluded to the fact that when writing regular expressions, there's a few logical operators we can use. And, or, and not. And it turns out we've already been using the and operator, and that's because it's implicit. So when we write regular expressions, like, for example, I'll just put this in a comment. When we write a regular expression like ABC, it actually means A and B, technically, and C. So in a sense here, and means and followed by. So A is followed by B is followed by C. So let's actually take a look at the or operator. So if you recall a few videos ago, I actually gave the example of a regular expression with capital H, lowercase h, then A-R-R-Y. That would match the case on Harry, whether it's uppercase H or lower, or a lowercase h. So basically the regular expression would match both cases. But we can actually use the or operator to achieve the same results. So we could do something like print out, and we'll start off doing Harry in lowercase, dot, replace all, and we could put, I'll create a regular expression with the left square bracket, capital H, then the pipe character, then lowercase h, n square bracket, then A-R-R-Y, and let's just say we wanted to replace that with the word Larry. So we could run that, and that should actually convert that to Larry. You can see it's converted to Larry because it's replaced the first H, so we can also just take a copy of that and then just convert the first letter to an uppercase H just to confirm that the or is working in both scenarios. And you can see it's working there as well. So basically what we're saying here is that if the H, or the character is a H, capital H, or a lowercase h, consider it a match. And again, as you saw that it converted, what actually worked, it matched the regular expression for both. Harry with a capital H and Harry with a lowercase h. Now, we've actually already seen how to use not when working with a set of characters. So for example, the regular expression, square bracket, then a caret, ABC, square bracket. So the caret character here means not when it's the first character within square braces. Now this regular expression matches all characters except A, B and C. So that's one version of not, but there's also another not operator, and that's the exclamation mark character, but this character has to be used in what's called a negative look-ahead expression. So let's look at an example of that. We're going to start off assuming we've got a string called TV test. And I'm going to assign that TSTV TKT. So what we want to do is find all T's that aren't followed by V. So our first attempt at a regular expression might be something like string T not V reg expression. Set that equal to, so it's going to be T, then left square bracket, caret, V, right square bracket, like so. Then we could do pattern, and we'll say T not V pattern equals, and it's pattern.compile, our T not regular expression. Then we'll do a matcher, T not V matcher is equal to T not V pattern dot matcher TV test. And then we'll do a count equals 0 while T not V matcher dot find count plus plus. Then we'll do something like print out occurrence plus count plus colon plus T not V matcher dot start plus 2 plus T not V matcher dot end. So that's our first attempt. So we're using a regular expression that says we want to match occurrences of T that aren't followed by the character V. Now there should be 3 occurrences, TS, TK, and also the final T in the string that isn't followed by anything. So if we actually run this, let's see what it does. So you can see we've got 2 scenarios covered here. We've got occurrence 1, which is the characters 0 to 2, and occurrence 2, which is the characters 4 to 6. So the first 2 occurrences were found, but the third one, the final T, wasn't. And there's a reason for that, and that's because when we use the caret in square brackets regular expression, we actually match a character, or we must match a character in order for the regular expression to match. So we're saying that the T must be followed by any character other than V. But in this case, there's no character following the final T, and so our caret V in square brackets doesn't actually match anything. So another way of saying this is that the left square bracket caret expression, right square bracket, consumes a character. So in other words, it requires a character to be there. So instead of using the square bracket version of caret, we can actually use the not operator, which is the exclamation mark in a negative look ahead expression. Now, a look ahead doesn't consume characters. It can actually match nothing. So let's go ahead and change our regular expression as follows. So instead of where it is at the moment with T, left square bracket, caret V, and then a right square bracket, we can actually use this negative look ahead expression. So to do that, I'm going to take a copy of this so we've got the original version. I'm going to duplicate that line, and I'll comment that out. And the regular expression we're going to use will be T still, but this time we're going to use parentheses here. So parentheses, question mark, then our negative operator, and then a V, then right parentheses. So what we're saying here is we want T that isn't followed by a V. Now the question mark inside the parentheses is part of the look ahead syntax. And the look aheads always start with a left parentheses and a question mark. Now the not operator, the exclamation mark here, doesn't consume a character, so it will match instances of T at the end of a string. So if we run this now, we should actually get 3 lines of output from our occurrences, and we should get the final matching T as well as a result. And you can see we've got the third one showing there as well. So all 3 occurrences have now been found. Now note that when we use a look ahead, the characters in the look ahead aren't part of the match. And also note that the indices indicate that our matches are 1 character in length, and if you recall that the end method returns the index after the match. So they're no longer matching the T followed by another character, in other words. Now once again, look aheads don't consume the characters they match, or putting it another way, they don't actually include the characters they match in the matched text. So that's negative look ahead expressions, but we can also use positive look aheads using the equal sign rather than the not operator, which was the exclamation mark. So if we wanted to find all matches of T followed by V, but we didn't want to include the V in the match, we'd use a regular expression like so. We'd do the regular expression here would be T, left parentheses, the question mark, equal V, then the right parentheses. So that's the positive look ahead. And again, that's if we want to find all matches of T followed by V, but we didn't want to include the V in the match. Alright, so before we leave the subject of regular expressions, let's look at a couple of real-world examples. Now, regular expressions are often used to validate user input. Now, here's an example, which I'm going to copy and paste, that has or is a regular expression to validate a US phone number. So I'm just going to put that into a comment for now, just so you can get a look at it. Now, let's actually have a look at what this does. Now, obviously, we know that it's validating a US phone number, but it starts out by indicating that the line has to start with the entire pattern. In other words, if anything occurs before this pattern in the string, then it's not a phone number. So next, in this version, we're expecting the area code to be within parentheses. So the first character we expect is the open parentheses. So we have to escape it, and that's because, as we've seen, the parentheses is a character class used to indicate a group. Now in this case, we want to match the parentheses character literal. And when we want to match a character literal that can also be used as a character class in a regular expression, we have to escape it in this way. So following the parentheses is a quantifier indicating that there should only be one opening parentheses. So moving on. Next, we expect the area code, which will be 3 numbers between 0 and 9 inclusive. And again, we're using a quantifier after the range of characters to specify how many numbers we actually expect for a match. So following that, we expect the closing parentheses. Then, we want to see a blank before we see the rest of the phone number, and we only want to see one blank. Moving on, we expect 3 numbers from 0 to 9 inclusive, followed by a dash, followed by 4 numbers between 0 and 9 inclusive. And finally, we expect the string to end with the entire pattern, which means that if anything follows the phone number, the regular expression won't match. So now that we've seen that, let's actually try this out. So we're going to type in a few examples here. So string phone 1 equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Now based on that regular expression, that shouldn't match. So string phone 2 equals, let's try another one. We'll try 1, 2, 3 in parentheses, space, 4, 5, 6, dash, 7, 8, 9, 0. Well, that should match because we're using the right format for the phone number. Phone 3, we'll do a couple more, equals 1, 2, 3, space, 4, 5, 6, 7, 8, 9, 0. That one shouldn't match because we haven't got parentheses around the area code. And the last one, phone 4, equals 1, 2, 3 in parentheses, but no space, 4, 5, 6, 7, 8, 9, 0. So obviously that shouldn't match either because we haven't got a space after the area code right parentheses. So let's actually try this out. So we're going to do system.out.println and we'll put phone 1 equals plus phone 1. And we can use dot matches because we're actually matching the entire string. And we'll just paste shortly the regular expression into there. And I'll just do the same thing for the other 3. 2, 3, 4 here. And phone 4, 3, 2. And we'll just come back up to here. And we'll take a copy of our entire regular expression. And we'll just literally just paste this in here, the same one for all 4. Alright, so let's just try running that. And we can see phone 1 is false, and the reason that's false, of course, is it hasn't got parentheses, hasn't got a space, and hasn't got a dash between the first part of the number and the second part. Phone 2 is true, so that matches because it fulfills the regular expression. Phone 3 doesn't match because it hasn't got parentheses around the area code. And phone 4 doesn't match because it hasn't got a space after the right parentheses just before the start of the phone number. Now, there are many ways to write a regular expression that matches a phone number. For example, we might not expect parentheses around the area code. In a real-world application, we'd probably remove punctuation and white space from the phone number before processing it. And we might require the country code. But these are details that would depend on a specific case. Another example of a regular expression would be checking for a Visa card. So Visa credit card numbers start with a 4. Newer cards have 16 numbers, but older cards have 13. So the regular expression, I'll just copy and paste, to validate a Visa number would be like so. Now we start by using the beginning of line character class, just as we did for the phone number. Then we expect the character 4, and that's because I mentioned that all Visa card numbers start with a 4. Following the 4, we expect at least 12 numbers. Next comes the optional 3 characters that occur in the newer cards, which we've put into a group and followed with the question mark at the end, which will match 0 or more occurrences of the group, which is what we want here. Now, there will be 0 occurrences of the final 3 numbers for older card numbers and 1 occurrence for newer card numbers, hence the reason we're using a group. Finally, there's the $boundary matcher, which means that if anything occurs after this pattern, then there's no match. So let's actually try this with a few sample numbers. And what I'm going to do, just to save a bit of time here, is I'm just going to copy this block of code in. The video is getting quite long. And I'll just paste that in. And I've got 4 examples here. You can see the first 2 shouldn't match. The last one shouldn't match either. And the third one is the one that's the right length should match. And obviously the first one as well, it was 13. That should match as well. So basically we've got 2 here that should match. The other two, visa 2, shouldn't match because it starts with a 5, and visa start with a 4, and visa 4 shouldn't match because it's only 4 digits. So let's actually just run that and confirm. And you can see visa 1 and visa 3 match, as they should, and visa 2 and visa 4 don't for the reasons that I've just outlined. Now note that this isn't a comprehensive check for a valid visa card number. Some 13 and 16 digit strings would match this regular expression but fail other steps required to validate a card number. Alright, so that's it for our whirlwind tour of regular expressions. I hope you've got a lot out of this. So in the next video we'll actually start looking at the challenge for this. So I'll see you in the next video. Alright, so now it's time to practice what we've learnt about writing regular expressions. Now, there's often more than one way to write a regular expression that will match what we want to match, so the answers that I'm providing in this lecture may not always be the only answer. What you should do is verify your answers using string.matches, string.replaceAll, and or matches.matches. And we've been through all of those in the last few videos in this section. Essentially what I'm saying here is if your answer doesn't match the one that I provide, that doesn't mean that you're wrong, that your answer isn't correct. And that's because I can't really provide every possible solution because it's usually the case there are multiple solutions with programming, but especially with regular expressions, there's can be many different answers. All right, so let's go on now and start looking at these challenges. All right, so the first challenge number 1. And that's to write the string literal irregular expression that will match the following string on screen. And you want to use the string.matches method to verify your answer. So pause the video now and see if you can figure that out, and I'll see you when you get back. Alright, so hopefully you managed to get that solution sorted out for that challenge. So let's actually go through and type in the answer. And I've created a new project here, Regular Expressions Challenge, and I'm going to be putting all the challenges in this particular project. Alright, so the answer, we'll print this out, system.out.println, and we'll use a string, but I'll actually type the string in first. So string challenge 1 is equal to I want a bike, as per the slide. So to match that, pretty simple for this first one at least, challenge 1 dot matches I want a bike. So we're just using the string. We want to match us the regular expression. So obviously when we run that, we should get a true, indicating that there is a match. And you can see that there is a match there. And I'll just move this down to the bottom. All right, so that's the first challenge. The regular expression matches the occurrence of I want a bike. All right, on to the next challenge. Challenge number 2. Your challenge now is to write a regular expression that will match I want a bike and I want a ball. So verify your answer here using the matches method. So pause the video, try that out, and I'll see you when you get back. Alright, so to do that match, to actually match I want a bike and I want a ball, how do we do that? Well, we do something like this. So we do a string regex equals I want a 2 backslashes W plus dot, and then we're going to print that out to make sure it works. Challenge 1 dot matches regular expression. Then we'll also do the second one. We'll actually create a string for that. String challenge 2 is equal to I want a ball, and we'll print that out just to make sure that also matches that one as well. Challenge 2 dot matches regular expression. Alright, and just to, we'll run it first to make sure it works. Obviously always important to make sure it works. We should get 2 more trues there. We've got 3 trues on the screen. Here we're using the \w character class, and if you recall that matches characters A to Z in uppercase, A to Z in lowercase, 0 to 9, and the underscore. So it will actually match one character, so we needed to add that with a quantifier. So I used the plus quantifier, which indicates that we want to match on 1 or more characters before the period. Now notice that we have to escape the character class in the string. That's why there's 2 backslashes there. And there would be another solution here. Another solution would be to use a group. So let's actually look at that one as well. So we could do something there like string reg exp1 equals I want a, then in parentheses bike, the pipe character, ball, right parentheses, and a dot. That would be an alternative way of doing it. We can just do the same there. We can actually just print this out. I'll just copy and paste this, remove the second line there. So let's actually check to see whether that regular expression works. I'll just change the here, regular expression 1, exp1, like so. So let's check that out and make sure that works as well. And you can see we've got true down the left hand side. So what I've used there is a group that's going to match the bike or ball, and I've also made use of the logical OR operator too, as you can see there with that pipe character. Alright, that's 2 challenges down. Let's move on to the next challenge. Challenge number 3. Alright, so in challenge number 2, we use the same regular expression twice. So use the matcher.matches method this time to check for matches instead of string.matches for the regular expression that uses \w+. And as a hint, you will have to compile a pattern here. Alright, so see if you can figure out that challenge. Pause the video and I'll see you when you get back. Okay, so we're trying to this time use the matcher.matches method to check for matches instead of the string.matches which we used previously in this second challenge. Now, what I indicated as a hint here was that we needed to compile a pattern. So we're going to be doing just that. So we're going to use our regular expression again. String reg 3 for challenge 3. We're going to set that to I want a escape it. We're using the \w character, but we're escaping it with another backslash plus dot. Then we're going to create a pattern. Pattern is equal to pattern.compile our regular expression 3 that we just created on the previous line. Then we need a matcher equals pattern.matcher challenge 1. And we'll print that out to make sure it works. Matcher.matches. Then matcher is equal to pattern.matcher challenge 2 this time, and print out matcher.matches. Alright, so we'll just run that to verify that does work. So firstly I compiled a regular expression into a pattern. Then I created a matcher with the challenge 1 string we used previously, and I called the matcher.matches method. And then I did the same thing for the challenge 2 string, except keeping in mind that at that point we don't have to compile our pattern again. We can get a new matcher instance using the same pattern object in our challenge 2 string. And as a result, we don't have to reset the matcher here because we're using different matcher instances with each challenge string, just in case you're wondering. So that's my solution to that challenge anyway. Alright, so on now to challenge 4. Okay, let's moving on. Challenge 4. This challenge is now to replace all occurrences of a blank, like a space, with an underscore for the following string that you can see on the screen. Then you want to print out that resulting string. So you can see the string there is replace all blanks with underscores with spaces. You need to replace those blanks or spaces with an underscore. Alright, so try that out. Pause the video now and I'll see you when you get back. Alright, so how did you go on that one? Hopefully you managed to solve that. So my solution to that one is I'm going to create a new string. So string challenge 4 equals, and that's replace all blanks with underscores, which was the string used in the slide. Now there's actually 2 ways that I've got to do this. First one, we're going to do challenge dot replace all space with an underscore. But the other way of doing it is to use the character class, the \s character class, which will match all white space. Now this would actually be a more broader solution that would work well if you wanted to replace all white space with underscores and not just blanks. So let's do that one as well while we're here. That's going to be printing out challenge 4. Oops, I had challenge 1 on that previous line. Challenge 4 dot replace all. We need to escape it as well, so a \s escaped. Then we're going to replace that with the underscore. Alright, so let's try that and make sure that it works. And you can see we've got the spaces now in both cases there replaced with underscores. So that obviously worked. All right, next challenge. Challenge number 5. This time, the challenge is to write a regular expression that will match the following string in its entirety. And you want to use the string.matches method to verify your answer. All right, so see if you can figure that one out. Pause the video, and again, as always, I'll see you when you get back. All right, so for this challenge 5, there actually are a number of ways of doing this. So I'm actually going to show you a few ways. The first way would be system.out to println challenge. Actually, what we'll do is we'll create the challenge string first. So string challenge 5 is equal to, what I'll do is I'll just copy and paste this. Actually, make it easier. Okay, and we want to do challenge 5 dot matches, and double quotes, and then left square bracket A, B, C, D, E, F, G, then plus outside of the square bracket. So in that case, I'm matching strings that contain one or more of the letters A through G inclusive. Now, we could also have written that with a range, so let's actually do that as well while we're here. It'll be challenge 5 dot matches, and this time square brackets again, A dash G plus outside that. So in both cases, using the star quantifier would also work. I've used the plus quantifier, as you can see there in both cases. Now, these aren't the only regular expressions that would match. There are others, so your answer might be different. So long as it actually works, that's fine, and you've actually succeeded. As long as the matches method returns true, you're essentially correct. So let's actually just run that again just to confirm that this is working. We've got 2 trues there, so that's obviously working as well. All right, next challenge. Challenge number 6. The challenge is to write a regular expression that will only match the challenge 5 string in its entirety. So again, the hint there is only match the challenge 5 string in its entirety. See if you can figure that one out. Pause the video now, and I'll see you when you get back. Okay, so how did you go with that one? Well, here's my answer. And there actually are a couple of ways to solve this, but we'll go through 2. First way, I'm going to do challenge 5 dot matches, and I'm going to do the caret, left curly brace 3, right curly brace, then BC, left curly brace 8, right curly brace, D, left curly brace 3, right curly brace, EF, left curly brace 3, right curly brace, G, and then a dollar on the end. So here I'm using quantifiers to spell out exactly what I want to see. So I've got 3 A's followed by a B, followed by 8 C's, followed by an E, followed by 3 F's, followed by a G, and then I've also made use of the beginning of string and end of string boundary matches because we want the string to match in its entirety and not just part of the string. And let's actually just run that. Now that's returning false because I forgot to put an A in there. Try again. Now we've actually got a true there, so it's actually doing a complete match. Now we can actually also verify the answer here by using replace all. So we can do something like system.out println challenge 5 dot replace all, and I'm just going to copy the regular expression that I typed in on the previous line, its entirety, paste that in. If we run that, we should see the word replaced, and you can see it's been a complete replacement there. That's obviously a good way to verify your answers using replace all. And then just to confirm that that does work, if I then change challenge 5 and put a Z at the start, we should find that we get a false for the challenge 5.matches, and the original string should now not be replaced. And whoops, I need to actually put in the caret at the start as well. Didn't copy that over. So it's an exact copy of the previous regular expression. So now if I run that, you can see the original string was now left untouched, and that's because the complete regular expression wasn't matched because we had a Z character and we've actually specified that the entire string had to match, and consequently the previous line also didn't work because again we actually wanted to do an exact match, a complete match of the entire string. Alright, time for the next challenge. Okay, challenge number 7. So your challenge here is to write a regular expression that's going to match a string that starts with a series of letters. So the letters must be followed by a period. After the period, there must be a series of digits. So the string kjisl.22 would be an example of a string that would match. The string f5.12a is an example of a match or something that wouldn't match. So use this string that I've got on screen, abcd.135, to test your regular expression. So see if you can figure that one out. Pause the video now and I'll see you when you get back. Alright, so let's see if we can solve this challenge. We're going to start by putting our challenge string in. So challenge 7 is equal to abcd.135. That's our test string. And so one answer to this would be print out challenge 7.matches. And the match we're going to be looking for is the caret, start of string, then left square bracket, capital A dash Z, then another square bracket, lowercase a dash Z, then we want a plus, 2 backslashes, dot, because we're escaping a dot character, 2 backslashes D plus, then the dollar sign. Now this one isn't the only way to write this regular expression. If the matches method returns true for whatever you've written, then your regular expression is correct. In the one that I've written above, we start by using the beginning of string boundary matcher, the caret, to ensure that nothing occurs before the pattern. We then look for one or more letters using a range of characters and the plus quantifier. We could have used the case-insensitive modifier and only specified one range. That's one alternative. After the letters, we look for a period. Now since the period character is a character class that matches all characters, I had to escape it when we matched the literal dot, so that's why there's 2 backslashes and a dot. And after that we expect one or more digits. We're using the \D character class followed by a quantifier plus to match that part of the string. Now the star quantifier here would be wrong because that would match strings that look like ABC dot. The strings we want to match must have at least one digit after the period. Finally, we include the dollar boundary matcher at the end of the string to ensure that nothing occurs after this pattern. So let's just run this to make sure it actually does work. And you can see we've got a true there, so it is working. Alright, so let's finish the video here now. We'll continue on with some more challenges for our regular expressions section in the next video. Okay, so on with our challenges. Challenge number 8. Now this challenge is to modify the regular expression from challenge 7 to use a group so that we can print all the digits that occur in a string that contains multiple occurrences of the pattern. So write all the code required to accomplish this, so create a pattern and matcher, etc. And use the following string that you can see on screen to test your code. Now there are 3 occurrences of the pattern we looked at for in challenge 7. When you run your code you should see 135, 7 and 999 printed to the console. So see how you go with that one. Pause the video and I'll see you when you get back. Alright, so on to the solution for challenge 8. Firstly, I'm going to create the string. So challenge 8 is equal to, that's abcd.135 uvqz.7 tzik, and we'll finish with a 999. So that's our test string. Now, in terms of the answer, we start with a pattern. Pattern 8 equals pattern.compile, and it'll be challenge 8. Then we need a matcher, which will be matcher 8 as well, equals pattern8.matcher for challenge 8. And of course I made a typo there. The actual pattern is going to be the important thing which we're going to enter shortly, which will be our regular expression. And then we'll put while matcher8.find, and we'll print out occurrence plus matcher8.group. And group 1 is going to be output All right, and then the actual regular expression, which is obviously the important part, is going to be left square bracket, A-Z, uppercase, and then also a lower version, A-Z. The note in the previous video, in the previous section, I used two groups separated by the square brackets, but you can do that all in one like I've done here as well. Then a plus, backslash, backslash, dot. This time we're going to change it to a group, so it's going to be left parentheses, backslash, backslash, D plus, right parentheses, and that should be it. So we're now interested in matching parts of the string rather than the string as a whole, and you'll notice that I've removed the caret and dollar boundary matches from the previous challenge's regular expression. Now we're obviously interested in printing the numbers part of the pattern, and so I've put the part of the pattern that matches the digits into a group by surrounding that part of the regular expression with parentheses. And I compile our regular expressions into a pattern and create a matcher using that string. I'm then looping over the matches using the find method. For each match, we're printing out group 1, which will be the digits group, remembering that group 0 is always the entire string. So let's just run this and see that it actually works. So you can see we've got our 3 occurrences, 135, which is from this group here, 7, which is from the next group, and the last one, 999. All right, on to the next challenge. All right, challenge number 9. Let's suppose that we're reading strings that have to match the patterns we used in challenges 7 and 8 from a file. So tabs are used to separate the matches with one exception. The last match is followed by a new line. So that's your challenge, is to solve this, and the revised challenge 8 string is going to look like you see on the screen there now. So basically the challenge is to revise the regular expression accordingly and extract all the numbers as we did in challenge 8. See how you go with that one. Pause the video now and I'll see you when you get back. Alright, so how do we do that one? We're going to start by putting pattern 9 equals pattern.compile, and we'll fill that in shortly. Then we want a matcher, and we'll make them a matcher 9 is equal to pattern9.matcher, and it's going to be our challenge 9, which I haven't written yet, which we'll be doing that shortly. And we want to put our while in again. So we'll put a while, let's just copy that code there. While matcher 9 dot find, we'll print out matcher 9, and we're still going to be printing out group 1. Alright, so our string, challenge 9, is going to be equal to, that's ABCD. Let's just copy this because it's pretty similar to this one in challenge 8. The only difference, the real difference here, well, firstly, is a carriage return on the end, so it's a \n, but we've also got a tab character being used. The tab characters are used after the numbers. So the first time, after 135, there's a tab in there. We'll put a /t there, \t. And after the 7, there's also another tab as well, remembering that the last match is followed by a new line instead of a tab character. Alright, so that's our challenge. So the actual regular expression would be left square brackets A-Z, that's the capitalized versions, then lowercase versions, A-Z, plus \\, dot to match the dot. Then we need to create a group, and within the group with parentheses there's 2 backslashes D plus, and then D should be lowercase. End the group with the right parentheses, and then we want to put \\, S on the end of that. So basically all we're really doing here is updating the regular expression to use the character class \s, which is going to catch the whitespace character that occurs after each occurrence of letters, periods, digits. So both tab and the new line are considered whitespace. So I know I typed it all in to make it look like harder than what it was, but it's really quite a simple solution, as you can see. So let's actually run that, though, importantly, to check that this does work. And I need to change this while, didn't I? For some reason I didn't change that. I thought I changed that. Matcher 9, that should be. Okay, because that's obviously the one that we're working on. Let's try running it. And we've still got our 3 matches, so obviously that's working well, which is excellent. Alright, so let's move on to the next challenge. Hitting double figures, challenge number 10. Alright, so instead of printing out the numbers themselves, print out their start and end indices. So use the same string we used for challenge 9 here. You want to make those indices inclusive. So for example, the start index printed for 135 should be 5 and the end index should be 7. And as a hint here, you'll need to look at the documentation for the matcher.start and matcher.end methods. And there's more than one version of these methods as well. You can see the link to the documentation for the matcher class, and there's also a link in the video. So pause the video now and try that out, and when you're ready to see my solution, come back. So I'll see you when you get back. Okay, so solution for challenge 10. Now this is a tricky challenge for a couple of reasons. First of all, we have to use the versions of the start and end methods that accept a group number because we're interested in the indices of the group matches, not the pattern matches as a whole. Second, the end method returns the first index after the match ends. So to get the index of the final matching character, we have to subtract 1 from the end method return value. So let's actually try typing this in and see if we can get it to work. What I'm going to do is just take a copy of challenge 9 and just change it. So challenge 10 here hasn't changed, and the pattern won't change either. And matcher 10 here is going to be equal to pattern 10 matcher, and it's while matcher 10.find. And to print out the occurrence, this is going to be the bit that's changed. Occurrence plus it's going to be matcher 10.start 1 plus end equals plus matcher 10.end 1 in parentheses take 1. Alright, so let's try running this first. And you can see we've got the output there for the first occurrence, start equals 5, end equals 7. The second occurrence, 14, end is 14 is the start. I didn't actually put in the word start there. I should probably do that, shouldn't I? Let's just do that and run it again. So I've got start equals 5, end equals 7, start equals 14, end equals 14, and then the third one, start equals 21, end equals 23. So that's challenge 10. So let's now move on to the next challenge. Challenge number 11. So suppose we have the following string containing points on a graph within curly braces. Your challenge is to extract what's in the curly braces only. So see if you can figure that one out. Pause the video now and I'll see you when you get back. Okay, so what we're looking for, string challenge 11 is equal to, and remember we had values in curly braces, so we're 02, comma, we'll try 0, comma 5, comma, and again I'm putting these in curly braces, 1, comma 3, and the last one, 2, comma 4. And incidentally, the previous challenge worked. You might be wondering, this hasn't been used because I accidentally left challenge 9 in there as the pattern matcher, but because we didn't actually change the pattern, it actually worked. So if we run that again, we get the same result. So more or less a bit of luck there that we happen to use the same challenge string for both challenges. All right, so moving on to challenge for finishing challenge 11. So we need a pattern now. So pattern 11 is equal to pattern.compile, and we'll get back to that shortly. We'll actually add that, and then we want a matcher 11. We'll set that equal to, it'll be pattern11.matcher. And it's going to be our challenge 11 string. Then we're going to do the same thing there with the while matcher 11.find. We're going to print out the occurrence plus matcher 11.group 1. Alright, so the actual pattern here is going to be backslash, backslash, left curly brace, left parentheses, dot, plus, question mark, right parentheses, backslash, backslash, and then the right curly brace. So here what we're saying is we want anything inside the curly braces to match. Now since the opening and closing curly braces characters are used in regular expressions with quantifiers, I've escaped them when we want to match the literal characters. That's why there's a \\/ before the left curly brace and the same for the right curly brace. Remember to put the contents of the curly braces into a group by using parentheses, as I've done, and I've used +.?mark to get the contents of the braces. Now the plus matches any character, the dot or period matches any character, the plus says that we expect at least one character, and the question mark turns the plus quantifier into a lazy quantifier, and it prevents it from matching more characters than we want essentially. So it will actually limit the match to the content of the curly braces. And if we were to remove the question mark quantifier, there'd only be one match because the plus quantifier would gobble up everything between the first opening brace and the last closing brace. So when we run this, we should get 4 occurrences. And you can see we've got 4 occurrences showing there, 0 and 2, 0, 5, 1 and 3, and 2 and 4, which is the contents for these 4 curly braces. All right, so that worked fine if we know that our data only contains points within curly braces. But if we want to be more precise and only match a digit, followed by a comma and space, followed by digits, we could do something like this. Let's go ahead and change that. So I'm actually going to take a copy of this and call this one a challenge at 11A. Okay, so the difference is here. Let's actually add some more content to our challenge 11A. So we're going to actually add some invalid input as well. So we're going to try x, y, 2, 4, 4, and also 11, 12. All right. So we need to change our regular expression to cope with that. So I'm going to just delete and type it in again. \\/ left curly brace. Then we want our parentheses. \\/ d plus, comma, space. \\/ d plus, right parentheses. Then we finally escape the last right curly brace. \\/ then the right curly brace. So I'm using the \d character class followed by the plus quantifier to indicate that we want more than one or more digits, followed by a comma, followed by a space, followed by 1 or more digits. And you saw that I also modified the test string by adding x, y, and 11, 12 into the mix. So when we run, we should see only the numerics that are part within those curly braces. Let's just run that. And perhaps confusingly, I've actually put 2.4 in twice there. So let's put another different number in there. Something that we're not using is 634. And the other thing I'll do is I'll just put a bit of a separator here. Let's just run that again. So you can see we've got 02, 05, 13, 24. It skipped x and y because it doesn't match the regular expression. Then we go to 634, then 11, 12. All right, so that's obviously working. We didn't see the XY pair printed to the console. And just as a final thought, if we wanted to extract only the digits without the comma and space, we'd actually put each set of digits into its own group. All right, we've got 3 challenges left. Let's work on those last 3 in the next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
All right, so let's move on to the next challenge. Challenge number 12. So the challenge here is to write a regular expression that will match a 5-digit US zip code. So use 11111 as your test string. So figure that one out, pause the video, and come back when you're ready to go through my solution. Pause the video now. All right, challenge 12. How do we actually do this? So we're going to put in our test string, which is going to be string challenge 12, 11111, 5-digit code. So the challenge is actually quite simple. It's going to be challenge will be challenge 12 dot matches. Then we're going to start with our caret \\/ d 5 in curly braces and $1. So we wanted to use the start and end boundary matches because we want the entire string to match. And we use the \d character class, which will match any digit. And then I use a quantifier to specify that I wanted 5 digits. So let's check that it actually works. And we've got a true there showing that it does work. All right, next challenge. Challenge number 13. So US zip codes can be followed by a dash and another 4 numbers. So write a regular expression that will match those zip codes. So use 11111-1111 as the test string. So see if you can figure that one out. Pause the video now and I'll see you when you get back. Okay, so challenge 13. So we'll enter our string firstly. So string challenge 13 is equal to 11111-1111. And the solution will be challenge 13.matches, and a regular expression will be a caret, \d, 5 in curly braces, dash, \d, 4 in curly braces, and then the $sign to finish it off. So this one's fairly straightforward. We're just adding a dash after the regular expression for challenge 12, and then we expect 4 digits. So the final part of the expression is essentially the same as the beginning. All we have to do is change the number in the quantifier. Now, if we were trying to verify user input, we could check the length of the input and from there decide which regular expression to use. But ideally, it would be nice to have one regular expression that would match both cases. But let's actually just check to see whether this actually works before we move on to the last challenge. We've got a true there, so that one works. All right, final challenge. Challenge 14. So write a regular expression that will match a 5-digit US zip code and zip codes that contain the optional 4 digits preceded by a dash. So in other words, matching both challenge 12 and challenge 13 in the one regular expression. See how you go with that one. Pause the video now. I'll see you when you get back. Okay, challenge 14. How would we go about actually solving this one? Well, what we can do is we're going to use the challenge 12 and challenge 13 strings that we defined in the previous challenges. So I'll print out firstly challenge 12.matches, and we'll put something in there shortly. We'll also do the same for challenge 13.matches. All right, let's actually add our regular expression. So we're going to do caret \d, we want 5, it's a quantifier in curly braces. Then we want a group, so left parentheses, dash, \d, left curly brace again, 4, right curly brace, end the group with the right parentheses. Then we're going to put the question mark and the $sign. So we're going to do exactly the same for the challenge 13 as well. So basically, I've actually modified the expression by enclosing the optional part, the dash and 4 numbers, within a group, and following the group with the question mark modifier, which means that, or quantifier I should say, which means that there can be 0 or 1 occurrences of the group. Now we wouldn't want to use the plus or star quantifiers in this case, because then we'd match strings like 1111-1111-1111. So if we run this now, we should find that both postcodes now match this. You can see we've got true for both there. And whenever you would need to write a regular expression that matches a piece of data like a zip code, telephone number, email address, etc., we can usually find regular expressions that solve these problems on the web. But my suggestion here is to be careful, and that's because there's a lot of variations and in some cases much debate about which one is correct. Also, the regular expressions can be wrong or incomplete. For example, if you do a search, you can actually find this regular expression for a Canadian postcode. I'm just going to paste it in because we're not going to produce any code. So that's the example there. This regular expression expects a letter, followed by digit, followed by letter. Then there will optionally be a blank or a dash, and then a number, followed by a letter, followed by a number. Now this matches postcodes like M1A space 1M1. But here the regular expression is wrong because Canadian postcodes can't contain certain letters and they generally aren't written using a dash, although that's not strictly wrong. The point here is to remember that not everything you see on the internet is true, especially with regular expressions. Alright, so that concludes our regular expression challenge and actually this section of the course. Regular expressions can be challenging and to write and decipher, but you'll get the hang of it with practice, practice, practice. So I hope you've enjoyed this section. Time to move on to the next one now. So it really would be wonderful if all the code we wrote was bug-free, but the stark reality of it is that that's not the case. When an application crashes or behaves in a way we didn't expect, we have to figure out where the bug occurs in the application code. Fortunately though, we can use a really powerful tool to help us called a debugger. Now, using a debugger, we can see what's happening as the application runs. And we can stop execution at a specific line of code and examine the state of the application. We can change the values of variables on the fly and set watch points to help us understand where we've gone wrong. So in this video, we're going to learn how to use IntelliJ's IDE debugger. Just a few caveats before we begin though. If you want to see what's happening inside a class or method, then we have to have the source code for that class or method. Now, when we're debugging our own application code, of course, that's not a problem, but when we want to see what's happening inside a class that belongs to a third-party library and we haven't got access to the source code, then it's going to make it a lot harder. So in those cases, the best that we'll be able to do is examine what values were passed into a method and what value was returned from a method. So related to that, to use the debugger with a class, the compiled class files must contain debug information. And again, when it comes to our application, that's not a problem, but third-party class files don't usually contain debug information. But with that said, some libraries do offer two versions, one without debug information and one with debug information, which of course would be using the debug version during development. Now, when we're using the debugger, our applications will run slower than it usually does because of the extra processing that has to take place back in the debugger. And because of that, using a debugger to track down a threading issue, for example, can sometimes be challenging. The debugger can mask threading issues because the timing of the application isn't the same when it's running in debug mode. Okay, so with those caveats out of the way, let's actually go ahead now and see the IntelliJ debugger in action. So I'm going to go ahead and create a new class, and let's call this one debugger demo. Do as we normally do when we create a new project. So debugger demo. Okay, finish. Okay. All right, so let's start running some code. So I'm going to start by typing string utilities, utils, equals new string utilities. And as you can probably guess, we're going to write that method. Then we want string builder SB equals new string builder. And while SB.length is less than 10, then we're going to do utils.addChar SB, comma, and the letter A. Single quotes, because it's a char. And then at the end, we're just going to print out the value of SB. Alright, so I'm going to create a new class, new Java class. We'll call this one string utilities, of course. String utilities. Okay, and this class is going to be pretty straightforward. It's going to have a private string builder, private instance variable, which we'll call it sbuilder, equals new string utilities, a string builder rather, to initialize it. We also want another instance variable, okay, so private int chars added, and we'll initialize that to 0. Then we want this public method, public void add char string builder sbuilder and char c. Then we're going to do this dot sbuilder dot append c, then chars added plus plus. Alright, now if you've spotted the bug in the code, good though, but if not, stay tuned. So going back to our main method now. So now you can hopefully understand that code that we've just put in there in the main method. So we're first creating an instance of the string utilities class, and then we also create an instance of the string builder class. Then we're calling the string utilities.addChar method to add a single letter, an a char, to the string builder until the length of the string builder reaches 10. Of course, we could use the string builder.append method directly, but that's what we're doing in the addChar method. The method also counts how many characters it's added to string builder over the application's run. Alright, so it all looks pretty straightforward. So let's actually run the application. Now, when we do run it, you can see that it's now running. It seems to be hanging because it's still actually running over here. Then we actually get this error. And I'll just move this down so we can see it a bit easier. And we've got an out of memory error. So why has that actually happened? Well, let's use the debugger to find out what's going on. Now, running the debugger inside IntelliJ is actually very easy. So instead of actually running up here, this little regular button that we click when we're running, we click on this little debug icon. It looks a little bit like a green ladybug without the spots. We can also, where we would normally run, we can click on debug instead, debug main, and we can also use those shortcuts as you can see over to the right of it. So if I actually click on debug now and run it, you can see that it starts and it looks a little bit different, and then it crashes out. So there's a couple of lines that you saw there about sockets being printed to the console, but otherwise our application will run as it did before. And when debugging, a socket is opened because the debugger attaches to the application and communicates with the application using that socket. So if we want to see what's happening inside our application, we need the application to stop running or suspend at some point so that we can examine its state. Now we tell the debugger where we want the application to suspend by setting what's called a breakpoint. So the first step is to decide where we want to set the breakpoint. We can set more than one, but let's just start off with a single one. Now taking a look at the code in the main method here, we suspect that there may well be a problem with this call to the addChar method from the string utilities class. So that's where we want to set a breakpoint, because we want to see what happens when that addChar method is executing. So that being the case, let's go and open our string utilities class. We're going to put a breakpoint in this addChar method in the string utilities class. So we're going to place the cursor on the first line of the addChar method, which here in my case is on line 11, and we're going to set a breakpoint. Now there are several ways that we can set a breakpoint. So we can come over here, we can click on in here, this left gutter here. I can click on there and I can click it and it'll toggle on or off. I can also go to the run window and click on toggle line breakpoint. And there's also a shortcut here that we can also use to do the same thing. You can see that I'm on a Mac, so the command for me is Command F8 to set the line breakpoint. On a Windows machine, it would be Control F8. So I can do Command F8 on a Mac. We can turn the breakpoint on or off. And again, you can see that this little red circle appears no matter which method we use, which is our indication that the breakpoint's been set. And again, we can toggle that, as I showed you, by just clicking on the same option that you just selected to turn the breakpoint on again. Now just remember that the cursor always has to be on the line of code though, where we want to set or remove the breakpoint. Alright, so I've set a breakpoint now on this first line, this line 11, which is the first line of the addChar method. So now we're going to run the debugger again. This time I can come over here and just click on the little ladybug or the debug icon. Now this time notice we've got a different behavior than what actually happened last time. It seems to pause the application at a certain place. So basically by setting a breakpoint, when the Java runtime reaches that line of code where we set the breakpoint, the application will suspend. Now the IntelliJ editor, as you can see, is highlighting the line of code where the application is currently suspended. You can see this highlighted in my case in blue. And remember that we can have more than one breakpoint, which is why that's really handy. And also down the bottom here, we've noticed that you can notice that a debugger tab is opened in the same area as the console normally is. This is assuming you're using the default UI configuration. But let's actually come up here and start with what's in the editor. So when an application suspends at a breakpoint, keep in mind that the line of code has not been executed yet. In this case, we've entered the method, the addChar method, but we've paused before the string, the this.sBuilder.append line method has been called. And this is actually quite an important point to remember. Breakpoints cause the application to suspend before the line of code has been executed. But it isn't always the case that when the application suspends, the highlighted line of code hasn't been executed yet. It will actually depend on the context. For breakpoints, though, it has not been executed, as we mentioned. And we'll see an example of when it has been executed a little bit later. But notice now that the red circle contains what looks maybe like a little check mark. So it's changed from what was just a red circle without anything in the middle to a little like check or a tick or something along those lines. And that's actually indicating that the debugger is live. And over here to the right of the actual line that it's processing, you can see in my case in yellow, we can see where it says sBuilder : then 2 double quotes. Then we've got a C : then the A, like an A char, and then a number 97. So what this is doing is telling us the current values of the parameters we passed to this method. Now the sBuilder variable is empty, and the C variable contains the value A in double quotes, and incidentally the ASCII code for A is 97, so that's what that 97's for. Now these at the moment are the expected values that should be occurring when we made a call to that method. And since this is the first iteration of the while loop in the main method, the string builder is empty, and again we've passed A as the second parameter. Right, so now let's look down here in the debug tab. And there's two sections there. You can see there's frames over here, and there's also variables. Now the frame section over here to the left shows the execution stack trace. So each time a method is called, a frame is added to that stack trace. Now in this case there are 2 frames on the stack. The first method called is at the bottom down here, which is the main method, which was called by the Java runtime. The main method then called the addChar method from our string utilities class, and that's this next frame which is currently highlighted in blue. So that's also the top frame, which means that it's the method that's currently executing. Now the drop down here above the stack trace shows all the threads that are executing and their states. And to see the stack trace for another thread, we just have to select it from the drop down. Now this can be useful when you're trying to debug a multi-threaded application. Even more conveniently, we can even add a threads pane to the frame area by pressing the Restore Thread View button. And that's located over here to the right of the pane, the bottom pane's toolbar. We can click on this, and that gives us another little pane there, the threads, which is again very useful when you're debugging threaded applications. And you can just click on this little arrow here to close that down at any time, and you come back over and open it at any time you want to. Now in terms of this drop down, once we've clicked it, we can actually use the up and down arrows to move through the stack trace, which is an interesting idea. So move up and down here like so. But then we can also here, in the actual stack trace, we can also use our arrows to go up and down as well. And you can see as I'm doing that, the actual editor is changing to the context that's relevant for that particular method. So the first case down the bottom, there's our main method. And you can see a light blue line on light blue hot background color for line 9, telling us that was the line that was being called. And if I move the down arrow up, the up arrow I should say, we get to the addChar method, and that's it's a more striking blue background, telling us that that is the currently executing line, or the line that is to be executed when we continue. And notice also here to the right that as I'm selecting those, again I can use arrows or I can just click, the actual variables update to show the values of all the live variables available to that selected frame. So it shows instance variables, the method parameters, and also any local variables that have been declared before the suspension point. You can see there that we're getting different values than in this case with the main method, or the main frame. It would be probably more correct to be calling it that. So you can see at this point we've got the variables that are relevant and available for the main method. But if we click back again to the addChar method, we see the variables the char's added method knows about, which includes the instance or fields, the instance variables or fields for the string utilities class. So to actually see those instance variables though, for a particular class, if there are any, we have to expand the this item. So I can open that up, and you can see that we've got now a list of the instance variables for this particular class. So we can see the sBuilder instance variable there. Now, since it's an instance of the string builder class, we can actually expand that further by opening here and actually seeing the values. So we're actually seeing now the instance variables that belong to the string builder itself. And we can see here in the string builder value variable is a char16 array over here, and all its elements are currently 0. You can expand that out to see that, and you can see at the moment we've got nothing in there, which is consistent with the fact that it hasn't been used at this point in time. And also, if I just put that back again, the count variable, again this is for the string builder class itself, is also set to 0. But again, that's because we haven't added anything to it, and that would make sense. Notice also that the chars added is shown under this, but it's also shown on its own line further down. So it's shown outside of this as a convenience because it's used in the method in which we're currently suspended. Now, if more instance variables were used within the method, they'd also appear here as well. Now, we'll see later that we can also use watches to make seeing some values more convenient. Now, below the this, I'll close it off for now, we can also see the two parameters that were added to the add char method, or part of the add char method. Now, IntelliJ marks parameters with a P, as you can see here, to indicate that they're actually parameters, and it's like an orange circle with a P in there. Now, one of the parameters has the same name as the instance variable, and at this point again, if we open that up, you might actually get more of a clue into the bug if you haven't already. But let's just pretend that we haven't had our morning coffee or tea and that we're not cluing into anything just yet. And just finally, before I finish this video, there's also, after these parameters, these two items marked with glasses. Now, these are watches that IntelliJ automatically sets, but we'll get back to those later. Ignore those for now. The point is, though, that right now the variables all have the values that we expect. Now, both the instance string builder and the one we passed as a parameter have a length of 0, and the parameter character is A. Now, if you haven't figured out the bug at this point, we probably want to see what happens when we run the line of code that appends the character to the string builder. So we want to take a look at the values of the variables after the append has taken place. So we want the application to suspend again after executing that one line, that append. Now, I guess we could set a breakpoint on that next line, and that would work in this case, but you can imagine that if you were debugging a long method and you wanted to suspend execution after every line, or in other words, we want to step through the method, having to set a breakpoint on every line would quickly become tedious. Now, fortunately, the debugger provides us ways, or other ways, to control the execution of our application, and in the next video we'll start going through looking at these and actually figuring out what some of these buttons up here are here in the debug pane and putting them to use. So I'll see you in the next video. Alright, so continuing on, as I mentioned in the last video, fortunately the debugger does allow us, or provides us with other ways to control the execution of the application. So we don't actually have to add a breakpoint on each and every line. Now, we actually do so controlling this flow of execution by the buttons on the toolbar that are actually above the frames and variables area down here next to the debugger and console tabs. So let's go through what each of these buttons do one by one from left to right. Now, for each button, what we're going to do is we're going to try the button out. We're going to then stop the application using the usual stop button, and we'll then run the debugger again so that the application will suspend at the breakpoint that it started on. Alright, so let's look at this first one, which is the show execution point, which is this one here, and I'm just going to hover over it. Show execution point. So if I actually tap this one, so this returns the editor to where the application was suspended. And it didn't really do much there because I was already actually on that line. But if we flip back to the main.java code for a moment, let's just presume that you're editing another file. Now I come back over here again and click on this button. You can see it's quite handy. It actually takes us back to the current execution line. So it's basically the line corresponding to the current breakpoint. Now, this may seem trivial, but when investigating a bug, you may have actually opened up several different Java source files while the application was suspended, and it saves you from having to flip back through all of them to find the current execution point. So it's just really a shortcut to get back to where that breakpoint is. The next one moving over is now the step over. So this button will advance the execution point by one statement, and it won't show us what's happening inside any methods called by the statement. So I'm just going to close this and run it again. The debug, remembering not the normal run. I need to go back to main. It's probably quicker to do this here then if that's the case. So click on debug. You can see that's the current line. So I'll come over here and look at this step over and come down here and click that. You notice that we've now moved on to the next line. We've moved on to line 12 now. So the application then got that one line of code, the code that was on line 11 got executed, and then we skipped over to the next line onto line 12. Then the application got suspended again. Alright, so we'll take a look at the state later, but let's actually try out the other buttons first. And remembering that each time we do this, we want to close down the app and then run it again, or debug it I should say to be more precise. So this time we want to go over to this next one, and this is different to step over. This is step into. So this step into button will actually step into any methods called by the next statement that's executed. So the application will suspend on the first line of the first called method. Now we use the previous one, the step over, when we don't care about what's happening in any methods called by our code. But we use step into when we want to actually see what's happening inside that method or any methods called by our code. So let's actually press the step into button. Now in this case we can see that the debugger didn't step into the append method. So it behaved much the same as if we'd pressed the step over button. But this actually happened because the stringbuilder.append method is a method of the Java development kit. Now many debuggers, including the IntelliJ debugger, won't suspend within JDK methods because they assume that developers aren't interested in seeing what's happening inside those methods. Now the JDK isn't bug-free, but most of the time it won't be the source of a bug. The situation could also arise when we're dealing with third-party libraries. Now, if you want the debugger to suspend within a JDK method or another method that normally it would skip over, we have to use the force step into button, which is this next one. Now, this button will force the debugger to step into a JDK method and suspend. So let's actually see how that works. I'm going to stop the program and then we're going to debug it again by starting at the debug icon. So this time we're going to click on the force step into, click on that. And you can see here that now we've used force step into, you can see that this time the debugger steps into the append method, and we can actually see the JDK method for the append from the string builder class, the code that is going to be executed. And you use the step out button when we want the debugger to run the rest of the method, return to the caller and suspend. So moving on now to the next button, which is step out. Now we use the step out button when we want the debugger to run the rest of a method to return to the caller and then suspend. So when we try this now, I haven't restarted this time, we click on that. Notice what's happened, it's gone back to the line where we originally got called from the add char method from the string utilities. Now this is a case which I mentioned in the previous video where the highlighted line of code has been executed. So there is a scenario here where it looks like the debugger may or may not have executed. In this case, we have executed because we used the force step into to go into the method, then we use the step out to come back to this method. So at this point in time, the .append has been processed and called. All right, so moving over to the next one. This is the drop frame. Now the drop frame button allows us to effectively time travel into the past. And what I mean by that is that it lets us rewind the application by one frame. Now if we were to rewind the frame here, we'd actually jump back to the main method as if the add char method had never been called. Now the application would be suspended on the line that called the method. But an important note here is we can't rewind everything. And for example, network traffic, database changes, and changes to static and instance variables won't be undone. So only changes to local variables will be reverted. So some developers use it to try out different code paths without having to restart the application. But to be honest, most of us will probably never use it. We'll give it a try just to confirm. And you can see that we've moved back to the main method at this point in time. And it's suspended before the highlighted line of code is executed. And again, we could confirm that by step over, and we've gone back into the method again. And back to drop frame again, and we're back to the main method. Alright, so finally there's this last one over here, which is run to cursor. Now let's say we've got a method that's say 100 lines long, and we suspend it on line 20. And we want to run to say line 55, and then suspend again. Now we could set a breakpoint on line 55, but setting a lot of breakpoints can make future debugging sessions a bit of a pain. And also if we forget to remove them, the application will suspend in places we weren't expecting. So unless we actually think we're going to want to suspend at that line 55 again, it would be better to put our cursor on line 55 and use run to cursor. The application will run, and when it reaches the line where the cursor is located, it will actually suspend. So let's actually put our cursor. So what we'll do is we'll stop it, and we'll run it again, debug it again. So let's put our cursor now on the chars added ++ line. Down here, come over here and click on the run to cursor, and the application is now suspended on that line. Now those buttons are quite convenient, but if you prefer to use menus, we can do all of this from the main menu. So come up into the run menu, as you can see here. We've got step over, force step into, force step into, and there's a couple of other ones there as well. You can see they're pretty much all there, as well as resuming the program as well. We'll be talking more about some of these options shortly. Now what do we do though if we're suspended and we found the bug? So we don't want to step over or into or out, we just want to get out of the debugger. So you can just stop the debug session as we've been doing, but that's not always a good idea. Now for our little application it's fine, but for an application that's perhaps connected to a database, or that's opened a network connection, or has any type of cleanup that it needs to do, it's better to run the application to completion, and we'll do that by pressing on the resume button that's found to the left of the frames area. Down here, resume program will actually run it through to the end. And as long as there's no other breakpoints, that program will then run and complete. And again, in the case over here, there was also the resume program as well. And you can see there's a shortcut there on the Mac at least, Command Option R. So again, if there's no other breakpoints, clicking on this resume option will actually run the program and complete. And if we've set other breakpoints though, the application might suspend again. And that's why it's good to keep breakpoints to a minimum and use run to cursor in most cases. Now it can be easy to accidentally press the run program button when we want to resume the program. Now doing so runs an entirely different instance of the application. So we can get back to the debugger by clicking on down here, which of course is just above the status bar on the IDE's main window. So if you've accidentally run it again, you'd be over here, and you can come back and click on debug to get back to the debugger. Now if you're finding that you've got a lot of breakpoints and you want to get rid of some of them, there's a way to see all breakpoints in our application. So we actually go up here to the run menu and click on view breakpoints down here. You can see that this dialog's opened and shows all the current breakpoints. And in the case of IntelliJ, if you've got it configured for other languages, we're going to be seeing some of the other languages as well, Python exception and so on and so forth. But right at the moment we can see that we've got a breakpoint on string utilities Java line 11. And that's consistent with the breakpoint that we've got there showing on line 11. So from this screen though, the point that I wanted to show you was that you can remove any breakpoints by checking the box next to them. But you can also add breakpoints, but only certain types of breakpoints, because we really have to be able to specify where the breakpoint should go. So we can't set breakpoints on statements within a method using the dialog. So let's actually close that now without changing anything. So I clicked that, but I clicked it again to leave it on. I click on done. But note that we can also get to the view breakpoints dialog, and that's this little button over here. So you click on that, that opens up the same dialog. And I just wanted to reframe that. We come up here, we actually click on rerun. It can be actually easy to do that because it's actually very similar to or very close to the resume program. So keep that in mind, that it can be a common problem, but again, clicking on debug will take you back to that screen if appropriate. Alright, so let's end the video here now. In the next video, we're going to go through a little bit more and start using some of these things that we've learned to debug this app and see if we can fix the problem that's been introduced into the code. So I'll see you in the next video. Okay, so continuing on with our debugging session, let's actually stop the application one last time if we haven't already, and we're going to rerun the debugger again. So I've stopped it, so I'm going to rerun. And let's get to the bottom of this bug and see if we can actually fix it. Alright, so you can see that execution has been suspended on the this.sbuilder.append line. So we're going to now press the step over button and take a look at the state of our application. So I'm going to come down and press the step over button over here. Click it once. And let's see what actually happened. So noticing over here now to the right, the this.sbuilder in the variables pane has now got a value of A. And if we expand the sbuilder in the variables section, we can see that the count has been set to 1. But over here, if we actually expand sbuilder, we can see that the value has been set to 0, is still 0. And also the value of the actual string builder itself hasn't changed, unlike the field version of our sbuilder variable. So in case that's not clear, this tells us now that we're updating the wrong variable. We actually wanted to update the string builder passed to the method, but you can see here we're actually updating the instance variable, and obviously the this dot would give that away as well. Right, so let's step out of the method using the step out button. So we can come over and click on step out again. So we've now suspended after executing the call to add char. We're on the last line here. And we can see the variables here for the add char method. And if I click one more time now, you can see how they disappear now that we've stepped. And we're now back in the main class, in the main method. And we're now seeing the variables for that method. The other thing to note here is now on the left hand side there's only one frame in the frames area now. So if we expand the SB variable here in the variables area, we can see that it's still empty. Now the editor is still also displaying the current value of SB. So hopefully now you understand why our application is running out of memory. So we're appending the character to the string utilities instance variable rather than to the string builder that we're passing to the method. Therefore the loop is never going to terminate, and the string utilities string builder instance will continue to grow until the application runs out of memory. So to fix this bug, pretty simple fix. Go back to string utilities. We're going to actually change this by removing the this. I'll take this opportunity to close these extra Java files down. So we're now going to be updating the variable passed to this method instead of the local instance variable. And if we just go back now and we'll stop this and we'll run it again. And now we'll check the values. So we'll step over again. And you can see now that we've actually got the right values being updated. We've got this we can open up. We now can see that the field for the class is no longer being updated. And in fact, the local, the parameter, the sbuilder variable passed to this method is now being updated. You can see the count is going up as well as the actual value. So that should be that bug fixed. So what we can then do is we can remove the breakpoint by clicking on it here and then coming over and clicking on resume. And we can see that the program is now finished because these buttons have now been dimmed down and no longer available. And we can click on console to see the output. The program finished without any errors and there was no more exceptions. Alright, so let's go back to our debug view again though. I'm going to set the breakpoint again in the same area, the same one on line 11. And I'm going to click on the debug as normal to start it again. I want to talk a bit more now about these variables with the glasses on them. You can see at the moment we've got this one down here, this char's added with the little picture of some glasses there. So at the moment that's the only one there, and that's because we're no longer referencing this.sbuilder within the method. But if you had keen eyes, you probably noticed that in a previous video, and even earlier in this video before we fixed this, that there was two variables there. The class instance field sbuilder was also showing there as well. So these variables with glasses next to them are actually called watches, and they're a feature of the IntelliJ debugger. Now watches always appear in the variables pane and they're updated as the application runs. So let's actually go and step over each statement in the add char method until we're actually suspended on the closing curly brace. So I'm going to step over and do one more. Now we're actually suspended on the curly brace, as you can see, and we can see we've had some values updated here. So char's added has been updated to 1, and if we click on resume, the application will suspend again at the same breakpoint because of the loop in the main method. Now we'll step over to the curly brace again. You see the values updated to 2. So this is a convenient way to watch what's going on with variables of interest. Now it may not seem like much, but that's because we don't have many variables. When we're dealing with a class with a lot of instance variables and we're interested in one or two of them in particular, we'll want to set them as watches. And as we've seen, IntelliJ has set these default ones up for us because we didn't actually set these watches up for ourselves individually. So we're actually interested in seeing what happens to the sBuilder parameter. Now we can see the values easily enough by actually coming down here and clicking on it and having a look like that. But let's just suppose we were interested specifically in sBuilder.count. Now we can expand the sBuilder parameter as you just saw and see the count, but if we want to do this with several fields belonging to, say, different instances, our variables window will quickly become pretty cluttered and full as we're expanding everything out down here. And then we may have to scroll up and down to see all the values that we're interested in. So to avoid this, what we can do is we can make sBuilder.count a watch. So to do so, we're going to just open this up again. And we're going to come over here to count in the variables pane, right click on it, and click on add to watches. You can see up here now, it's actually showing on its own line. And I'm just going to click away from that because I wanted to make a point about the color, which we'll see shortly. So let's go through and step over this again. So I'm going to resume. I'm going to step over. Now, did you notice what happened there to the watch, the sBuilder.count watch that we've just added? And notice how it went blue there when we stepped over that line 11. Now, a watch will turn blue when the last statement executed changed its value. So that's a good thing to know that you can sort of see that when something's updated, it changes to blue. It's a quick update, a quick scan. You can sort of see anything in blue has been updated. Now we can simplify this even further by opening the Watches panel. Now if the panel isn't already open, we're going to open it using the Show Watches in Variables tab toggle, which is down here. So if you see that there, click on that to open it. But once you've done it once, and if you come over here and hide it, you notice that this option doesn't come back here. At that point in the future, it's then available here to click to restore the watches view. So either of those two places will actually show it, but the bottom line is now we've got this separate pane for our watches. Now, depending on how much screen real estate you've got, you might find that either of those options wasn't available to find that little watches pane and be able to click that. So you might see two greater than signs, and you've maybe seen it before in this course when I've had a lot of windows open here at the top. There's a little greater than sign, two greater than signs, and you click on that and it opens up and gives you some other options. So if you can't find it, look for another option in here that you can click, which will open that up and enable you to select that option, the Show Watches in Variables tab toggle option. All right. Now, one thing to note here is that this will only show you watches that you've added yourself, not the ones that are set by IntelliJ. And if you want to hide it again, as you saw, I can click on this little option here to hide it, and you can add it back anytime you want. So if you no longer want to actually watch a variable any longer, you can right-click on it and select Remove Watch. So let's just run this again, and then open this. So again, if I wanted to remove that, just right-click, Remove Watch, and that removes it from that window. And we can hide that again. Okay. Now don't confuse watches with field watch points, which is our next topic. So a field watch point is a type of breakpoint. So let's say we suspect that somewhere in our code, the value of a variable is changing in an unexpected way, and we want to locate the code that's changing the value. So what we can do is we can set a field watch point on that variable. Then whenever the value of the variable is accessed or updated, the application will suspend. Now we can actually create field watch points in two ways. In the editor, we can actually place the cursor in the field declaration and then Alt-click in the gutter. So in other words, if we wanted to know if whenever this child's added was updated, we can come over here, hold down Alt and click to create the breakpoint then, or it's actually, to be more precise, the field watch point. Now notice that that's a little bit different, the icon, to the one we can see there for a regular breakpoint. So that's telling you that this is actually a different type of breakpoint, or it's a watch point in this case. So that's one way of doing it. The other way of doing it is to come up to the Run menu, click on View Breakpoints. And then we want to click on plus here, and then select the Java field watch points. So click on that. And then we can actually specify the name of the class, in this case string utilities, and the name of the variable that we want, say in this case chars added, and click on OK, and that would actually add it when we clicked on OK. But obviously I've done a similar thing with the way that I've clicked into the gutter, so I'm going to cancel out of that. I won't add that for now. Right, so let's try this. I'm going to remove the breakpoint that we've had here on line 11. So just click on that, click that in the gutter to turn it off. And I've set a Java field watch point in the chars added variable, as you can see here on line 8. And I just want to click on it again to show you something here. So I'll click on that again, because there's two different ways of showing this, and depending on which option you select, one will be selected. So I click on this one here on line 8, holding down Alt, and that should work for both a PC and a Mac. Alright, so to take it off, I just click it without holding down Alt, and that turns it off. So going back to our other menu, our Run menu, click on View Breakpoints, click on plus, select Java Field Watchpoint, select the class, String Utilities, and the name of the instance variable, the field, chars added, click on OK, click on OK again. You can see that's added here, and when we're done, we can see that it's added to this area here as well. Now this is the way it's set up with this little dash. This basically means any time that chars added, the field is modified, the program will automatically break. I'm not sure what happened there. I might have accidentally clicked that. So any time that it's actually modified. But what we can do is hold down Alt again and right click here. We get this little menu, and we've got a couple of different options here. So we can actually set the watch to be any time the field is accessed, as opposed to modification. But modification will usually be the one that you're checking, but in any event you can select either. Click on Done. But I also want to show you by coming over here and clicking on Alt and right click again. There's another option here when we click on More, and that will automatically open up the View Breakpoints window with that variable that's been defined. We can also click on here Remove Once Hit, and if we click on that, Remove Once Hit, click on Done, what will happen there is that the first time the variable is accessed, it will break, and then after that point, from that point onwards, it actually won't break. So if we just click on right click that again, we can see now that I've done that, we've got this Remove Once Hit. And my IntelliJ seems to be playing up a little bit, because what should have happened at that point is that we should have seen a little 1 showing there, indicating that it was only going to be a watch point once, and then it would turn itself off automatically. So let's actually just try running this and just see what happens. I'm going to resume. Now see what happened there. I resumed, and it only allowed me to resume once, and then you can see here the program actually finished. So in other words, the watch point came into effect once, and that first time we got a break when that chars added variable was changed, the field for the first time, and from that point on, it then went through and allowed the program to exit. So in some scenarios, you may only want that to happen. You may want to break just the first time a variable value is changed, but there could also be other scenarios where you'd want it to change each time. So we come back and add that breakpoint again, just doing an Alt click again. You see, where it wasn't doing that before, now it's actually working. That's the one that I was trying to show you earlier in the video, and it might be that we have to have debugged it at least once, perhaps for that to happen. But in any event, this is what I wanted to show you. So the one there is going to do that to remove once hit. So if I hold down Alt and right click again, we can see how that's now showing in this menu, where if you go back and check earlier in this video, it wasn't showing. So that's the case where it's only going to show one, or it's only going to break once the variable is changed for the first time. But we can take that off if we want. Click on Done. The little icon changes to that little dash, and the dash means that each time the variable is changed in value, it's going to break. So let's actually test this by debugging this again. So what I'm going to do, you can see the first time we've got a break there, so I'm just going to click on Resume. And I'm clicking on Resume. You can notice how each time I'm clicking on Resume once, it's breaking at that point, and that's because this has been specified to be anywhere in the code where that particular field is changed in value, it's going to break. So that can be really handy if you're trying to figure out how this variable, how this field actually got updated. You know, you might have quite a complex class and you can't figure it out. That's what you do to actually set it up. So again, you can come up here and Alt right click. And notice now that we've actually removed that checkpoint, we can't add it again here from this screen. But we can click on More if we wanted to. Remove once hit. Click on Done. and you'll be able to set it up that way. Probably not a good idea to be doing that during a debugging session, but we'll try working it, and we'll just confirm that it works. And you can see that I clicked once and clicked again, and then the watch point automatically got deactivated. Alright, so again, if you just hold down Alt and click, you get the 1 there, which is what it should have happened. I'm not sure why it didn't happen earlier in the video. And that would be when the value changes once, the program will then break, and we can just confirm that by just debugging and resume. It never asks again, as you can see. Alternatively, I can do an Alt click, and I can do an Alt right click, click on the remove once hit, click on done, and I can debug again, and then I can just resume each time to track any time that the field is actually changed in value. Alright, so what I've shown you is probably the features that you'll use for debugging probably about 99% of the time. There's a lot more we can do, but setting breakpoints and watch points are really what we do the most. But I want to touch on a few more things, so let's start working on those things in the next video. Okay, so as I mentioned, I just want to go through a few other things to do with debugging that you'll probably find useful. So what I'm going to do is turn off this field or watch. We don't need that anymore. And I'm going to just stop the debugger for now. And what we want to do is add a few more methods to the string utilities class. I'm in the string utilities class, and we're going to create another one. So public string upper and prefix string, and we're going to do string upper equals str.toUpperCase, pretty simple method, return prefix underscore plus upper. That's the first method we want to write. And the second one is going to be public string add suffix string str. And then we want to return string plus underscore suffix. Okay, two very simple methods there. And let's go back to our main method to add a bit of code there to actually run that. So string str equals abcdefg. Then we're going to do string result is equal to utils dot upper and prefix. Then utils dot add. I made a typo there, I should probably fix that. Suffix. Add suffix, and it's also going to be str. Alright, so let's set a breakpoint in main on the line containing the call to upper and prefix. So this line here, so I'll set a breakpoint there. And we'll run the debugger. And so far so good. We can see here that the string value is what we expect, A, B, C, D, E, F, G, which is of course the one that's been defined on line 13. But now we want to see what's happening inside the upper and prefix method. So I'm going to press the step into button over here. So click on step into. But instead of stepping into the upper and prefix method, the debugger steps into the add suffix method. That's because it's called first on the line back in the main method. And we can have a look there and see. So I'm going to go back to where we currently paused here. Now obviously in this trivial example it doesn't matter, but if you think that we had a line of code that contains calls to 4 or 5 methods, so imagine a long stream chain for example, and we're interested in only that last method, it can get rather tedious to step inside and out of all the methods, and worse, if we accidentally hit the wrong button, like step over, we then would have to start the debugger again. So let's stop the debugger and run it again. So I'm going to stop it, run it again. So the application is suspended on the upper and prefix statement again. But this time though, instead of pressing step into, we're going to use something that's called smart step into. And this is actually a feature of the IntelliJ debugger. Other debuggers may not actually have this feature. Now there are two ways we can actually tell IntelliJ which method we want to step into. So if you actually press Shift F7, it'll bring up a dialog and you can select which method we want to step into. But we can also go into the Run menu and click on this Smart Step Into. You can see that's Shift F7 on a Mac as well. So click on that and we get this little option showing. So either with the shortcut, the keyboard shortcut, or selecting the option from the Run menu, you get the same option here, which method to step into. So now we can actually select the upper and prefix And once we do that, you can see without doing anything else, it's actually now executed the code in the add suffix and moved to the operand prefix, which is where we actually wanted to check what was going on. The point here is that the debugger just won't suspend the application inside it. Now, of course, the add suffix method will execute first and did execute, but in this case, because we're using this smart step into, the debugger just didn't suspend the application at that point. Now, another thing we can actually do is set variable values on the fly. So let's just say that we've found our bug and it's due to a value being wrong. Now, we can set the value to what we expect to see if the rest of the code then executes correctly. So let's try this out. So I'm going to stop here. And we're going to go back to the add char method, and we're going to actually set a breakpoint on line 12, where it's actually updating the char's added variable. And let's actually run this. When I say run, I mean debug. So we actually stopped there on that line. So let's resume the program a couple of times just so the value, the variable, gets updated. You can see that it's 1 and now that it's 2. But let's just say now that we want to change the value of this variable while we're running. So there's a couple of ways we can do this. We can actually right click over here on chars added and set value and set the value to 5. Press enter. You can see that it's updated here to 5 and 5, and obviously 5 down here. Alternatively, we can open up here and list the variables here. We can actually do the same thing. We can actually do a set value within there, and there's the keyboard shortcut over there to the right. And we can even change the sBuilder the variable as well. So down here under the sBuilder, I can actually click on that, click into value. If I wanted to, I can come down here and click on, say, this second char, right click that, set value. Now I have to enter it in a similar thing. So I can put single quote B, single quote, press enter, noting that it's added the 98 for it automatically, which is the ASCII equivalent of a lowercase b. The point is that we can actually change these values on the fly without actually restarting our program, so we can test different things based on the value. And that's seriously pretty cool, I think, to be able to do that. And obviously now if we come back and click on resume again, you can see the values are still going up and the changes that we made here are still being used. So the char's added, the count started from the last value, we went to a 6 and a 7, and obviously the rest of the chars are being added to this char array without affecting the change that we actually made, which is pretty cool. Now, one last thing that I want to cover is I mentioned earlier that we need the source code to debug a method. Now, if we're using a third-party library, then we need to tell IntelliJ where it can find the source. Now, we're not actually going to use a third-party library, but let's download a library and its source so you can see how to associate the source code with the library. So I'm going to get a link here. I'll open a browser. Paste it in, and yes, it's in the resources section of this video. So what we want to do is just go down to the bottom of this package, and we're going to download both the binary. I'm just going to save that on my desktop, and I'm also going to download the sources. Same thing, save. They're only small files, so it shouldn't take too long at all. Alright, so let's go back to IntelliJ. Now what we want to do, and I'll just close this window down, disconnect the debugger. And what we want to do now is come over here and click on File and select Project Structure. Then we want to come to Libraries. Then I want to click on the plus, select Java. Then we want to navigate to the folder that contains that file, the two libraries that we've downloaded. I'm going to go to my home folder, and it's going to be on my desktop. So the first one we want to add here is the JTransforms, the with dependencies one. So I'm going to click on that first. I'm going to click on OK to say yes, that's okay. That's going to be added to this current project, to this module. So that's added the first one. Now we want to add the source code to that library. So what we want to do here is make sure that we use this little plus button here. And if you're on a Windows machine, the plus may be here. But the point is we want to make sure that the actual library is selected. So what I'll actually just click on OK to close it down. Then click on File, Project Structure again. Click on Library if it's not selected already. Then select on the actual library if you've got more than one. Then don't click this button again. We want to click this button here to associate to this existing library. But again, that button may be at the top depending on your operating system. But click on that. And saying select file or directories in which library classes, sources, documentation, etc. are located. But we want to select the sources this time. Click on that. Click on OK. And notice now what it's done here, it's actually put the classes, but then it's also listed the sources there as well. So we've now associated the source code for a particular library with the actual library itself, the actual class files. Now, having said that, the JTransforms classes don't actually contain debug information. So therefore, even though we have the source, we wouldn't be able to see much in the debugger. So it does really depend on the library. But I'm just using this as an example to show you how to associate source with a third-party library, because lots of libraries do have that debug information. And this is just a great way that you can get the source code and you can then start debugging and stepping through source code for a particular library that you're using. Keep in mind that if you don't have the source code, then usually the debugger can show us the method declarations because it can figure those out from the Java binary file. But that's all it can show us. We won't be able to see individual lines of code unless you've actually got that source code. Alright, so that's it for using the IntelliJ debugger. Now, other Java IDEs also have debuggers. The concepts are the same, but how you use the features, such as setting breakpoints and watch points, may be different. But for now, you've got a solid basis to start with, and you should be able to use any debugger to debug your applications. Now you know the basics and what to look out for. Alright, so that's debugging finished. In the next video, we're going to start looking at JUnit testing. So I'll see you in the next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
So one of the important phases in the application development lifecycle is the testing phase. Now, there are several types of testing. The first line of defense when testing code is called unit testing, which is typically performed by the developer or development team. Now, when working with Java, a unit usually refers to a method. Now, a developer could run tests on his or her code manually. For example, if we wanted to test a method that performs a calculation and displays the result to the user, we could manually run the method with a set of test values and verify that we get the expected result back. But that's tedious, and what would happen when we made changes to the method? We'd have to run the tests all over again and perhaps add even more test values. Now, instead of running tests manually, developers can use a unit testing framework to write tests that will run in an automated fashion. Now, when working on a team that's coding a large application, the build process for the application will typically run a unit test suite after each successful build. And if 100% of the tests are successful, that's great. But if not, then the failed tests will tell the developers what recent changes to the code may have broken a part of the application. For smaller applications with a single developer, the developer can still run the test suite after changing any code. Now, JUnit is a popular testing framework that we can use to run unit tests. And starting in this video, we're going to learn how to use JUnit to run automated tests on our code. So what we need to get started is to create a class that we can use to write some unit tests for. So let's create a new project. It's just a standard command line up, and we're going to call this one banking. Alright, and I'm just going to create a class, new class, and we'll call this one bank account. Okay. So let's add a couple of fields. So private string, first name, private string, last name, private double, balance. Let's add a constructor with all three fields. Alright, we want to write a couple of methods here, a deposit and a withdrawal method. Public double deposit. We need two parameters here, double amount and boolean branch. Balance plus equals amount. Return balance. Let's just put a note here to say that branch argument is true if the customer is performing transactions or performing the transaction at a branch, with a teller. And we'll say it's false if the customer is performing a transaction at an ATM. Okay, that's the deposit method, and we'll write another one. Withdraw, public double withdraw. You need a double amount again, and we want a Boolean branch. And it's going to be balance minus equals amount and return balance. Alright, same deal there with the branch argument, so I'll just take a copy of that and paste that on the method there. Alright, let's add a getter just for the balance. And here, ordinarily we'd put more methods that use first name, last name, and perform other functions. But obviously this isn't a robust implementation of a bank account class, but the methods that we've created will do for our purposes here. Alright, so we want to use JUnit, which is the testing framework that is going to be automating our tests. Now the first step that we need to do is to add the JUnit library to our project. Now IntelliJ ships with the JUnit 3 and JUnit 4 libraries, but it doesn't actually add them to the projects by default. So we have to add the version of JUnit we'd like to use. Now JUnit 4 is the latest version. I recommend going for that one. So we're going to use that one in this section of the course. And in fact, all the code in this lecture will be based on JUnit 4. So if you are using an earlier version of JUnit, some of the code won't compile and the tests won't work because of the enhancements that they've made to JUnit 4. And again, IntelliJ includes JUnit 3, so that projects built in IntelliJ that use JUnit 3 will still work without having to switch to JUnit 4, but it is recommended to use JUnit 4 for all new projects. Alright, now, so how do we go about adding the JUnit 4 library to our project? Well, we could add the library to the project in the normal way that we've done before. File, project structure, going into libraries, and then adding the library and actually navigating into the IntelliJ installation folder, where you'd find it in the lib subfolder of the IntelliJ root directory. But there's actually a more convenient way to add it to our project. So let's just cancel out of that. Now we want to write unit tests for the bank account class. So what we need to do to get this added is put our cursor on the public class bank account line within the bank account file. And once we've done that, we press Alt Enter, the cursor on that line. We get this option that pops up here. We click on Create Test. And this pop-up will pop up the first time you do this. And it's actually asking where we're going to put the test code. Because what actually happens is JUnit will create for each class in your project an equivalent test class. So it'll have the same name as the class, but with the word test in it. In this case, we've got a class called bankaccount.java. So JUnit will want to create a file called bankaccount.test.java. So I'm going to click OK to enable the tests to be added into the same root, in the same source root. So we'll see that when I open the project pane shortly. So I'm going to click OK to that. Now once I do that, we'll get this pop up as well. But what we want to do here is you can see that it's, for me, it's popped up and said or shown test library Groovy as a default. And it may or may not do that for you. But what you want to do is come down here, click on the drop down and select JUnit 4. And at the moment it's coming up saying JUnit 4 library not found in the module. We can click on Fix. And we get this little pop up, and you can see the options are we can either copy the JUnit 4 library or we can use the JUnit 4 from the IntelliJ IDEA distribution. So select that first option because it makes more sense to use the inbuilt one that comes bundled with IntelliJ. Click on OK. We now look at get that error about the JUnit library. Now at the bottom down here, we've got the options of the methods that are in this particular class, and we can create an equivalent test for that method for each of those methods. So let's click on the checkboxes next to each one and click on OK. I'm just going to open the project pane here just to show you what's happened, and you can see now that IntelliJ has actually added this extra class, this bank account test class, and has put it in the same source folder as the regular package. So basically you can differentiate between the two by the word test on the end there. And it's conventional for the unit testing class to have the same name as the class that it will test. So the test suffix makes sense here, and it tells you at a glance that these are the tests relating to the bank account class, which is what we want to do in this particular case. And by the way, the new class is created for our tests. That's because we don't want to mix any test code with the application code. That's why they are separate and distinct from each other. So notice here that there's one test method for each method in the bank account class. Now remember that a unit is typically a method, and so a unit test will typically test one method. Now this org.junit.test annotation tells the JUnit framework that the method is a test method. Now right now the JUnit references are unresolved even though we added the library to our project. That's because when we clicked the Fix button and IntelliJ added the library to our class path, it set the usage of the library to testing, which means that the library will only be included when we run tests, but not when we compile them. So to fix this, we need to go to the project structure dialog, appeared, File, Project Structure. And we need to click on it over here to Modules, and over here to click on JUnit, and we want to come over here to the right where it's got Test, and change that and select Compile. Once we do that, we click on OK, you can see that IntelliJ had a brief think about it, and now those annotations are now resolving and working fine, and we've no longer got any errors. Now if you want to avoid the extra step of going into the project structure dialog as I just did, you can do so by not clicking Fix when we add the library. So let's actually just go through that just so for future reference you can see what to do there. So I'll go back into the project structure again. Come over here to JUnit. I'm going to remove that by clicking on the minus. Bearing in mind that the plus and minus may be at a different location. It might be at the top of the screen, but in any event, select it, click on minus, click on OK again. And obviously we've now got those errors again because we've removed the JUnit library from our project. So come across here to one of these unresolved annotations, putting your cursor to the right of the JUnit where it's in red, and hold down Alt and press Enter or Return. We click on this Add JUnit 4 to class path. The same deal here, we want to click on or select the Use JUnit 4 from IntelliJ IDEA distribution. Click on OK. And that also fixes the annotations, and we've now no longer got any errors. So I personally prefer this method because we don't have to go into the project structure dialog at all to set the value to compile. So it's just fewer steps and gets you up to speed quicker. Alright, so next we're going to create a separate run configuration for all our tests. Because we want to test a class in our application, we don't actually want to run the application itself. We want to run the unit tests. So within this class that I've got open on the screen, the bank account tester class, I'll just do the full screen. You want to right click anywhere outside of a method. So down here we can right click. And you can see this option here for create bank account test. That's going to be the one that we want to click. But if you're in a method and you right click that, notice that we've only got that option for create withdraw. That's not what we want. So just basically move outside of a method, right click, click on create bank account test. That brings up this create run / debug configuration screen. All the options by default are correct. Click on OK. Now you may have noticed at the top right hand corner here, this little dialog box changed. We've now got an option for main. But we've also got an option here now for bank account test, which is the one that's currently selected. So basically we've got this now to run the tests within this bank account test Java. We've still got our regular main, which would run the code that's in our main method, of which there's currently nothing in there to actually process. It's an empty method. And I'll just move this down to the bottom. So let's go back to main and just put a simple print line in that there so we can see that it's doing something. So, and obviously we can just click on run over here again. Okay, that's working. But now the moment of truth has arrived. Let's actually run our tests. So just to bring the file back on screen again, the bank account test. Come over here select bank account test and click on run. Alright, so you can see something's happened down the bottom of the screen. The console panel at the bottom has been split into two parts. On the left you can see there's a list of all the tests we ran. So you can see that the 3 there corresponds to the method names that are in our bank account test class. It actually shows you the name and how long in milliseconds it took to actually execute that test. On the right is the normal console that we're used to seeing. Now there's also a toolbar that only appears when we're running tests. For now though, we'll notice that there's a message after the green bar that reports that all our tests were successful. Over here, all 3 tests passed. But this is actually bad. And the reason it's bad is we haven't actually written any tests. All we have in our bank account test class are stubs, which if you recall is another word for empty methods. But if we were to look at the test report, we could forget that the tests were only stubs and think that we've tested our application and that all the tests have passed. So to make sure we don't make this mistake, before we end the video, we're going to have all our tests call JUnit's fail method. And that method does what it says. It reports that a test has failed. So it accepts a string parameter that it will report when the test fails. So let's actually add that to each one of these methods. So it's going to be fail. And I'm just going to do an Alt-Enter to accept that import. And the message is going to be this test has yet to be implemented. Just as a reminder for us. And what I'm going to do is put that same message in each one of our methods. And now that I've done that, if I run our test again, we actually now get 3 errors. So you can see that it's now completed and the amount of time that's taken, but we're getting these assertions now. JUnit framework assertion failed error with our message this test is yet to be completed. And we can see looking down there, we've got 1 for each of our methods. So basically all 3 methods are now failing. So hopefully now you can see that how getting into the habit of adding a call to fail to any new test method will ensure that we aren't running test stubs and that we know that these can ultimately be replaced with our tests when we get to writing that bit of code. So when the tests failed, they threw these java.lang.assertion error exceptions, and the message reported for each exception, again you can see on the screen there, is the message we pass to the fail method. Now when we use JUnit, what we essentially do is test the output of a method against an assertion that we've made about the expected output. So a test fails if the assertion isn't met. And that's why JUnit reports test stubs as passes. They don't assert anything, and so no assertions fail. And this will become clearer when we continue in the next video. Okay, so let's now go ahead and add another test method to the bank account test class. And we can do that at any time. We don't have to match a test method to a method in the class we're testing, although in an actual development environment it wouldn't make sense for us to do so. Test methods have to be annotated though with the org.junit.test annotation, as you can see that the 3 methods in the bank account test class currently are. And they must also be public and must also return void. Now when working with older test suites, you might see that the test methods begin with the name test, and that's because older versions of JUnit didn't have the test annotation, and so we had to begin test method names with test in order for the framework to identify test methods. We no longer have to do that, which is why IntelliJ doesn't generate method names that follow that now outdated convention. Alright, so let's add some code. We're going to add another method here. So it's going to be public void dummy test. We'll start off with an empty one, and we need to annotate it with our org.junit.test. You can see when we did that they're highlighted in yellow, so IntelliJ was telling us it's now a valid test. Now, as I mentioned towards the end of the last video, when we work with JUnit, we make assertions about what we expect to happen. Now if these assertions are met, then the test passes, but if they're not met, then the test fails. So an important implication is that a test can pass even though our code has bugs, because none of the tests in our test suite made an assertion that will catch the bug. As we've seen, when an empty test method runs, it's considered a pass, and that's again because no assertions failed when it ran. So that's really important to remember, that the test suites that we write, all the methods will only cover the situations that we test against assertions. Alright, so let's now change the dummy test method so that it tests whether two integers are equal. So I'm going to type assert equal. So it's assert equals, we'll put 20, 21. Now when using the assert equals method, the first parameter is the value we expect, and the second parameter is the value we want to test, or the actual value. Now obviously this test here is quite a silly one because we've hard-coded the values, but let's run it anyway and see what happens. But instead of running the entire test suite, which we've done in the past by clicking the run button up here, which we could also now do with this JUnit pane open, we could also click it down here. But instead of doing that, we can actually click on this little green arrow here to the left in the gutter of the method, and that'll run the test just for this one method. So click on that now and run it. You can see here I can click on run dummy test. And you can see that one test failed this time. We haven't got the list of the other tests because we only ran this one single test. And we've got a similar error on the right hand side in that we got the assertion failed come up, but it actually showed us that we expected the value 20, but we saw the value of 21. And that's in line with the fact that we've put two different numbers on line 27. Now note also when that happened, when we ran the test this way, this little icon's changed now. And also over here, notice that we've now got a different run configuration. So one's been created just for that method. If we do a drop down, click on the drop down, we can see now we've got main, we've got bank account test, which would run all the tests in this class, and bank account test.dummy test. So if I leave that on there and run that now, it'll only run just the one test for that method. But if we want to run all the methods, all the tests in the bank account test class, select the bank account test only and run that. And we're now getting a list of the four methods, or the four tests running down the bottom of the screen. Alright, so you've now seen how you can add test methods to the test class, and hopefully now you've got a bit of a feel for how JUnit works. Let's go ahead now and delete this dummy test method because we really don't need that anymore. And what I also suggest you do is come over here and click on the drop down, click on edit configurations, and you can just expand this so you can see which one it is. Make this a little bit bigger so we can do that. And you can actually remove this one as well, this dummy test we no longer need. Click on minus there, click on OK, so we don't get confused later on down the track now that we've deleted that method. Alright, so let's now go ahead and write a test for the bank account.deposit method. So we're going to start there, so we're going to start working up here. And we'll start by creating an instance of bank account. Let's go ahead and do that. And I'm going to delete the file there now because we're actually at the stage of writing our tests. So bank account equals new, bank account, and first name, I'm putting my name in there, last name, so I'll put a starting balance there of $1,000. So again, I've deleted the call to the file method now because we're actually implementing this test now. Alright, so let's call the deposit method with the value of 200. And we're going to set the second parameter to true, meaning that the transaction is taking place at a branch with the help of a teller. Right now though, the bank account deposit method isn't using that parameter. So I'm going to type double balance equals account.deposit 200 and then true again for using the branch. Alright, so obviously we started with a balance of 1,000 on line 11. We've deposited 200 on line 12. So the bank account.deposit method should return 1,200. So this is where we can use the assert equals method to assert that the expected value should be 1,200. Now the actual value we'll test against is the value returned by the deposit method. Note here that when comparing objects, the assert equals method uses the equals method of the objects being compared to make the comparison. Alright, so we'll type in assert equals 1,200 being the value that we expect that it will be. Then the actual value we're going to test is balance, which was retrieved from the account.deposit method on line 12. Right, and then I'm going to put a third parameter there of 0. And I'm going to accept that import. So when comparing doubles, I've chosen to use the version of the method that accepts a third parameter, and that's a delta parameter. And what that does is it allows some leeway in the comparison. So as long as the difference between the expected and actual values is within the delta we specify, then the assertion will pass. Now in this case, we expect the value to be exactly 1200.00. So you'd start with a delta of 0 and change it if we discover that the value returned was, like 1199.999999, etc. That sometimes happens when you're working with double calculations. All right, so let's rerun our test suite now. Coming over here, making sure that in the run window here, you've selected bank account test. Click on run. We're now back to our 3 tests because we deleted the 4th one, but we also can see here now that the deposit method is now successful. It's changed to showing OK and is in green, indicating that that test has actually succeeded. Okay, so we can have more than one assertion in a test. For example, we may want to verify that the bank account balance instance variable now equals 1200. So let's go ahead and add an assertion to that below the first assertion. So assert equals 1200.00 account.getBalance, and add our delta parameter as well, which is 0. And we run the test, or the test suite I should say, all of them. Same thing happens, we've still got the deposit test completing successfully, and the withdraw and get balance are failing as is expected at this point in time because we haven't implemented them. So every test method should be self-contained. In other words, what happens in one test method shouldn't depend on what happened in another test method. So every test method should start fresh and be able to run independently of the other test methods. And as you saw earlier, we were able to run the dummy test method independently. Having said that though, we can have instance variables in our test class. Now depending on the code, it may make sense to create a single instance of a class that we're testing that all the test methods use. Essentially, when writing a test, a question you want to ask is whether the test can run and pass on its own, and the answer to that question should always be yes. Alright, so in the case of the deposit test, even though we can add more than one assert to the same test, it's not best practice to do so. The best practice is actually one test per test condition or assertion. So given that, let's copy the body of the deposit test method to the balance method. Okay, let's go ahead and do that. So I'm going to copy that code and paste it into the balance, overwriting the existing file method. And what I'm going to do here is delete this second test, which we no longer need. That's because we're about to do that in the get balance test. And I'm going to remove this first assertion in the get balance test because the one that we want to test here is the value coming back from our get balance, which is the value coming back from our account object. So let's delete also the first part of line 25, since we no longer need to keep the value in a variable anymore, unlike what we did in the deposit test at the top of the screen. Alright, so let's run our test suite again. And we can see that the get balance test and the deposit method are both working, or tests, I should say, are both working. We've got 2 successes now and only 1 failure, which is the withdraw test, and that's correct because again we haven't implemented that at this stage. Alright, so let's say that we wanted to verify the value of the bank account deposit after calling the withdraw method. Now doing so within the balance test method would be bad practice, so we're going to add another method for that. But here's another good practice for you to follow. Test method name should give some indication of the actual condition they're testing. So what I suggest we do here is with the existing get balance method, we'll actually change that and we'll put an underscore deposit on the end of it to indicate the type of test we're doing for that particular test. And then let's add another method to test the withdraw function of our class. So I'm going to go ahead and copy that entire method, paste it. I'm going to change the name where it's got deposit to withdraw. Now obviously this test will be a bit different in that we're going to be calling the withdraw method instead of the deposit. Withdraw. And the assertion here should be a different value. The value should now be 800 because we started on $1,000. We've taken $200 out. So the balance that we should be asserting or checking against should be 800, like so. Alright, so let's run this again. Alright, you can see now we've got 4 tests showing and 3 succeeding. And we can also now tell from the test method names showing down there on the bottom left-hand corner of the screen exactly what each method was testing. One's testing the deposit method, one's verifying the balance after a deposit, and the other is verifying the balance after a withdrawal. Alright, so now that we've got a few more tests, let's actually try out the toggle above the test results. So I'm just going to come down over here and just size up the screen so you can see it a little bit. You can see this OK button. There's actually a toggle which will show you either all the tests or only the ones that failed. So I click on that once. It's now showing only the ones that have failed. And that can be useful when there's a large number of tests, and you can quickly just show the ones that are failing so you can start working on those. And in addition, if I click that again now to see all of them, we can click on a particular method to see its results in the console. That's the results for a single one. And in the case of where they've worked and there's been no errors, we're not getting any output. Now that would change if we've actually got output in the method, but where there's just been an assert and there's been no other output, we'll see nothing for tests that have succeeded. But in the case of one that has failed, we'll get the assertion, in this case, based on our failure method that we've called and the text that was passed to that. Okay, so let's add a method to the bank account class that returns true if the account is a checking account and false otherwise. So I'm going to go back to our bank account class. So we could use an enum for these types of accounts, but since we've only got two, I'm going to use an int constant for both. So let's go ahead and do that. So we're going to do an int. We'll do a PSFI checking equals 1, PSFI savings equals 2. Now, the other thing we'll need is a field to store the type. Private int, we'll call it account type. As a result, we'll now need to change the constructor as well. So let's add int type of account. And then we'll save it in the field. So this dot account type equals type of account. All right, then let's just add a getter down here. And it'll be public boolean. We'll call it is checking. Then we'll do a return account type is equal to checking. All right, that's going to return true if the account type is checking. All right, so let's go back now and add a test for the is checking method to the bank account test class. Now notice now, because we've made changes to the constructor, that we've got these errors in our various tests, so we can go ahead and change that. And let's make the default type of account, or the account for these calls, all to be checking. So we're going to do add bank account.checking for each one of those constructor line calls. Like so. So that's 3 now, and let's fix those errors. All right, and we'll go ahead now and do a test now for is checking. So we can do a public void is checking underscore true. We need to annotate it, org.junit.test. So how do we actually check this? So we type in, we'll actually copy the constructor line, the line that actually creates a new object for us, because that's going to be the same. Then we could do assert equals. We can put true, comma, and then account dot is checking. And we can run that. Is checking underscore true. You can see that's now passed. But when you're testing a value against true or false, it's actually preferable, instead of using assert equals, to use assert true or assert false. Both are separate methods. So we can do an assert true. I mean, because we've now specified assert true, we no longer need to pass the first parameter as true. We just pass the object in this case, or the method call that is actually going to return true or false. We can run that and get the same result. And likewise, if you wanted to test whether something's false, change assert true to assert false. So when you're actually going ahead clicking on these tests that have failed or succeeded, it's not really very useful for small test suites and tests that have only got one assertion. But when skimming the results of a large test suite, coming up to here like so, or if we've got tests that are performing more than one assert call, then the messages can be really helpful. Keep in mind that sometimes JUnit tests are being run as part of the build process and not manually. So as part of that, failed test results may be saved to a file, or a human might have to look at the results, which could be numerous, and that's when these messages can be really quite useful, the ones that we've currently added here to file. So in line with that, what we can do is we can not only just leave the assert true like this, we can actually put in a message that will be that'll pop up in the failure case. So the account is not a checking account. And that would be the preferable way of writing that. So from our point of view, nothing will change here. And that's because the assertion is returning true. But if that didn't return true for some reason, and we could simulate that by changing this to savings, and rerunning our test, you can see now that we're getting the error, the account is not a checking account, because this assertion has failed. So that again can be quite useful. I'll put that back to what it was and rerun it again to confirm that it's working. So again, it's part of a big software team, or if the unit tests are being performed as part of the build process, these types of messages can be really useful to help a developer figure out what changes need to be made. Alright, so I'm going to finish the video here. In the next video, we'll start talking about some other JUnit assertion methods, and then move on to some more advanced JUnit testing techniques. See you in the next video. Okay, so let's have a talk about some other JUnit assertion methods. First one, assert not equals. So we can use this instead of assert equals when we don't want the actual value to be equal to a specific value. Assert array equals. When we want to verify the value of an array, we have to use the assert array equals method. Now the assert equals method won't work in that scenario because it will only consider two arrays to be equal if they actually are the same instance. So the assert array equals method considers two arrays equal when their links are the same and every element in both arrays are the same as well and in the same order. Next, assert null and assert not null. Now we can use these methods to check for null and non-null values. We can use assert equals to check for null, but as with the assert true and assert false methods, using assert null and assert not null makes the intention clearer, and we only have to pass the actual value to the method. Assert same and assert not same. Now we use these when we want to check whether two instances are the exact same instance. Remember that the assert equals method uses the equals method to test for equality. Now the assert same method compares the object references only. And lastly, assert that. Now this method compares the actual value against a matcher. And by the way, this is not a matcher in the JDK, but a JUnit matcher class. And think of this as something that's more powerful than the other assert methods, since we can compare the actual value against a range of values. And note that this method only became available in JUnit 4.4. Alright, so it's time to move on now to look at more annotations that we can use. Now I said that we want to start each test fresh, and so we're creating a bank account instance at the beginning of every test. And the exception to that was when I ran that test in the previous video to test to see whether the bank account checking was the same as the savings. So we're using the same values for the bank account in every test. Now instead of writing the same line of code in each test, what we can do is use a method that has the at before annotation. Now a method with the at before annotation is run before every test. So let's try this out by changing our code to use a setup method. And what we're going to do is we'll remove the creation of the bank account instance from our test methods, and instead what we'll do is we'll have an instance variable called account in this class, and then the setup method will create the instance and set the instance variable. Alright, so at the top of the bank account test class, we're going to put it up in there. So we're going to do an at org.junit.before. And we're going to create a method called setup, so public void setup. And we need to also create this field, the instance variable. So we're going to do private bank account, and we'll call it account. Then inside the setup method, we'll actually just copy this code from one of the methods. This one here is fine. So setting up the new bank account instance as we've done before, and we'll also print out a message as well. The message is just going to say running a test. Okay, so that's the setup method done. And now what we're going to do is go through the other methods and remove the creation of the account, of the bank account, because we no longer need that anymore. So I'll remove that entirely now. That's from the deposit method, also from the get balance underscore deposit method. Same with the get balance underscore withdraw method. And finally to the is checking underscore true method. So basically, as you can see now, we're running, setting that up. The new field that we've defined here on line 12 is being instantiated with a new object in this setup method. So the @before annotation, the @org.junit.before, is telling the JUnit framework to run this method setup every time we run a test. So let's actually just now run this to see what happens. So I'm going to make sure that bank account test is still selected. Click on run. And we should get the same results as last time in that each test will run, and noting that the same 4 methods have succeeded and the withdraw hasn't, and that's because we haven't really implemented that yet. But notice also here now we've got this running a test coming up 4 times, and if we scroll up we can see the 5th time, and the reason that it's failed one of those times is of course the withdraw method has still just got that fail code in there because we haven't implemented it yet. So the bottom line is that you can see now that this setup method has been executed each time a method is tested prior to that tested being executed. So therefore we're getting, in this case, a new bank account object being instantiated on line 16 every time a test runs. Alright, so that's really great when you want some code to be executed each time a test runs. But what about the case where we want to perform some setup code before the tests, but we only want the setup code to be run once? In other words, we don't want to run it before every test. And an example of that might be where we want to read data that all the tests will use from a database or a file. Or perhaps we may want to open a network socket or do some other setup that we really only want to do once per run instead of once per method invocation. So in that scenario, we'd use the org.junit.before class annotation, and then we'd use the org.junit.after class annotation to run the cleanup code. Now the @before class method will run before any of the test cases in the test class, and the after class method, unsurprisingly, will run after all the tests in the test class have completed. And in this case, the methods have to be declared as public static methods, and they must return void, so a little bit different to how they were set up the other classes. So let's go ahead and add one. So I'm going to set one up here. The before class I'm going to set up here, so @org.junit, oops, lowercase o there, dot, and it'll be before class this time, and the method's going to be public. Remembering it has to be a static void before class, and then we're just going to print out here to say this executes before any test cases. Alright, so I normally like to put the 2 before methods at the top of the class, and the after I like to put down the bottom. So it's in a logical order, what is logical to me. So let's do that for the after as well. So @org.junit. This time it's going to be after class. That's going to be public static void. We'll call this one after class. And print out this executes after any test cases. Now remember here that the name of the method isn't important, before class or after class. The annotation is what JUnit is using to determine whether to run that method, whether it's going to be run at the start of the test methods or at the end. Right, so let's actually run this. Now if we have a look at the results, we can see that we've got the message this executes before any test cases, only once, and likewise only once after, and we've got our other tests in there that we've added as a result of adding the setup method as well, using the .before annotation. But depending on the timing, the statement printed by the before class may actually appear in the console after the statement printed from the setup method, and you can see that is the case here. We've printed, this has been the last 2 messages printed. This executes before any test cases, and this executes after. But this doesn't actually reflect the order of execution. What is happening is that the print statements are spooled to an IO thread, and so they may appear in the console out of order, and they're actually doing that, as you can see in this scenario. So just to show this, let's actually add a static int variable to our class, and also a method that we're going to annotate with addAfter. And each time a method in our class runs, what we're going to do is print out the value of that variable and also increment it by 1, so that we can actually see a true test of when these methods are being executed. So I'm going to create an instance variable here, private int, and we'll just call it count. Alright, so with the before class method, we're going to change that a little bit. We're going to put full stop count equals, and we'll add the count. So it's going to be plus count, and I'm going to add a plus plus to increment that value as well. We need to make that a static as well, which makes sense because we only want one instance of that variable when we're going through all these methods. So we're going to show the value before the classes are executed. We've got that set up as per normal. And what we want to do now is go down to the bottom. We want to add an after. So we're going to add the after shortly, but before we do that, in the after class, let's also add a count there as well. So I'm going to put count equals plus count, and then we'll also increment it after displaying it. And then we'll also add our org.junit.after. So this will be executed, this method, after each unit test is finished, in a similar way to the way that the setup method was executed before every test. So we'll do a public void. This one doesn't need to be a static method. We'll call this one teardown. Now we'll just print out count equals plus count and also increment it. Okay, so that should be that. So now if we run our tests again, we should be able to keep track of the count now as it goes through. So looking at the output, we've got count equals 1, running a test. And note here down the bottom, we've got this executes before any test cases, count equals 0. So that's actually the output from our before class method, noting that it actually is set to show the value of count, which will be 0 in this case, and then incremented after that. And then you can see that each other test went through as the test was executed, count equals 1, 2, 3, 4, 5. Then the last one, count equals 6, was executed in the after class method, as you can see there with the output on line 54. So that's confirmation that even though the output is showing in a different order, the methods are being run in the order that I've specified. Okay, so let's go ahead and update the code in the bank account withdraw method. I'm going to go back to our bank account class and have a look at this withdraw method that we've got here on line 35. Now right now we're not using that branch parameter, and you can see that IntelliJ is telling us that the parameter branch is never used. But let's suppose this bank doesn't allow its customers to withdraw more than $500 from an ATM. Now if the customer tries to withdraw more than $500 and they're not using a teller at a branch, we need to throw in an illegal argument exception. So we're going to make a bit of a change here. We're going to put a test in first. So if amount is greater than 500 and we're not at a branch, so not being a branch means that it's being the customer's trying to take the money out of an ATM. If that's the case, we're going to throw a new illegal argument exception. And then we leave the other code down the bottom as is, because the code will only be executed if that doesn't occur. I'll put a semicolon there to complete that line. Alright, so we're now testing to make sure that we're only able to do a withdrawal if the amount is less than or equal to $500 and it's at a branch. Otherwise, as you can see in this scenario, it's going to throw a new illegal argument exception. So let's go now back and update the code in the bank account.withdraw test method. So coming back here to our bank account test, we've got our withdraw method. At the moment, we haven't got anything written in there for. So we'll go ahead and replace that now. I'm going to get rid of the fail there, and we'll put double balance equals account.withdraw, and we'll try to withdraw 600, and we'll also pass true. True meaning that it is a branch, so this test should work. So we can do assert equals, and the value should be 400.00, and we're checking against the value of balance, and we put our delta parameter in as has been discussed in previous videos. Alright, so the test here is to check to see whether we can withdraw more than $500 and we are at a branch, and the true on line 32 means that we are withdrawing the money from a branch. So if we run this now, run our tests, you can see at this point now all our tests have actually passed, and you can see here we've got confirmation on this side as well, and we can see now that there's no problems, and we can see all the output now. Interestingly enough, in the right order this time. You notice how that the output is now appearing in a better order than what it was when we had a test failure previously. Alright, so let's change that. We'll change the name of this one. So back up to withdraw, and we'll say withdraw_branch, because that's really the name of the method. And let's create another one, org.junit.test again. And we'll call this one public void. We'll say withdraw, not branch. And we need to throw the exception again. And what we want to do here is do a similar thing. I'm just going to copy the code that we had prior. I'm going to paste it in there for the withdraw_not branch. But this time I'm going to change the true to false, meaning this time we're doing a test to see whether a withdrawal of 600 at an ATM works or what actually happens. And bearing in mind that we've added the code in the method in bankaccount.java to throw an exception if that's the case. So now if we actually run this, so you can see what's happened there. We've got an illegal argument exception, which is to be expected because the amount that we're trying to withdraw at an ATM exceeded the value that we specified in bankaccount.java in the withdrawal method. But the problem here though is that the test actually passed. In other words, we want the method to throw an illegal argument exception when branch is false and the amount is greater than 500. So how do we handle this to correctly indicate that the test has passed? Well, in this scenario, when we're expecting an exception to be thrown, we actually have to make a modification to the annotation for the method. And I'm going to do that as follows. So down here in the withdraw not branch, and what we do is we put parentheses, we put expected equals, then the name of the exception. So that's going to be a legal argument exception dot class. We need to add the dot class on the end as well. So now when we run, we should find that all our test methods will actually pass. And you can see at this point now, because we've told the method to expect an illegal argument exception, we no longer get the exception showing, and all our tests are now succeeding and working properly. Alright, so I'm going to finish the video here now. In the next video, we're just going to come up with another little bit of a scenario to optimize this withdraw_not branch method. And I'm going to actually show you the old way of testing exceptions that you used to have to do in older versions of JUnit. See you in the next video. Okay, so we can further optimize this method a little bit more. If we're actually expecting an exception to be thrown, we did have to modify the annotation line as you saw on line 36. But we can also remove the assert equals as well, because we're not testing for equality in this case, we're just testing to see whether the exception's thrown in the case of invalid input. So I'm going to remove that. We can remove that completely, and the test could now literally just be that one line there. And in fact, we could even remove the local variable because we don't need that anymore as well. So really just purely just testing in this particular test to see whether that exception is thrown, given that the parameters are invalid for the amount of money to be withdrawn from an ATM. So let's just run that. And you can see that the tests are still passing there and working fine. Now note that annotations were only introduced in JUnit 4. When using earlier units or versions of JUnit, what we'd have to do is surround the code that would throw an exception with a try catch block, and we wouldn't do anything in the catch block. Remember that if you don't assert anything, the test will pass. So in that case, we do the following when working with an earlier version. And I just want to show you this because you may come across some code along those lines. So what I'm going to do first is comment this bit out here for now. And we're going to write the extra code, assuming we're in the scenario of an older version of JUnit. We need to introduce a try. We put our code in the try block, which will be in this case the account.withdraw. Then we'll need to catch the illegal argument exception. We wouldn't actually do any processing, so we'll do it that way. When we run it, we should see that we get the same result. You can see we get the same test results that all our tests pass because we've caught the exception in this case because we're expecting it, and we don't need to do any processing in the method because we've caught that exception. But the other thing I wanted to show you what we should really be doing here to be more specific is we should really have a fail here as well. And the fail would be should have thrown an illegal argument exception. So again, we run the tests. And just to confirm that this code would work, we'll put a true there, run it. And we get that failure, should have thrown an illegal argument exception. So that's how we would have had to do it in the past. But it's a lot easier than that these days. So I'm just going to put the code back to how it was. So again, this is the JUnit 4 way of doing it, which is a heck of a lot easier. So I guess to be correct, we would also put a fail here as well. On the tests again. And again, it passes because the exception's thrown and this code is actually bypassed. Okay. All right, so the final JUnit topic that I want to cover is parameterized tests. So we want every test to start fresh, but that can result in a lot of repetitive code. For example, let's suppose we want to try depositing 5 different amounts and verifying the resulting balance. Now we could write 5 different test cases, but we can also write a parameterized test. Now we have to use a class annotation to run parameterized tests, so let's create a new task, a new test class. I'm going to open up the project pane, a new class, and we'll call this one bank account test parameterized, like so. And let's start by creating an instance variable, a private bank account. Then we want to set up a before, so at org.junit.before, and that's going to be public void setup. And account equals new. I could have copy and pasted this code, but I'll just type it. New bank account, Tim Chalka 1000.00 and bank account.checking again. And then we'll just do an output, a line of output, just to say we're running a test. Okay. But what we need to do now though is tell JUnit that this isn't a normal test class. And we want to tell it that, so we want to use it to run a parameterized test. So we need to use the @runWith annotation on the class definition itself. Come up here to the top, and we're going to put @runWith, and we're going to put parameterized.class, like you can see there. And as a confirmation that you've got this right, you should see these 2 little green arrows in the gutter to the left of the class definition. Okay, so let's suppose we're going to call the deposit method with branch equal to true and a number of values, say 5 different values. What we have to do is tell JUnit that these are the parameters we want to use. Now we're going to do so by adding a static method annotated with the @parameters annotation, and that method needs to return a collection. So we're going to come down below the setup method. We're going to put @parameterized dot parameters, not parameter, and it's going to be a public static collection. It'll be a collection of object. We're going to do test conditions is what we'll call it, and we're going to do a return arrays.asList. That's going to be a new object array, and the values that we're going to include, and I'll explain these shortly, so 100.00 true 1100. On the next line, 200 true 1200, 325.14 true 1325.14, 2 more here, 489 33, true, 14, 89, 33, and last one is going to be 1000.00, true, 2000.00, and put a semicolon there to close it off. Okay, I've got an error there. I need to add square brackets there. Okay, so what have we done here? Well, each row you can see on line 26 through 30 is the set of parameters we want to test, followed by the expected value. Now, when we run the parameterized test, JUnit will create a new instance of the bank account test parameterized class for each set of test data. And it will use the class constructor to set instance variables to the values we've specified. Now, we need to do two things though. Add instance variables for the deposit amount, the branch value and the expected value, and we also need to add a constructor that accepts the values and sets the instance variables. So let's go ahead and do that. So we're going to below here, below the bank account, I'm going to type private double amount, private boolean branch, and then private double expected. Then we need to have that constructor that I talked about. So public, we'll create a constructor, and the parameters we want are the amount, the branch, and the expected. We don't need to use the bank account in the constructor. So we've now created that constructor. All right, so let's go back to the bank account test class, like so. And what we want to do is grab a copy of the deposit test. So we'll just copy that. Go back to the bank account test parameterized Java file, and we'll paste that method in there. I'll accept that import. And we just need to modify this to use the instance variables rather than hard coding the values. So I'm going to change this. Firstly, the 200 is going to be now the amount. The next parameter is branch, which is again, it's one of our instance variables. And the third one, instead of the 1200, that's going to be expected. So the three values that are coming from here, which ultimately are being created from our collection objects from the test conditions method. So what we can do now is we can actually run the test by clicking on this green arrow to the left of the get deposit. And let's actually just change that. We'll just call the method deposit for simplicity. And we'll run it. Run deposit. And you can see that it ran various tests. So we've actually got some output here to the left showing the various tests, the fact that it was run 5 times. But this third one's interesting. And you can see deposit 2. And the problem with that is we've got this expected value of 1325.14, but the actual value is 1325.13999999. And this is where the delta option actually comes in. So in terms of the tests that might fail, in my case you can see it was the third one, but you might find that the fourth one actually fails here. It just really depends on your system as to which one will fail or which one could fail. So what you need to do now is just change this delta parameter to take that into account. I can change that to make that say 0.01. Run the test method again. Run deposit. We can see that this time we've actually allowed that delta to be 0.01, which is enough of now to actually cover for the fact that it was sort of close enough dealing with the double precision that is part of a double primitive type. So in most cases you won't need to do that, but you can see where this delta option now comes into play if you do need to do that when you're testing double primitive type. Alright, so that's how we run a bunch of tests on the same method, as you can see there. And you saw that there was a bit of work to set it all up, but then it does cut down on the amount of test code that we have to maintain. And just to confirm that, if we look over to the left hand side here, IntelliJ created a new run configuration for the class. So if we want to run this again now, we've now got this bank account test parameterized.deposit that we can run at any time. And over here to the left, the 5 tests are showing as having run, and the test pane also labels each test using its index in the collection. Alright, so now that you've seen how JUnit gets the test values and passes them to the test method, hopefully now you can understand why we have to create a class for each parameterized test that we want to run. Alright, so that concludes our tour of JUnit. Now obviously we can't go through every detail of JUnit. This is quite extensive and there's a lot more that could be covered. Now there's certainly more that you can do with the framework, but you now have the basics, and coupled with you spending some time looking at the documentation and playing around with it, I'm sure you'll get a lot out of it. In the next video we're going to start working on a JUnit challenge. So I'll see you in the next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
So it's now time to start practicing what we've learnt about JUnit, and we're going to do that in a series of challenges. So what I'm going to do is start off by creating a utilities class that we're going to be using. So create a new project, as I've already done. In this case I've called it JUnit Challenge, but you can of course call it whatever you like. And let's create this new package, this new class rather, and it's going to be called Utilities. Okay, so let's create a few methods now. So we're going to start off by creating a method. It's going to be public. It's going to return a char array, and we'll call it every nth char. And it'll accept a char array as a parameter. We'll call that source array, and also an int n. And let's just put a comment here. It returns a char array containing every nth char when source array.length is less than length is less than n, return source array. So that's basically the overview of what this particular function does. Okay, so in terms of the code, now there may be bugs in this code as I type it, so if you do spot any, keep them to the back of your mind for now. Remembering that we're going to be testing all the methods in this class using JUnit. Alright, so if source array is equal to null, or source array.length is less than n, then we're going to return source array, and then int returned length is equal to source array.length divided by n. We'll do a char array result is equal to new char return length. Int index is equal to 0. Then we're going to use a for loop here. So for int I equals n take 1, I is less than source array.length, I plus equals n. Then we're going to do result index plus plus is equal to source array I. Then we're going to return result. Okay. So that's the first method. And again, the idea of this one, return a char array containing every nth character. And nth is a parameter that we pass. And when the source array.length is less than n, we just return the entire array. So that was the purpose of that function. The next function, we're going to call this one public string. We'll call it remove pairs. And we get a source string as an argument. And the idea of this function is to remove pairs of the same character. So removes pairs of the same character that are next to each other. And it does that by removing one occurrence of the character. And let's just do an example. So if we get the input string A, B, B, C, D, E, E, F, then what this method should return should be A, B, C, D, E, F. That's another example. A, B, C, B, D, E, F should return A, B, C, B, D, E, F. The reason for that is the two B's are next to each other, so they aren't removed. Right, so that's the purpose of this function. Right, so let's write the code for it. Firstly, if the length is less than 2, there won't be any pairs. So if length is less than 2, or we'll write that out, is less than 2, there won't be any pairs, which makes sense. So if source.length is less than 2, we're just going to return source. Alright, so now we're going to create a string builder. So string builder SB is equal to a new string builder. Sorry, string builder, not string buffer. String builder. And we'll create a char array. So char array string is equal to source dot to char array. So converting the input string source to a char array. We'll create a loop for int I equals 0. I is less than string.length I++. And if string I is not equal to string I++, then sb.append string I. And then we're just going to return at the end of that loop sb.toString. Alright, we've got a couple of other methods here that are just going to be smaller ones. This one will be public int converter, int A, int B. And the idea of this one, perform a conversion based on some internal business rule. An arbitrary rule, and the rule will be return A divided by B plus A times 30, take 2. And the last one, public string null if odd length, string source. I won't bother commenting that because hopefully the method name gives enough information as to what this is trying to do. So if source.length remainder of 2 is equal to 0, return source, otherwise return null. So essentially it should be returning null if we've got an odd length of the input string, otherwise we return the string itself. Okay, so that's the utilities class that's going to be used as a basis for our unit testing. So this is available in the resources section if you don't want to type it in. So let's go ahead now and look at our first challenge. Alright, so challenge number 1. To set up the test stubs. So you want to create a JUnit test class that contains a test method for each method in the utilities class that has just been created in this video. Now don't add any test code to the methods yet. When you run the tests, they should all fail. So use the naming conventions we discussed in previous videos in this part of the course, remembering that you have to add the JUnit4 library to this project. So that's challenge 1. See how you go with that one. Pause the video and I'll see you when you get back. Okay, so how did you get on with that first challenge? Hopefully you managed to get that working. So what we need to do is use IntelliJ's JUnit support to create that test class and then add the JUnit4 library. Now you can do all of this manually by adding the methods yourself and also adding the J4 library by using the project structure dialog that you saw earlier in this section. But what I'm going to do is place my cursor on the utilities class declaration line and hold down Alt and press Enter. Then I'm going to click on Create Test from the pop-up dialog. Just press Enter there. I'm going to select JUnit4 from the testing library. And the dialog box reports that JUnit4 library is not found in the module. However, we're not going to click on that Fix button. And the reason for that is we're avoiding the step of having to go into the project structure dialog and select and compile. So we'll fix the library problem in a minute. So the class name is set to utilities test automatically, and that follows the naming convention for test classes with the word test in it. So we can keep that the same. And notice that the create test dialog has options for at before and at after. So now you can see what they mean, because the last time I went through this earlier in the course, we hadn't discussed what those sections, what they were actually used for and what they meant. But we won't actually add those at this time. And then of course we need to select all the methods by checking all the boxes at the bottom of the dialog to the left of each method we want a unit test for. In this case is all 4 of them. And then we click on OK. You can see that IntelliJ has now created this units test class in the same package as our utilities class, which is of course what we wanted. And we've still got this problem here though of the references to JUnit being unresolved. So all we need to do to fix that is place the cursor on one of these annotation lines. So the first one's as good as any. Making sure you click actually where it's unresolved, the JUnit part, Alt Enter. We click on Add JUnit 4 to test path. And we want to use JUnit 4 from IntelliJ Ideas Distribution. Click on OK. That should resolve all the errors as you've seen now, and we no longer have any errors showing. Now at this point, if you were to run the tests, they would all pass. But if you recall, part of the challenge was to make them fail. So what we need to do is add a call to JUnit's fail method to each test method. Let's go ahead and do that. So we want to do a fail. This test has not been implemented. I'll allow the import. And I'll just copy and paste this same message into all of the unit tests methods. Now if I just right click in there somewhere and click on Run Utilities Test. And I'll move this down to the bottom so we can see it a bit better. And you can see we've got our 4 JUnit test methods now, which are all failing. And they've obviously all got that same error, that same failure message, which we've just added to each method. Okay, so that's challenge number 1 completed. Let's have a look at the next challenge. Challenge number 2. So the challenge is to add test code to the remove pairs test method to test the utilities.removepairs method. So in this challenge, the idea is to create tests for the utilities.removepairs method. Now this method accepts a string and removes any pairs it contains by removing one half of the pair. And you saw when I was typing in the code, some of the examples, but you can see on the screen there, the first input has got multiple A's, multiple D's, and multiple F's. And the output has stripped those to leave only A, B, C, D, E, F. And in the second scenario, we've got some duplicate C's there and some duplicate E's, and it strips those to leave only one of each. So you want to write the test code that tests the above 2 scenarios that I've shown, and start by writing a test for the first set of input-output. And once that test passes, add a test for the second input-output pair. Now to keep things simple, you can add the second test to the same test method, but if you want to be strict about it, you could create another test method for it. Alright, so that's challenge number 2. See how you go with it, and pause the video now, and I'll see you when you get back. Alright, so for this particular challenge, we want to use the assert equals method, and that's because we want to test the actual value, the output from the method, against the expected value. Remember that the expected value is the first parameter. So let's look at the remove pairs. Firstly, I'm going to delete that failure call now because we're now implementing the test. So we're going to start by utilities, util equals new utilities. That's our utilities class. And for this first test, we're going to do assert equals. And we want to, the test A, B, C, D, E, F is the output we should be expecting. And then we want to test that by putting util.removepairs. And it's going to be AA, B, C, D, D, E, F, F, which was the input as per the slide. And if you recall, we can run the test in 2 ways. We can run all the tests, which we do by clicking on Run. Either over here in the bottom left-hand corner or up here now that utilities test has been selected because we've run it at least once. We can also do it by clicking over here in the gutter. So let's run this test only by just clicking on this little button over here to run just the remove pairs test. Run that and see what we get. And you can see that we've got a comparison failure here. So we've actually got a failure. So you can see that it expected to get A, B, C, D, E, F, but the actual response we got was nothing. It was actually empty. So did you figure out why it's actually done that yet? What I suggest you do is take some time now to see if you can figure out the bug and fix the method before we proceed. So pause the video now, see if you can fix and figure out why this method is now failing, and then come back and then I'll go through the solution. So how did you go? Did you figure it out? But when debugging, it can be useful sometimes to run the code outside a test case. So let's actually go back to main.java and put some code in there to test this. So we're just going to put utilities, util equals new utilities. Then we'll just do util dot remove pairs, A, A, B, C, D, D, E, F, F. We don't care about the return value here. But let's actually print the value of each character we're examining in the loop in the remove pairs method in the utilities class. Coming down here, remove pairs. So when we're going through it, for int equals I less than string.length I++, let's print out the character there. So s out, and we'll print out string I. So I've just added a simple print out there. Now I guess we could have used the debugger instead to set a breakpoint inside the loop and examine string I. In this case though, I think print line is easier, but you may well prefer to use the debugger. It's literally up to you here. Some developers prefer using logging or print line when they know the general area where the bug must be, and then if the prints don't help, they then go back in to start using an alternative, which would be the debugger. There's really no right or wrong way here to debug a problem. Just use whatever method works for you. Note, however, that you'll often need to use a debugger when working on non-trivial applications. Alright, so we've got a print line added now, and we should expect to see all the characters in the input array printed to the console. So let's go back to our main method and run it. Right click to make sure we're running the main and not the tests anymore. Alright, and when you see the output there, clearly something isn't working right, and that's because we only see the letters A, B, D, E, and F. So no C, as you can see. Now we're using a classic for loop. If we go back to our utilities test again, and we're incrementing I by 1 on each loop iteration. So how can this be? So how can we've actually missed out C in this case? Looking at this code now, can you see where the bug is? Well, here's a hint. Since we seem to be skipping letters when we loop, code inside the loop must also be incrementing I. I bet you can actually see it now. So the if statement is using the increment operator, which is wrong. So the if condition is comparing the character at position I with the character at position I plus 1. But instead of writing I plus 1, we used I plus plus, which not only increments I, but assigns the result back to I. And that's why we're actually skipping over characters. So let's actually change that. Instead of putting I plus plus, we'll change that to I plus 1. So you can see there. So let's go back and run our main method again. You can see now that we're actually getting the entire output, the source string A, B, C, D, D, E, F, F. However, we are now getting an array index out of bounds exception. So now that we've fixed one bug, another bug is detected. So one bug masking another bug is actually a very common scenario in development. Now we didn't see this bug before because we were incrementing I by 2 on each iteration of the loop. And because of that, we were never examining the last character in the array. But now that we're not skipping characters, we try to test the last character in the array against the next character, but of course there isn't a next character, so we're getting an index out of bounds exception. So what we need to do there is, looking back at our utilities class and the remove pairs method, we need to stop at string length -1. But that's not all we have to do. We also need to add the last character to our string builder, because that character is always safe. If it's part of a pair, we've already handled the pair by not adding the first character of the pair to the string builder. Wow, that code was really, really buggy, so it's a good thing we're testing it. All right, so let's actually go and change that, make those changes now, so that we can hopefully fix these errors, and hopefully our unit tests will then start working and we won't get any more errors. So the first thing we need to do is, instead of testing here for string.length, we've got to do string.length take 1. And again, because we're using the +1 on line 44, we need to make sure that we're not skipping too far and getting an index out of bounds. Then also what we need to do after the for loop, before the return, we need to add the final character, which is always safe. So we never need to check it because it's already been checked previously. So that'll be just sb.append, and it's going to be string.length take 1. And then the final return. All right, so let's just go back to our main and run that. We've now got the right output. And if we go back to our unit test, and actually just before we do that, just incidentally, in case you're wondering, where's the second F? Well, we're not actually printing that out. We're not actually getting to the stage of actually outputting that last character. If we really wanted to be precise about it, we could actually print it out here. So we could do print string.length, take 1. You could run that. Whoops. Like so, is what I tried to do. Run that again. We're now seeing the second F. All right, so now that we've done all that, we should be able to go back now to our remove pairs test and run that. And we get success. We've finally got our second challenge complete and working. But there was one other thing we needed to do. If you recall, we needed to test our second input. So let's just do that before we end this mega video. So assert equals, this time it's going to be A, B, C, A, B, D, E, F. And util dot remove pairs. So the output, or the input rather, is going to be A, B, C, C, A, B, D, E, F. By the way, you notice that this is now changing a little bit with this source and expected. This is actually a new feature of IntelliJ. And we're not actually typing that in, but it's just showing you what the proposed inputs and expected values are. So it's really quite useful. That it's a new feature that IntelliJ has added, and here it's actually making a lot of sense. It's telling us at a glance that this is the expected value we're going to get back, and this is the source value being passed to a method. And you'll see that in all aspects of Java development from this version onwards of IntelliJ. So just confirming our output we want back should be A, B, C, A, B, D, E, F, and that's because we're passing A, B, C, C, A, B, D, E, F. So let's test that. And we've got that passing as well. All right, so let's finish this video here now, and we'll move on to challenge 3 in the next video. Okay, so next challenge number 3. So the idea here is to come up with 2 more tests for the remove pairs method. Now, normally you wouldn't stop with the 2 tests that we've run. So it's now time for you to come up with 2 more tests that don't test the same functionality as those 2 existing tests. So take a look at the code and see if you can think of another string that we could pass to test a specific part of the code. And there's also another special input value that we'd want to test, and testing that would reveal another bug in our code. So you don't actually have to write the tests for this part for this challenge if you don't want to. At least just think of what the inputs and expected outputs would be for these scenarios. So pause the video now and I'll see you when you get back. Okay, so let's have a look at our remove pairs method again on screen. So what extra tests could we have here? Well, firstly, we want to test an input string that has a length less than 2. So obviously we're doing a test here if source is less than 2. So we want to put a test in, we'll do that shortly. So that test could be an empty string, or it could be a string with a length of 1, or even both scenarios there. But the other one we'd also want to do is add a test that passes null as the string. Now if we were to run that null test, it would currently fail since we're not checking for null in the remove pairs method on screen, as you can see there. So let's make a few quick changes now to cope with that. So we're going to put if source is equal to null, or source.length is less than 2, then return source. So let's actually try that and go back and add a test for that. So we could do the test here, and again, normally, as I've mentioned, you would do 1 test only per method, but for simplicity in this challenge, I'm going to put them all in this 1 method. So we can do an assert null, and we want to pass null to util dot remove pairs and passing null. So you can see there. So we're passing null, and we should be getting back the value of null. And actually what I did there was And this is again where this new feature of IntelliJ is quite handy. That was actually the message, not the expected value. And of course, because we're using the cert null, we don't need to test for an expected value. The actual method is testing for null. So the message would be, did not get null returned when argument passed was null. So let's just run that. And that's passed, and that's because we've got this test here. If source is equal to null, or it's less than 2, then return source. So because source was null, then it got returned null. Let's fix that as well. And the other one we're going to test there was cert equals. And we'll do a simple test here. We get back A if we actually call utils.remove pairs. util.remove pairs, and we'll pass A to it. So basically that's going to be the test less than 2. We should get back what we passed to it, which in this case should just be an A. So we'll run that test. And doing one more test, let's just duplicate that and pass an empty string to make sure we get an empty string back. Okay, so that's it. That's that test scenario, and we've just made a revision to our code now to cater for or to test for that null. And this would be something that you'll find does happen when you're creating unit tests. You'll be thinking of conditions, and then you'll realize that you haven't tested for a particular scenario, and you'll end up making modifications, as we did here, to our method to make sure that still works. And again, the good thing here is that we've added these extra tests, but the original tests are still in there, and the fact that they're still succeeding tells us that the changes that we've made to the method haven't broken anything, which is, obviously is the whole point of a unit test, to make sure you're not breaking anything when you're changing or adding functionality, as well as testing everything in that method. All right, so let's move on to the next challenge. Challenge number 4. You want to add a test for the every ninth char method. So you want to test the following scenario. So the input, the char array containing the letters H, E, L, L, O in that order, as well as n equals 2. And the output should be the char array containing the letters E and L in that order. So see how you go with that. Add a unit test for that. Pause the video, and I'll see you when you get back. Alright, so since we're now testing an array result, we need to use the assert array equals method. So let's do that in the equal nth char. So I'm going to delete that. The fail method call, because we don't need it anymore. So let's create a new instance of our utilities class. Utils equals new utilities. Then we're going to do char output is equal to util or utils dot every nth char, and we want to pass to that new char array, and the char array is going to be, as I mentioned in the slides, H, E, L, L, and O. The second parameter, n, is going to be set to 2. Now to test this, we actually need to use the assert array equals method. And that's because when testing arrays, the assert equals method only returns true if the arrays are the exact same instance. So it's the wrong method to use in this case. So just to confirm that, let's actually test the array to see that it works. So we're going to use an assert array equals. And if that doesn't come up for you like it hasn't for me, just come over here and click on import static method. So you can see up there. And then what we want to test in here is we need to create a new char array, which would be what the expected output is. So we're going to do a new char array, left curly brace, and it's going to contain the E and the L in the char array. That's our expected result, and the output is what we've got back from the method call on line 15. So if we run that method, that should work. And you can see that's worked okay. And just to confirm, if we do change this to use assert equals, and we try and run that, we do get that failure, and that's because the two char arrays are actually different, and assert equals is only checking to see if the arrays are the exact same instance. So that's the reason that we're using that. So I just undo that change now. Go back to where we were, which was the assert array equals. Running that, and we're good to go again. Alright, so let's move on to the next challenge. Challenge number 5. So add a test for the case when n is greater than the length of the array. So you can add a new test case, or you can actually add the test to the existing test case method. It's up to you as to which way you want to go. So again, write that test that tests the case when the value of n is greater than the length of the string. And you can add a new test case, or you can add the test to the existing test case. It's up to you. Pause the video and I'll see you when you get back. Okay, so for this one, we're just going to put the test on the next line up here. So I'm going to do char output 2 equals, and I'm just going to take a copy of this entire line. So we're going to use the exact same one, but instead of n being 2, we're going to change n to be equal to 8. Then we want to do an assert array equals, and this time the char array we expected is going to be 8 characters, so it's going to be, well, it's actually going to be the entire contents of the array because we haven't got 8 characters in there. So new char, and it's going to be the H, the E, the L again, and the O. So it's actually 5, which is the entire contents output. That should be an output 2. Okay, so let's run that. Okay, and that passes. You can see that we've got the right response there. All right, next challenge. Challenge number 6. So it's to add a test for the null if odd length method. So in actual fact, the challenge is to write 2 tests for that method. Now you want to include both tests in the null if odd length test method. In one of them, pass a string that's got an even length, and in the second test, pass a string that's got an odd length. So that's the challenge. Pause the video. I'll see you when you get back. Okay, so when testing for null and not null, we want to use the assert null and assert not null methods. So let's go down to our null if odd length method test. Remove the file, and we're going to do utilities. Util equals new utilities. Then we want to do assert null first. So assert null util, and it's null if odd length. And we're going to pass an odd length. In this case, the length is 3, which is obviously an odd number. And then we want to do an assert not null. We don't necessarily need to check the contents, just as the fact that it's not null if we pass an even length. So util.null if odd length again, but this time, and we'll just accept that import. We're going to pass even, which of course is a length of 4, which is an even number. So let's actually run that. And our test passes. Challenge number 7. You want to add a test now for the converter method. So test the converter method with the following input and output. So the input should be A equals 10, B equals 5, and the output we should be getting back is 300. So add that test, pause the video, and I'll see you when you get back. Okay, so let's add that test. So we'll remove this fail call firstly from our converter test, and then we want to do utilities. Util equals new utilities. Then we want to assert, and we want to use the assert equals method since both the input and output values are integers. So assert equals, and 300 is the expected response, and util.converter. And we're passing 10 and 5, and based on that, the calculation in the util.converter method, that should return 300. So let's actually run that, and you can see that that's worked successfully. Alright, so I'm going to end the video here. In the next video, we'll finish off the challenges with the remaining 3. So see you in the next video. Okay, so let's work on the last 3 challenges. This is challenge number 8. So your challenge here is to write another test for the converter method that tests the following scenario. Now, by the way, you can add the test to the existing test method or create a new one. Now, the input here is a equals 10, b equals 0. The output, arithmetic exception, divide by 0. So that's the test. See how you go with that. Pause the video and I'll see you when you get back. Okay, so part of this challenge was a trick question, I'm sorry to say. And that's because we can't really put the test in the same test method, because in this case, we're expecting an exception to be thrown. And if we were to put both tests in the same method, it's possible that the test method as a whole would pass, even though one of the asserts was failing. So consequently, we're going to use a new test method, and we'll modify the org.junit.test annotation to let JUnit know that we're expecting an exception to be thrown. So let's go ahead and do that. So I'm just going to add this code below the first converter test method, and we'll call this one public converter arithmetic exception. And it throws exception. And the annotation for that will be at org.junit.test. That's going to be expected equals, and it's going to be arithmetic exception dot class. Okay, and then the test is going to be utilities. Util equals new, utilities. Then util dot converter 10, 0. And if I've got a void there, void, and that keeps it happy. All right, so we'll run that and see what happens. And we can see that successfully passes. And just to confirm that, obviously we're past 0, which is causing the arithmetic exception. If we change that to 1, we should run that again. This should now fail because the exception isn't being thrown. And you can see we are getting expected exception to be thrown and we didn't receive one. So I'll put that back to 0. And it's working fine. All right, next challenge. Challenge number 9. Now, for this challenge, we want to reduce some repetition. All of our test methods are now implemented and our tests are passing. We'd want to write more test cases to cover scenarios that the existing ones don't test, but we'll pretend that we're actually done and we have covered all scenarios. Now, we could stop here, but every one of the test cases starts by creating an instance of the utilities class. So the challenge is to modify the utilities test class so that it doesn't have this repetitive code. So that's the challenge. Pause the video and I'll see you when you get back. Okay, so for the solution, what we're going to do is we're going to add a method to utilities test that's annotated with the at before annotation. And that method will create an instance of the utilities class, and we'll also have to add a utilities instance field to the class as well, so that the test methods can access the utilities instance. Now, since the at before method will run before every test case, every test method will start with a fresh instance of the utilities class. So let's go ahead and do that. So I'm going to start by adding this field, this instance field. So it's going to be private utilities, util. Then we're going to create this method, public void setup. And for the code for that, we util equals new utilities. So creating that new instance. And then we'll annotate this with the at org.junit.before, which tells JUnit now to run this before every one of our tests. Then what we also have to do now is change the code now that is creating a new instance, just by deleting that line. And I've called that utils, and I've called it util here. So I'll just change the references that I called it to utils in the method there. So that's our every nth character method or test method fixed. Same for the remove pairs. The converter, delete that as well. And lastly for the converter, well actually we've got one more after that, delete that. And also the null if odd length. So we've now got no code that actually creates that utilities class instance other than the code on line 15, and we've actually removed all that repetitive code. And removing repetitive code is always a good thing when you're a developer. Let's now run the entire test suite, because I don't think we've done that yet, just to make sure that it's all working. And actually what we need to do here is just come up here to see that we haven't actually got an individual test for the entire suite now. So we'll actually click on that, right click and run utilities test to run the entire suite. And you can see that all 5 tests are now running successfully. And of course now we've done that, we've got a configuration to be able to run all our tests. So everything's working fine. Alright, next challenge. Challenge number 10. So we want to actually test the following 5 scenarios that you're going to be seeing on the next slide with the remove pairs method. So we're going to test the following inputs and outputs. Now you could add all these tests to the existing test method or write a method for each set of input output, but that probably wouldn't be the best way to do it. So you want to do it in such a way that you only have to write one test method, and as a hint, you have to create a new class that's using a particular JUnit annotation. So you can see the inputs and the outputs on this screen. So take a note of those, and you'll be testing those to make sure that you're matching the input and output and that all your tests work. Alright, so see how you go with that. Pause the video and I'll see you when you get back. Alright, so the solution really calls here for a parameterized test. So what we're going to do is create a new class called utilities test parameterized and annotate it with the at runs with annotation. So let's go ahead and do that. New Java class, utilities test parameterized. We're going to annotate it with the at run with, and the parameter here is going to be parameterized.class. Now we're going to declare some instance variables for the utilities instance, the input value for each test, as well as the expected value for each test. And we'll also declare a constructor that will accept the expected value, the output in other words, and the string parameter, the input. Remember that for each set of test data, JUnit will create a new instance of the class and pass the expected and actual values to the constructor. Okay, so we want a private utilities, util, private string input, private string output. We want a constructor, and the constructor should accept both the input and output. So I'll select both of those, and they'll both be set. So now we're going to add the method that contains our expected and actual values. And we have to annotate this method with the at parameterized.parameters annotation, and also, if you recall, it must return a collection. So it's going to be public static collection object test conditions. Then we're going to do a return arrays.asList, a new object, and 2 square brackets, 2 pairs of square brackets, and then the actual parameters themselves, which will be, for the first one, A, B, C, D, E, F, F. Then it's A, B, C, D, E, F. For the second one, A, B, 88, E, F, F, G. Then A, B, 8, E, F, G. The third one, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Oops. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. And the expected output should be 1, 2, 3, 4, 5, 6. Then the last one should be A. And to fix that, we need to specify that's an array there. All right, so that's our collection now, our test conditions. And now we need to also add a setup method that's annotated with that before, and also our test method to actually do the testing. So let's go ahead and do that. And I'll set up the at before at the top here, below the constructor. It's going to be a public void setup util equals new utilities. So we've got our new instance of our utilities class. We'll annotate that with @org.junit.before. And then, as I mentioned down the bottom, we want to test. So it's going to be public void remove pairs, throws exception. We'll annotate that with a test @org.junit.test. And the test itself is going to be assert equals output util dot remove pairs input, and we'll accept that import, and that should be it. So let's just run this to confirm that it does work. And what I forgot to do was add the annotation for the test conditions line. So let's go ahead and do that. Of course, we need an @parameterized .parameters annotation for that to be valid. So now if we go back here and actually run this, so you can see now that we've got these 4, 0, 1, 2 and 3. So we've actually had our 4 tests and they've all passed separately, and we're good to go. And as you also saw, that created a new run configuration for that method. If we wanted to, we could just right click, even though we've just got the one test, and run the utilities test parameterized, and that would create the run configuration so that any future tests would also run, and we wouldn't just have to click on the one in the gutter to run the individual one. Alright, so that's it. You've now completed the JUnit challenges, and that's the end of this section. Hopefully now you've got a much more solid understanding of the basics of JUnit, and you can start applying that into your Java projects. So in this section of the course, we're going to take a look at databases. And we're going to start with an overview of what databases are, and go ahead and install SQLite, which is a free and open source database tool. And then we'll go through an overview of SQL, or also pronounced SQL, which is a database language used to communicate with databases. Now we're going to be using the command line initially as we start using SQL and SQLite, but then in later videos in this section we're going to progress and move over to Java and start on how to use databases from Java and actually writing programs to manipulate databases. But we really need to have this basic understanding of databases and SQL before getting to the stage of writing code in Java. Now if you've got some history with databases, you might be wondering why am I using SQLite and not MySQL or some other database? Well, the reason is, generally speaking, the skills that you'll learn with SQLite apply to any database, including MySQL. So the SQL code that you'll learn, as well as the Java code that you'll create in this section, requires very little change to work on literally any database. Now SQLite is ideal to get started with. It's a very small download, it's a very simple package, and it's really highly used. In fact, it's almost one of the most highly used programs in the world, believe it or not. And I've actually put together videos in this section showing how to get it working on Windows, Mac and Linux as well. But just to make sure that the course is really complete in this section, towards the end of the section we're also going to get MySQL up and running as an exercise, so you can see just how easy it is to switch to another database and what changes, if any, are needed to get that to happen. So anyway, let's get started. So let's go through some common database terminology that should be useful for you when we're working with the databases in this section of the course. And the idea here is that it'll make it a lot easier to understand the app when you understand what the fundamentals are and what all the actual various terms mean. You know, at the very basic level, the database is the container for all the data that you store or that resides inside it. Now, when you use the term database, you're referring to the entire data as well as the structure it's actually stored in, and in addition, any queries and views on that data. Now, in SQLite, the entire database contents are stored in one single file, but that isn't true of most large database systems. Now, the database dictionary provides a comprehensive list of the structures and types of data that are used in recording the data. So it basically describes all the tables and fields within the database. Now, more on the specifics later, but in SQLite there is a table in each database called SQL_Lite_master that has this information in it. Now, you can query that table, but there are commands that do it for you, so you don't have to understand the structure of the master table. But it's there for you anyway, and as we go through, you will see how these commands actually work. Now, a table is a collection of related data held in a database. So think of a contact database, for example, that stores the name and the address and the phone number of perhaps your customers. Or what about an invoice table that records the invoice number and details of the invoice? So on this slide there are two tables, contacts and invoices, that are used to store information about contacts and invoice details. Now, with SQLite databases such as SQLite or another database like Microsoft SQL Server, they're ideal for storing structured data that can be organised neatly into rows and columns like you can see in these examples. Now, with all the interest in big data, there are now databases such as NoSQL or Hadoop that can cope with data that doesn't have such an obvious structure, but we're going to be restricting our use of database to structured data. So a field is the basic unit of data in a table. So a field in a database can be thought of probably in a similar way to what a variable is, and you've seen those obviously. And just like a class variable, a database field has a name and a type. Now, the type restricts what kind of data can be stored in a field. For example, it could be a string or it could accept numbers. Now, many databases also allow date fields, large text fields, and also fields where you can store things like photographs or audio. And these field types are often called blobs, which is supposed to stand for binary large object. It's a great name, and I can't help thinking that the original acronym was something like LBO for large binary object, and they came up with a cooler sounding name afterwards. Now, fields are often referred to as columns in databases. I know this can be technically confusing sometimes because if you come from an Excel background, you'll find that the definition is probably a bit different to what you think of as a column. Now, in a spreadsheet, the term column refers to an entire set of data extending across many rows. But in a relational database, column generally refers to a single entry, although when talking about the structure of a table rather than the actual data, then you could talk about a column to hold the invoice number, which is probably closer to the spreadsheet use of the term. Now, when referring to the data in a database, though, we're talking about an individual item, like a base unit of data. Now, relational databases existed nearly 10 years before the first spreadsheet program, and we just have to accept that column means slightly different things in each case. But more on that shortly. Now, a row or record is a single set of data for all fields that are in that table. So if you've got 4 columns, like the example on the screen, and if your table has an invoice number, a date, a description, and an amount, then a row represents those 4 values for a single invoice. So it's really a collection of all the columns that comprise the details of one entry in that table. So the highlighted record holds the details for invoice number 2, which was a laptop costing just over $1,000, sold on the 24th of May 2016. And you can use either of the terms row or record to identify it, but the correct relational database terminology is actually row. Now, a flat file database stores all the data in a single file, which can result in a lot of duplication of data. Now here, ISP's credit limit needs to be increased so that they can purchase the monitor, as otherwise that can actually go over the limit. So in order to increase the limit, the data in 3 rows would have to be modified. Now, as you can see, every row in the table that contains a record for ISP must be changed in order to increase the credit limit. So flat file databases are not used very often anymore, but they were fairly popular in the early days as they directly mapped to those card index records that companies sometimes used. Now, if we were storing names, addresses and phone number type information, then a flat file database is fine for the job, and even today people still use address books and Rolex style contact systems with each person's details on a different card. but there isn't really much need to relate the individual cards to each other. This works perfectly well. Now, as you can see from this invoice example though, trying to store all the data in a single table results in duplicate data. Now, using a relational database, tables can be related to other tables, which is very useful. So continuing on with the invoice example, we can split the data out into a customer table which contains standard company data such as their name, address and a credit limit, and another table called invoices containing all that customer's purchases. The name column in the customer table is related to the name column in the invoices table. Now, in relational database terms, this is called a join. In fact, in this example, we have a one-to-many join because there can, and probably will, be many invoice rows for each customer. Using a relational model, updating a customer's credit limit involves changing the data in just a single row. So there is a mechanism to join these two tables to link the individual records in each table to each other. And you'll often see designs where a third table was used to provide the link, as in this next slide. And it's also very common to use a linking table to relate the data to two other tables. Now here, when an invoice record is stored, a new record is created in the customer_invoices table to link, for example, invoice 0004 with customer ISP. Now, one advantage of this is that the invoice table only contains data relating to invoices. The rows are not cluttered up with customer information of any kind, not even the customer name. Splitting the data up like this is known as normalization. Now, database normalization is basically the process of removing redundant, duplicated and irrelevant data from the tables, and the more that this is done, the higher the level of normalization. If you look into normalization, you'll find that you can go up to level 6, sixth normal form, but in most practical applications, it's rare to go beyond the third level. Now, it's an interesting subject, but the maths can get a bit horrible at the higher levels. Our example on the slide isn't quite as normal as we should be because we've used the customer name as the link between the customer and invoice tables. Now, if one of our customers changed its name, which is quite a common thing to happen, then we'd have to update each of the relevant entries in the customer_invoices table as well. Now, the usual way to deal with this is to use a unique ID field that stays the same for each customer once it's allocated. Now, we shouldn't store the customer balances in the table as that's best calculated when needed. So a view is a way of looking at the data in a format similar to a table, but bringing data together from more than one joined table. So in this example, the view contains columns from the customer table and the invoices table. So a view can just contain just some columns from a single table, for example, just the description column from the invoices table to produce a list of items that have been sold. Now in SQLite, the data in a view can't be updated. So that means that you can't add a new row to a view and have it place the new data into the relevant tables. Now, some databases such as Microsoft SQL Server do allow this, but in that case, the views do have restrictions on the columns that can and must contain if they're used in this way. So that's not something we need to worry about because we can't do that in SQLite. Alright, so that's enough to get us started, and we're going to explore these terms more as we go through SQLite. So coming up in the next videos, we're going to discuss a few more database concepts, and I'll be going into more detail. We'll be using practical examples and actually using the SQLite database. Now, SQLite is designed to be embedded in applications and is actually a library that's called from our application code. It does ship with a shell program that you can use to create databases and interrogate them though, and we'll start off by using that to explore the commands available in SQLite. Now, before we can use that shell program, we need to make sure that it's available on your system's path. So the next 3 videos are going to show you how to do that for Windows, Mac and Linux. So there's one video for each operating system, so follow the instructions in the relevant video for your operating system and you can skip over the videos that aren't relevant. So I'll see you in one of those videos. In this video, we're going to install the SQLite 3 command line shell for Windows computers. Now, if you're using a Mac or a Linux machine, skip to the next video or the video after that for your operating system. But if you're in Windows, you're in the right place, so let's make a start. The thing to keep in mind here, though, is that writing database code straight away isn't the easiest way to learn about SQLite and the SQL language. Now, if you get errors, you have to work out if it's the error or the errors in your code or in the SQL statement that you've used. So what we're going to do to start is we're going to start by installing the SQLite command line shell so that we can create databases and use SQL commands without having to worry about code yet. On Windows, the SQLite command line shell is an executable file called SQLite3.exe. So in this video, we're going to see how to download that executable and add it to our computer's path so that we can use it. First things first, we're going to go to the SQLite website, www.sqlite.org. And you can see at the top when we get there, there's a download link, so I'm going to click on that. Now, there isn't actually an installer for SQLite. Instead, it's packaged into a number of zip files. The file we want actually is a bundle of command line tools for managing SQLite databases. You can see we've got one here. We've got an OS X version there. And down here, we've got a Windows version here. A bundle of command line tools for managing SQLite databases. So I'm going to click on that link now. Bearing in mind that when you're watching this video, the version number may have changed. But that's all right if it's a later version. I click on that one and leave that downloading. It's actually finished. It was quite a quick download. I do notice that the description for this file includes links to the 3 executables. Over here we've got the command line shell, the SQLdiff.exe and SQLite analyzer.exe. So I suggest you bookmark this page so that you can come back here and check those links out in the future. But the tool we need at the moment is the command line shell. So what we need to do now is extract the contents of the zip file to a suitable directory and then add that directory to our path. So what I'm going to do is just go to the folder where that SQLite file was opened, and you can see that I've actually got SQLite tools there. So I'm just going to extract all, extract it currently in that current path for now. And it's quite quick because it's only a small file. And what I'm going to do now, we're going to move these. I'm going to right click the folder that was extracted. Okay, so I'm going to cut that folder. Then what I'm going to do, I'm actually going to put this in my users like sort of main home folder. Now you can put this in the program files directory or somewhere else. Doesn't really matter. But for simplicity, what I'm going to do is just go to my local disk, go to my users and Tim, which is the folder that I'm going to put it in. I'm going to actually save it in there. But again, the choice is yours as to where you want to save it. So I'm going to right click and do paste, put it in there. And that's now the folder. It moved over. And we double click it now to open the folder. And what we can do up here is we can actually come up here and click up into the address bar, and I can click on Control C. And that's actually going to take a copy of the path, which we can use to actually update the path on the computer. Now the instructions to set the path start off slightly differently depending on which version of Windows that you're using. I'm using Windows 10 here, and if your keyboard's got a Windows key, the quickest way for all versions of Windows is to use Windows and pause. So I hold down the Windows key and press pause, which I'm going to do, or click pause. That brings up this window here. Otherwise, you'll just need to navigate to the control panel, System and Security and System on your version of Windows to get access to it. And then from here, we can actually click on the Advanced System Settings on the left there. So I'm going to click on that. That takes you to the System Properties dialog, which is where all other Windows versions should already be. So basically, a couple of ways to get there, but the bottom line is you want to get to this location. And from here, what we want to do is click on Environment Variables. And just a quick note that if for some reason you couldn't get there with the Windows key, you can actually just right-click the My Computer icon on your desktop and choose Properties, and you're there as well. Alright, so we're actually here now. And what we want to do is come down here to where it's got the Edit button, making sure that the path is selected over here under User Variables. Now, unless you're really comfortable with doing this, leave the System Variables section down here at the bottom completely alone. If you mess up the system path variables, it can be really quite difficult to recover Windows, so you can get into difficulties, so suggest you don't touch that area. But under the user variable, there may or may not already be a path variable, as you can see here. In my case, it already exists, and I've actually got my Python installation actually in the path, but if yours is not there, you don't see a path variable, you'd click on New, then you'd actually specify the path name as path, the word path, and then you'd type in the value or paste in the value like here. So you'd put those details in, but in my case, because the path already exists, I'm going to click on Edit. So select Path and click on Edit, And what we're going to do now is actually add the path. Now, this is actually showing a new path variable being created on Windows 10. Now, if you're editing an existing path variable, leave the name unchanged and just add a semicolon to the end of the previous value. So there's a couple of ways of doing it, but this is the new way on Windows 10, where you just click on New, and you can just actually paste in the value there. All right, for some reason the Control C that I did didn't work. So if I just go back to the Explorer again, I can actually just go into there again, make sure that that's actually showing like that. I think that's what I didn't do last time. Do a Control C there, or I could do a right click and do a copy if I wanted to that way to copy that entire path. And then if I go back now to the System Environment Variables area, I click on New, I can paste that in, and that's now the variable that's been added. So either way, whether you've got the option to do it this way, or you've got an older way, you may just be shown the entire path. If you've got the older way, go to the end of the paths settings, the various paths that are defined in your system, put a semicolon there, then paste in the value. But in this case, this is the new way that Windows 10 does it, where you just select New and you enter another value there and click on OK. And what's happened now is that Windows 10 has actually updated our environment variable, so I can click on OK, close that down, I can click down OK there. Alright, at that point the path's now been set. So what we can do now is check that the SQLite command line shell is working. So the easiest way to do that is just to come down to here. You can either just type it in there if it's under Windows 10, type CMD. Alternatively, you can actually click on right click on the Windows startup image down here, right click that and select run and then type CMD. Either way you'll get to the command line prompt like you can see on the screen there. And what we can do now is type SQLite3 just to verify that SQLite 3 is working. And you can see that it's actually working. It actually came up and started up for us, so that's good. And as we can see that things are now working nicely. And keep in mind, you may see a slightly different version number showing on the screen to what I've got here, but that's okay, so long as it actually works. It means that the SQLite command line shell is now ready to go, and we can start using that in future videos. Alright, so type in .quit to get out of SQLite 3, then type exit to close down the command prompt window, and at this point you're good to go. SQLite 3 is installed on your Windows machine. So unless you've got a Mac and a Linux machine also, you can actually skip the next two videos and move on to start where we actually start using SQLite 3. So I'll see you in that next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
So in this video, we're going to see how to run the SQLite command line shell on a Mac. Now, if you're using Windows, refer to the previous video. And if you're using Linux, then actually refer to the video after this one, where we actually set it up for those relevant operating systems. But if you're on a Mac, you're in the right place. Writing database code straight away isn't the easiest way to learn about SQLite and the SQL language. If you get errors, you have to work out then if the error's in your code or in the SQL statements that you've used. So what we're going to do is we're going to start out by using the SQLite command line shell so that we can create databases and use SQL commands directly. Now on a Mac, it turns out this is really, really easy, and that's because the SQLite command line shell is already installed on a Mac. So there's really nothing else we need to do to be able to get that up and running. So just to confirm that it is working, open a terminal session, and you can do that by holding a command and pressing space. That'll open that screen up there, and we can just type in terminal, press enter, and that loads the terminal screen. And to test that we've got a SQLite, that SQLite's installed, we just type SQLite3 in lowercase, press enter, and you can see that we've got some text showing on the screen there. So you can see that SQLite 3 is actually successfully installed. Now, don't worry if you see slightly different version numbers there. This program is updated from time to time, but so long as you actually can see that it has started a program and it looks like it's working, then we're good to go. So at this point, we can quit out of this by typing .quit. And I'm going to type exit to close down the command shell, and I'm just going to close down the terminal window. And at this point, we're good to go. So skip the next video, unless for some reason you also want to install SQLite 3 on a Linux machine. And the video after that will then actually go ahead and start using SQLite. So I'll see you in the next video. In this video, we're going to install the SQLite command line shell for Linux computers. Now, if you're using Windows or a Mac, refer to the previous two videos where we actually set it up for those platforms. But if you're running Linux, you're in the right place, so let's get started. Writing database code straight away isn't the easiest way to learn about SQLite and the SQL language, because if you get errors, you'll have to work out if the errors in your code or in the SQL statements that you've actually used. So what we're going to do is we're going to start by using the SQLite command line shell so that we can create databases and use SQL commands without having to worry about code at this stage. Now on Ubuntu Linux, turns out this is really easy. So I'm going to start by opening a terminal session. So I'm just going to use the shortcut on Ubuntu, which is Control-Alt-T. That opens the windows you can see there. Obviously I could have just come up here and just typed terminal in there and opened it that way as well. Alright, so installing SQLite 3. Firstly, we check to see whether we've got it. We type SQLite3. You can see that it's saying that currently we haven't got the program installed. So again, on Ubuntu Linux, we do a sudo space apt space install space SQLite3. Press enter, type in the password. And you can see that was a really quick installation. It's only a small program because we're only getting the command line shell, not SQLite itself. At this point, we can then check to see whether SQLite 3 is installed. We're typing SQLite3. And you can see instead of getting an error like we did previously, we can now see down the bottom it's showing the SQLite version number, .help for instructions, etc. And incidentally, you might see a slightly different version number to what I've got on the screen, but that's okay, so long as you can actually get it working. And you can see that we've actually started the SQLite command line shell, you're good to go. And just keep in mind, specifically with Ubuntu, I'm using 14.04, but if you're using Ubuntu 16.04, you will actually get a much later version, but both versions will actually work fine with the course. There's no prerequisites for a specific version of SQLite 3. Alright, so at this point we've completed the installation, so I can type .quit to get out of the SQLite 3 command line shell. Type exit to close down the terminal session. And at this point we're done. So let's now move on to the next video where we're going to go through a bit of an introduction on using SQLite. See you in the next video. So we've got the computer set up so that we can use SQLite from the command line. We're now going to have a look at how to create databases and tables and start to see how the SQL language is used. So we'll be using SQLite in our programs later, but for now we're just going to focus on the SQL language so that we can concentrate on learning a bit about SQL without worrying about the Java side of things. So you need to start a terminal session or command prompt on your computer. On Windows, click on the Start menu and type command to launch a command prompt, or you could just use the same method that I used in the setup video to start a command prompt for Windows 10, depending on what version you're running. On a Mac, command space and type in terminal, and on Ubuntu Linux, you can launch this terminal quickly using Control-Alt-T. Alright, so I'm on the Mac as I said, so I'm going to start SQLite, and the way we start that is by typing SQLite 3, so SQLite and the number 3, and press enter. So that starts the SQLite shell program, and we can also specify the name of a database on the command line. So I'm going to show you how to do that. So I'm going to quit out of this by typing quit. Sorry, it should be .quit. So .quit. So as I mentioned, we can specify the name of a database on the command line. So I'm going to call this database test. So to do that, we type in a space after the SQLite 3 program name and then type test.db and press enter. And incidentally, there's also a command to open a database file if you forget to put the name on the command line, and we'll have a look at that a bit later. You will find that this SQLite program is a fairly minimal interface that just really tells us the version of SQLite that we're using, and that we can use .help to get some instructions. We can also enter SQL statements, and with some versions there's also a helpful reminder that SQL statements must be terminated with a semicolon. And you can see earlier I put in a semicolon to finish off the command quit, but the quit was meant to be a .quit, which doesn't have a semicolon. But in any event, we'll talk more about semicolons and the need to put those in a little bit later. And it is normal that you'll forget to do this quite often. You'll forget to put a semicolon in, but as you'll see, it's not the end of the world. You can just enter the semicolon on the next line and the statement will then be executed. but we'll go through that in a minute. But let's start off though by typing .help. And you can see that SQLite is helpfully telling us that if we type .help, we'll get some help. So we'll do that. .help, press enter. And you can see we've just got a whole page of information on the screen there. And I'm just scrolling up and down with my mouse. There's lots of different command options there available for us. Well, I say a lot, but really, in the scheme of things, it's not really a lot of commands there. Comparing that to the Java language, there's a significantly higher number of things you'd need to know in Java than SQLite. But even with that said, you probably won't remember them all straight away, if ever though, so the .help is a useful way to remind yourself of them if you ever need to go back and see what a particular command's all about. Alright, so before creating a new table in the database, you want to type in .headers space on. Now this actually shows the column names at the start of the data, which is a handy reminder of what we called the columns. Okay, so those are a list of the commands that SQLite recognizes, but when creating and querying tables, we just use SQL statements. So let's create a simple contacts table with the SQL command we're about to type. So I'm going to type in create table contacts, left parentheses, and we're going to type name space text, comma, phone space integer, comma, then email space text. Then we want to put a right parentheses and a semicolon. And then I'm going to press enter. Now that doesn't seem to do much, and that's something you'll notice with SQLite. If you do something wrong, it will let you know, but if everything works fine, then it just keeps quiet. So in this case, because we haven't got anything back other than the prompt asking us to type in something else on the next line, it's nice and quiet, and that generally does mean that the command worked. So in this case, it's created that table for us. Now that table called contacts has 3 columns: the name, the phone, and the email, but SQLite doesn't tell us that it worked. And again, if it hadn't worked, we'd get an error, but otherwise we can just move on to the next instruction. Alright, so with this table now, let's actually put some data into that table, and we can use the SQL insert statement to do that. So we can type in insert into contacts. I'm putting a space there, and then left parentheses, name, phone, email, then right parentheses, then space, values, left parentheses, and single quote, Tim, comma, 65456778, just a number, and an email address, so tim@email.com. Single quote, right parentheses, and semicolon. And press enter. Once again, we get no confirmation that it worked, but in this case, no news is good news. And I use single quotes there, but you can also use double quotes. The thing to remember though is if you're embedding SQL commands in Java, then it makes sense to use double quotes for the strings and single quotes around the SQL statements. And you'll see me do that when it comes to creating programs that work on our databases. Alright, so how do we know that this actually worked, or these commands actually did something? Well, we can actually check that it has. We can query the table. Now the select statement is very useful in SQL or SQL, and it's how you query the data in a table. Now it's a very flexible command, but at its simplest, you can just tell it what columns you want and the name of the table to get it from. Now I'm going to actually type the SQL reserved words in capitals in this statement. And it's actually useful to do that, especially in programs and scripts, but SQL itself doesn't care. People generally just do it to make it obvious which are the SQL reserved words and which are things like tables and column names. So to see what's in our contacts table, we use this. We type select, and again I'm typing that in uppercase, space and then a star, space from, and then contacts, space again, then contacts, and a semicolon, and press enter. And we can now see the record that we just inserted. Now the asterisk there, by the way, means all columns that you saw me type in the select statement. We could have been more explicit and typed something like this. So select space name, phone, email from contacts. And that would give us the same result. And if we just wanted email addresses, for example, we could just do select email from contacts. And that would just give us the email. Alright, so I'm going to do that command again, but this time I'm going to forget to put a semicolon on the end. So select email from contacts, press enter. Now you can see that nothing's printed, and SQLite has just to put another prompt up waiting for more input. And notice it's got the 3 dots and then the greater than sign here rather than the SQLite greater than that normally starts the command prompt when we're about to type a command in. Now you can add other clauses after select, and it's nice to be able to split them onto different lines to make it more readable. So SQLite will keep letting you type a SQL command and won't try to execute it until you type the semicolon. Now at the moment I don't want to add anything to the statement, so I'm just going to enter a semicolon and press enter. The statement executes, as you can see, and we get the email address for our one record. So when you forget the semicolon, just type it on the next line and generally everything will work fine. Okay, so let's add a couple of additional records. I'm going to use double quotes for the first one just to show you that it still works fine. So insert into contacts, values, Brian, 1234, and we'll put Brian at myemail.com. Notice that that's a slightly different form of the insert statement. And because we're providing values for all the fields and giving them in the order that the fields were defined in the table, there's no need in this case to specify the list of fields. So it actually works out to be a bit simpler. But if we try this, insert into contacts, values, Steve, 87654, and type a semicolon and press enter, we actually get an error. And obviously that's because we've only specified 2 values, but the table contacts has got 3 columns like it's telling us on the screen. So I could fix that by adding another value, but if we don't know the email address, then that wouldn't be an option. So instead I can tell it which columns I want to add data for and just provide the value to insert into those columns. So I can do something like insert into contacts, name, phone, values, Steve, and 87654. And you can see there's no error in that case. And we can now check what's in the table. So let's have a look at that. So select star from contacts. And you can see we've got 3 entries showing on the screen now. And note that Tim and Brian have email addresses, but Steve hasn't. Now incidentally, you can see the column names appearing at the start of the list, and that's because we used that command .headers on earlier. Without that, we'd see the data, but the columns wouldn't be labelled for us. And that's maybe not that important in this example, as there are only 3 fields and they all contain obvious values. In other words, it's easy to see that Brian is a name and Brian at myemail.com is an email address. But if there are a lot of, say, numeric fields, then it could be useful to have a reminder of what's in each column. Now, talking about numbers, we probably shouldn't store the phone number in an integer column. I just did that to show you how you can specify the type of columns when you create the table, but a phone number is really best stored as a text field. Now, SQLite doesn't actually have types for its fields. It's strange in that respect. Although you specify a type when defining the columns, that's really just what you intend to put into them. And in fact, because it's a SQLite implements standard SQL, it has to use that standard formula for creating tables where the columns have a data type. But you can actually put any kind of data into any column. And we'll look at doing that when we continue this in the next video. Alright, so I ended the last video by saying that we can put any kind of data into any column in SQLite, which is a bit strange. So let's actually try doing that. Now what I might do though is just clear, and I need to do a .quit, and I'm just going to do a clear, and then just go back in so we can sort of see this at the top. It's a little bit easy to read. And I'm just going to do a select here, select star from contacts. There's our 3 records. So let's now try and put in any kind of data into these columns. So I'm going to type in insert into contacts, values, we'll try Avril, +61 087654321, Avril at email.com.au. That would have worked, but I forgot the semicolon. the semicolon in there. Now it works, I've just put string data into an integer column, which is actually, believe it or not, is fine in SQLite. Just to confirm that, we'll do a select star from contacts. And there's our record. You can see the string number that we put in there for the second entry here, which was numbers in all other cases, has worked quite happily. So we'd entered a string where a number would ordinarily have been placed. Now, as a programmer, you might actually be horrified by what you've just seen. And in fact, doing things like that can cause problems when you try to get at the data back from a program. Now, if your code tries to put that phone number into an integer variable, then it is going to crash. If you switch databases and try to use the same code in, say, Microsoft SQL Server, then it won't work either, because the main client-server SQL databases do actually check the type of data that goes into columns. So make sure you use an appropriate type for the columns when you create your tables. Now, one thing that SQLite lacks is an alter table command for changing things like the type of the columns. There's actually ways around that, creating a new table and moving the data from the old table into it, for example, but it's really best to get it right first time. Alright, so now we know how to create a table and to insert some data or some rows into it. But we can also update the data that's in there. Now, firstly, I'm going to use the .backup command to make a backup of the table. You'll see why in a minute. Now, the command is .backup, and then you tell it which database to back up, then the file name you want to back up to. If you don't tell it which database you want to back up, then it does the current one, which is fine and makes the command very easy to use. In this case, I'm just going to do test backup, like so. Now notice that this is a SQLite command and not a SQL statement, so there's no need to put a semicolon at the end. If it starts with a dot, it's a SQLite command, dot first or semicolon last, but not both. So I'm going to press enter there. Alright, so I've backed it up. So moving on, let's say we now have Steve's email address and we want to update his record in the table. Now we actually do that using the update statement. So we type in update contacts set email equals Steve at hisemail.com. So here I'm updating the email address in the contacts table, but you actually have to be careful with this command. I haven't at the moment told it which row to update, so it's going to update every row in the table. So I'm going to add the semicolon now and press enter. And now if I type select star from contacts, you can see what's happened there. Everyone has the same email address, which is almost certainly not what we want to happen. So the update command is a very powerful command, and a single SQL statement can update hundreds of thousands of rows in a database. So you want to be very careful when using the update command, especially in an interactive session like this. You can render the data in your database useless, and believe me, I've done it. I've updated tens of thousands of records when I only intended to update one in a production database before, and just without going into too much detail, caused a lot of grief for all concerned. But luckily this time, I backed up the database first, so we can get it back and do the update properly. So I can type in .restore test backup, and then I can actually check the data's back by doing select star from contacts. And you can see we've got our data back with the original entries. Alright, so how do we update just Steve's record? Well, to do that, what we need to do is we still need to use the update command, but we need to add a where clause. So I'm going to type in update contacts set email equals Steve at hisemail.com. And the extra part here is where name equals Steve in semicolon, and press enter. Now that's more like what was required, only Steve's record has now been updated. So that's how to use a where clause. It's just the word where followed by a condition that identifies a row or set of rows to be updated. And you can probably see now that's why backups are also very important. Now a where clause can be used with many SQL statements, so you could display just a subset of the data by using a where clause with the select statement. We'll just do a search for, or do a select rather, to make sure all the entries are there, and we've got his email address has been updated. You can see they've all got individual email addresses, and Steve's email address has now been updated. So we can also use that where clause in a select statement. So we can do something like select star from contacts where name equals Brian. And you can see that that's come back and showed only one entry. Perhaps more useful though, if we already know the name, there's no point retrieving data that we don't need. So we could do something like select phone email from contacts where name equals Brian. You can see that just returns the email, the phone number and the email address. So that's select, insert and update, and we can also delete records. No prizes for guessing what the command is. You got it, delete. So delete from contacts. Now once again, we have to be very careful here. Without a where clause to specify which rows should be deleted, the command will apply to the entire set of rows in the database. And yes, I have done that as well. So putting the where clause in here, where phone equals 1234. And we know that 1234 was the phone number that we entered for Brian. So I'm going to press enter there. Then I'm going to do a select command, select star from contacts. And you can see that Brian is now missing from that list. And that's because we've deleted his record by using the delete SQL statement and using the where clause which specified his phone number. So we've now seen a few SQL statements: create, insert, select, update and delete. Now these are the most common commands that you'll need, and you can do a lot with SQL databases with just those commands. Now there are a few ways to modify the commands, especially the select statement, and we'll be having a look at using join in the next video to relate tables together. But that's the basics, and hopefully you feel a bit happier now about having to learn a new language, and you've seen that it's really not going to be perhaps as difficult as you thought it might be. Working with SQLite from the command line like this is very useful because you can concentrate on the details of your tables and columns and get everything right before trying to include the commands in code. And it gets better too because there's a couple of SQLite commands that you can use once everything's set up. So let's have a look at a few of those. The first one we can type is .tables. And .tables lists all the tables in the database, which can be handy when you have a lot of them and forget what you've actually called one. The next one, .schema. And that prints out the structure of your tables. Now we only have one table in this database, but you can see how it shows the SQL command that was used to create it. So you can copy that command and paste it into code when you want to create tables in code or create that table in code. And if you've got several tables, then .schema followed by a table name will print the structure for just that one table. And there's also .dump. And that not only gives you the SQL statement for creating the table, but all the inserts necessary to populate it with the data that's in it. So it wraps the whole thing in what's called a transaction. You can see we've got the begin transaction and commit there. And we'll be talking about that a little bit later, but again, you can copy and paste the output from dump into your code. And finally, .exit or .quit will actually exit the SQLite shell and take you back to your command prompt or terminal session. So that's a basic introduction to SQLite and the SQL language. Now the SQLite shell is useful when you need to design your database, and it's generally easier to use some sort of front end to the database when setting things up so that you can make sure you've got all the tables created correctly with the right columns and so on. You can also test the queries that you'll be using in your code before you get around to writing the code, so you know that the SQL side of things has been set up correctly and is working okay. So we've now seen how to create tables and insert, update and delete the records in them. And we've also had a brief look at querying the data in a table. So in the next video, we're going to work with a database that already has some data in it, so we can practice querying data a bit more and also look at how to join tables together. So we'll see you in that next video. In this video, we'll continue looking at querying the data in a SQLite database. Now, we've seen basic SQL queries using the select statement in the previous video, and it's time to look at that in more detail. Now once we've used some more queries, we're going to look at how to store commonly used queries in what's called a view. Now the idea of views is common in most relational databases. And I'm also going to introduce the SQL join clause and show how that's used to link tables together. And that can result in quite complicated queries, so we'll also use views as a way to store a query so that we can reuse it whenever we need to. Now our previous contacts example only had a few records, and using a database to store a handful of rows is probably overkill. It's probably quicker to scan 3 rows manually to find Tim's phone number than it is to type in a query. But once you've got a lot of rows though, a database becomes really useful. Now to save typing, what I've done is I've created a database containing details of a music collection. So download the file music.zip from the resources section for this video. And you can see that I've downloaded that zip file onto my desktop. Once you've done that, you want to extract the database file, which is music.db, and save it to a suitable location on your computer's hard drive. So I'm just going to double click this, which will extract the file. And you can see that I've got a file there, music.db. Then what I'm going to do is I'm going to change the directory to go to that folder, which is in this case is my desktop, so that we can access that database. So the command for me is going to be cd space /desktop. And you can do a similar thing on Linux to navigate to the folder, and on Windows you can do a cd space and just navigate to the folder, typing in whatever the directory structure is. And on Windows you generally have to use backslashes instead of forward slashes. But in any event, move to that folder. So in my case I can do now an ls, and I can see that I've got a couple of files in there. Music.db is the one I want, and that command will also work on Linux, and on Windows you type dir to see the files. Alright, so let's now go ahead and open that file. Remembering we've put SQLite in the path, so with the command prompt or terminal session already open, as you can see I've got mine open on the screen. I've changed into the directory, and now I'm going to type SQLite3, SQLite3 space music.db. Now incidentally, I've given the file a DB extension, but SQLite doesn't actually care how you name the database file. It's usual to use something like .db or .sqlite, but it really doesn't matter. It is a good idea though to avoid using .sql, as that's usually used to indicate that the file contains a SQL script. I'll talk about SQL scripts a little later. Okay, so we should now be running SQLite with the music database loaded, as I've got on the screen now. So let's start by reviewing the structure of the database. So the mini challenge is to remember what the appropriate SQLite command is to display the structure of the database. So type that in so that you can actually see what the structure of this particular database is. So pause the video now, and we'll come back and I'll show you what it is. Okay, so the solution to the challenge is the command to type is .schema, S-C-H-E-M-A, with a dot at the start. And you can see that gives us a list of all the tables and the SQL source code that was used to create them. Now you may have used the .dump as well, that's fine, but there's quite a lot of data in the table, so you'd have to scroll up a long way to see the structure of the tables if you did that. So generally speaking, .schema is a better command to use here when we're just interested in the tables rather than their contents. So I won't use the .dump, but you could do that if you wanted to. Now incidentally, if you're not too familiar with command lines, you can repeat previous commands by using the up and down arrow keys to recall them. But with that said, it doesn't always work. It depends on your version, because with a Mac I can't actually use an up arrow here, but I can use it when I'm outside of SQLite. But SQLite for some reason is mapping my arrow keys and not allowing me to actually use a previous command. But if you're on Linux, that will certainly work, almost certainly work the arrow keys, and it should also work on Windows as well. But basically how you'd normally do it is you just press the up and down arrow keys to get to the command you want, and you can even use the left and right arrow keys to move around on the line if you need to edit the command before pressing enter again to execute it. Now the left and right arrow keys may not work if you're using SSH to connect on a remote computer, but if you're doing that then you probably already know how to move around in the terminal. So I'll have to be typing in the commands in full, but just bear in mind that you can probably use the up and down arrow keys to navigate to a command to save you having to type it multiple times. Alright, so looking at the schema command, the output on the screen there, we can see that the database contains 3 tables: songs, albums, and artists. Now each table actually contains an ID column, which you can see there as the first field, and I've called that _ID. Now you don't have to call it that, but some of the Java classes to handle databases actually require an ID column called _ID. So it's probably a good habit to get into to actually do that. But in fact, as the database is at the moment, the _ID column is just an integer field, and we do have to update it manually, but I'll be changing that a little bit later in the course. For now though, _ID holds a number that uniquely identifies the rows in the table. So we can actually check this out by typing in a SQL command. So select star from artists. And you can see we've got quite a few there. We've ended up with a total of 201 artists. And you can see the number on the left there, to the left of the artist name, is uniquely identifying each one. And the same is true if we do a search for albums. Select star from albums. You can see we've got a total of 439 albums there, and again the ID is unique for each album. Now the third column in the albums table is the ID of the artist, so that we can see that the last album that was created by artist 133. Now if you read the screen very quickly when all the artists scroll past, you may remember that this was the Black Keys, but we can actually check that to confirm that by typing select star from artists where _ID equals 133 and semicolon on the end. And you can see that for ID 133 from the artists table, the name is Black Keys. And finally, the songs. So let's do a select space star space from space songs, semicolon. And you can see there's quite a few songs there, over 5,000 in fact. Once again, each song has got a unique ID. The second number is the position of the song in its album, and the final number is the ID of the album. So Permanent Vacation, which you can see is the second to last one there, is the 10th track in album 367. Another mini challenge. Find the title of album 367. So type in the SQL command necessary to return that title of album 367. Pause the video now and figure that out, and when you're ready to see me type in the solution, start the video. Pause the video now. Alright, so how do we actually find the title for album 367? We type select space name from albums where _ID equals 367 and semicolon to finish the line, and we can see Permanent Vacation. So the album, in other words, is also called Permanent Vacation. Now we could have also used select star, as there's only 3 columns in the albums table. That's fine as well. So select star from albums where _ID equals 367. And that would have given the same result, and obviously it's returning the other 2 fields as well. Now one thing I forgot to do was turn headers on, and it's not a big deal, but it's helpful to see what the columns are called. So let's do that now. So dot headers. Whoops, headers. See, and I can't use my up arrow. Normally I'd be able to press an up arrow and get the dot headers come back on the screen again and then just type in the rest, but it's not letting me for some reason. So headers space on. And now if I do the command again, so select star from albums where _ID equals 367. And you can see we've got the field names at the top as well as the actual answer. So the ID field can be used to relate the songs and albums tables so we can easily see which album the song belongs to. Now having to perform 2 queries to do that is a bit tedious, but I want to look a bit more at the structure of the tables and do some more querying before I talk about how we can join the tables together. Before moving on though, I'm going to back up the database in case I do something silly with my updates or deletes. So I'm going to type in .backup music-backup1. And you can see on my desktop the file music-backup1 appeared, and because it's on my desktop you can see any file that gets created there. So we can see that the file was successfully backed up. Alright, so let's have a look at the table structures again, because there's a couple of things in there that I didn't mention in the previous video. I'll type in .schema. Now the first thing is that the ID column is set to be the primary key. Now a key in a table is an index, which provides a way to really speed up searches and joins on a column. Now when columns are indexed, they can be searched much faster than if they aren't. Basically, index columns are sorted so that they can be searched through much faster. Now, one thing I should mention about relational databases is that the ordering of the rows is undefined. So in that respect, they're very similar to Java maps or to sets. In fact, relational database theory is heavily based on set theory. So by defining a key, what you're doing is you're saying that the data should be ordered on that column or group of columns, and searches, etc., work far more efficiently as a result of doing that. Now, there can be lots of keys on a table, but there can only be one primary key. Now, usually this is the ID column, but if you don't have an ID column in your table, then you can choose another column to be the primary key if you want. Now, one important thing about the primary key, though, is that it must be unique. So let's try to add another artist using an insert statement. Insert space into artists space values. We're going to type 201 comma then Beyonce in double quotes, finish off the parentheses and put a semicolon. If we do that, we should get an error, and you can see we've got an error there. Unique constraint failed, artist._id. Now personally, I'm not actually too unhappy that I couldn't add Beyonce to my record collection, but it failed because there's already a record with the value 201 for its primary key. So we get an error if we try to use that ID again. Now keys don't have to be unique, and often you'll want to index a column that doesn't have a unique value or doesn't have unique values. A surname column in a contacts database, for example, would benefit from being indexed, but many people can have the same surname. So you can have keys that aren't unique, but the primary key must be unique. Let's type in schema again. Now the other thing to mention is the not null for the text fields. The name column of the artists and album tables is marked as not null, and the title column of songs is also not null. And that means that the columns must contain a value, and if you try to leave them blank when inserting a new record, you'll actually get an error. And if you think about it, in this case, it really doesn't make much sense to store an artist without a name, and the same for an album. So creating those columns as not null ensures that all albums and artists have got a name, and the same goes for song titles. Now sometimes a null value does make sense. A middle name column in a contacts table may often be null, so it's fine in that situation to allow nulls. But when designing your tables, have a think about the data, and if it wouldn't make sense to have a null value, then use not null when creating the column. Now the primary key column in our tables is automatically not null because integer primary key columns in SQLite are treated in a special way. And we can see that by having another go at inserting Beyonce into the table. So if we come back and type insert into artists, name in parentheses, values, and this time we just type Beyonce in double quotes in parentheses and put a semicolon on the end. So this time we're not providing an ID. As a result, we must explicitly specify the name column so that SQLite knows which column we want to have the value Beyonce. So now if I do a select space star from artists, so now Beyonce has appeared at the table right at the bottom, and note how she's been automatically given the ID 202. An integer primary key column can't contain null values, and SQLite automatically generates a unique number for the column if one isn't provided. Now this is slightly different from the behavior of other databases, other SQL databases such as Microsoft SQL Server, where you have to specify auto increment when creating the column if you want the values to be automatically generated. Now there's a description of this behavior and why you wouldn't normally use auto increment in SQLite databases in the documentation, so I'll just quickly take you to that page. Because particularly if you've got some experience in other databases, it'll be good to know this. And if you're going to be working with databases a lot, then it's worth reading that. But really all we need to know is that SQLite will create the IDs for us, and we don't have to worry about making sure that we don't reuse an integer ID in a primary key field. Alright, so that's all I'm going to say about keys in this course. Database administration is a very complex topic in its own right, and the aim of this section is to give you the basics so that you can use databases to store your program's data. Now, if you are going to be doing a lot of work with databases, then you'll probably need to know about keys and how they affect performance, both positively and negatively, and stuff like that. But we don't really need any more for what we're doing here. So I'm going to end the video here now. In the next video, we'll continue on with SQLite, and we'll start looking at the order by clause. So I'll see you in the next video. Okay, so let's look a bit more at querying the data, including how we can make sure that we get the data back in a sensible order if, as I mentioned, ordering of rows is undefined in a relational database. So when we display all the artist's records, they actually come out in the same order each time. So I can do that again, select star from artists. So we get the same, every time we do it, we get the same order. And that's because we have a primary key. So the records will automatically be selected based on the ordering of the primary key. Now note that the actual order of the records in the database is undefined, and if we didn't have a primary key, they'd be coming out in an undefined order. Now we can actually specify a different order in our select statement by using an order by clause. So we can type select star from artists order by name. Semicolon on the end as always. And you can see now that the records have appeared in alphabetical order. And I can do exactly the same for the albums. Select star from albums order by name. Now you notice right down the bottom the two Blackbeard's Tea Party albums, Heavens to Betsy and Whip Jamboree, are out of order. That's because they start with lowercase letters. Now you can actually ignore case by using the collate no case clause. So we can do select star from albums order by name collate no case. And you can see there the ID 430 about 80% towards the bottom of the screen, which is Whip Jamboree, and that appears with the other albums beginning with W. In other words, it's now ignoring case when it's actually returning results. Now it is also possible to specify ascending or descending order using the keywords ASC or DESC or ASC or DESC respectively, which stands for ascending or descending order. So we can do select star from albums order by name collate no case. Then we can type DESC for descending order. And that's fine, but what if we want to group albums together so that all the albums by each artist appear together? Well, the order by clause can actually contain more than one column. So we can do something like select star from albums order by artist, comma name, collate no case. And what that does, it sorts first by artist ID and then by album name. So all the Deep Purple albums, artist 196, and you can see a group of them here with the number 196 at the end of the list of data. They appear together near the end of the list. You can see it's also starting with Burn, so this one up here, starting with Burn there, and ending right down here with Who Do We Think We Are Remastered Edition. Okay, time for another mini challenge. The challenge is to list all the songs so that songs from the same album appear together in track order. So that's the challenge. Have a go at doing that by typing in the SQL code that's necessary to achieve that. Pause the video, and when you're ready to see me type it in, start the video again. So pause the video and I'll see you when you get back. Alright, so to achieve that, what we need to do to list all the songs so that songs from the same album appear together in track order, we type select star from songs and order by album, comma track, semicolon on the end. And there you go. So now the 11 songs from the Black Keys albums Attack and Release appear together, as you can see right at the end of the list. And you could check that if you wanted to by typing something like select star from albums where _ID equals 439. And then we could do something like select star from artists where _ID equals 133. And there you go. You can see with a quick scan up the list shows that the records are grouped by album ID, the last column, and in track order within an album, the second column. Now having to run separate queries like that is a bit grubby though, so let's see how to relate the tables together so that we can get a list of songs that include the album they appear on, as well as the artist that produced them. Now to do this, we need to use the SQL join clause that's used to join tables together. Now we're keeping data normalized so that tables only contain information that relates to a single thing. Song, album or artist in our example is a fundamental part of relational databases, and by doing that and then joining the tables back together, you get a great deal of flexibility in how you can query and manipulate the data. Now remember that the songs table contains a column holding the album ID, and the album table has an artist ID field. And these are used to provide a link between the tables. Now don't worry about how those IDs got into the tables at this stage, we're just interested in using them to join the tables at the moment. So you can see here on screen how the album column in the songs table provides a link to the album table. The first 10 songs all belong to the album whose ID is 1, Tales of the Crown, and the next set of songs belong to The Masquerade Ball. The artist column in albums links to the artist table, so those first 2 albums are by Axel Rudapel, and the album Crimes of Passion is by Pat Benatar, and Night Flight is by a band called Budgie. Alright, so with that said, let's actually join the tables in SQL and see how this is going to look. So what I'm going to do, I'm actually just going to do a .quit, and then I'm just going to clear the screen. And see, notice how the up arrow is working for me here. It's just in SQLite 3 for some reason it's not working. I get those weird characters. But so I've gone back into the database again, and just so we're starting off with a clear slate. So let's now use this select statement and add a join clause to link the songs and albums. So I'm going to do is type select space songs.track, comma, songs.title, comma, albums dot name from songs, and here's the command join, the join clause albums on songs dot album equal albums dot _ID, and press enter there. So the first thing to note is that I've specified which table the columns are in when selecting them. And probably what I should have done is explain that while that select statement was on screen, because of course now I can't bring it back. Or can I? I can scroll up. So what I'll do is I'll just type it in again. And again, you shouldn't have this scenario. You should be able to do an up arrow and it should work, but for some reason my Mac is not doing what I want it to do. So albums.name from songs join albums on songs.album equals albums._ID. Alright, so I'll leave that on before I press enter this time. So getting back to that statement, the first thing to note is that I've specified which table the columns are in when selecting them. So track and title are in the songs table, and you notice how I use songs.track and songs.title. Now name comes from the albums table, so I've specified that as albums.name. Now if there's no ambiguity, you can actually leave off the table name. So what I could have done, I'll just press this to see the results again. So I could have also written this as select track title name from songs join albums I should say on song.album I should say equals albums._ID. So I could have done that way if there's no ambiguity with the names. But it is a good habit to always specify the table name, especially in code. Now, leaving it off is a useful shortcut to save typing when working interactively like this, but I'd say always prefix the fields with the table name in your code. Now, some albums have a sort of subtitle, so if the table was modified to include a title column, then that query would no longer work because it wouldn't know which table the title column should come from. And note though that we can't leave the table name off when using the ID column, so we just went back here, the end of it. Instead of putting albums.id, if I just put _ID there and press semicolon and press enter, we get error no such column, song.album. No, that was actually a different message. That was because I accidentally typed song there. So I'm just going to, I should be able to copy and paste. I might do it that way. That might save a bit of time. So the original request was songs. Should have been songs.album because of course songs is the name of the table. What I was going to show you was if I just type it like that without actually putting the albums dot before the ID and press enter, now we get the error that I wanted to show you the first time, error ambiguous column name _ID. And that's because both tables have a column of that same name _ID and SQLite doesn't know which one you mean. So you need to specify it there, and I'm just going to copy that again, paste it. So I would go back and I'd make that songs. I would make that albums, I should say, ._ID. And then we get our data back. Now there are different types of joins, the most common being an inner join, and join as I've used here is really a shorthand for inner join. What I'll do is I'll retrieve the full command that included the table names, then include the word inner. So I'm going to type select songs.track, songs.title, albums.name, from songs, inner join, inner space join that should be, inner join space albums on songs.album equals albums._ID. Now keep in mind that not all database systems will allow you to leave off the word inner, so it's worth always using it. And I'll just run this to make sure it works. Now looking at the result of that query, we can see that the song Just Walk in My Shoes is from the album Superlungs, and Permanent Vacation is from an album of the same name, and so on. So I'll just paste this code back in again. So again, this select statement follows the same pattern as we've been using up until now. Instead of select from songs, we're doing select from songs, inner join albums. We then have to tell SQLite which columns are involved in the join, which is what the on part does. And it says to relate the rows in songs to those in albums where the songs tables album column equals the album tables ID column. And if you really wanted to, we can actually tack an order by clause on the end of that if we want to sort the data. So I could come to the end here and I could then type order by and name of the table albums dot and then the column we want, name, then songs dot track, semicolon. And that's actually returned a heck of a lot of results, as you can see there, but it actually went through and did it really quickly. But if I wanted to, I could just scroll back up and have a look at some of the other data that's been returned. But you can see there's a lot of data and SQLite has manipulated that and returned it very quickly. Alright, so I'm going to finish the video here now. We'll continue on working with SQLite in the next video. Alright, so I've actually quit out of SQLite and I've started up again. I'm just going to type this command in. And you can just see that there's actually a tremendous number of records here that have appeared on the screen. I'm just scrolling up, as you can see, there's tons of them. Now, depending on the speed of your Mac, you might find it's a lot slower to output these, and you can actually use Control-C to stop the listing. And that also lets you see some records from the middle of the list rather than just the same few from the end. Now, you can do the same thing on Windows with Control-C, but there's apparently a bug that causes Control-C to quit SQLite as well. So you might have to start SQLite again with the SQLite 3 space music.db to get back into the database if you're on Windows and you press Control-C. On Linux, you might find as well that, you should find rather, Control-C will stop the listing as well. Alright, so let's just change this around a little bit, and it might actually look neater the other way around if we list the album name before the song title. So to do that, we would type select albums.name, songs.track, songs.title from songs, then inner join albums on songs.album equals albums._id order by albums.name songs.track. So let's try that. And you can see that does look a little bit neater. So you're free to return any columns you want in any order. You don't have to keep them in the same order that they appear in the table, nor in the order the actual tables are joined either. Alright, time for another mini challenge. Alright, so the challenge is to produce a list of all the artists with their albums in alphabetical order of artist name. So go away and see if you can figure out the SQL code for that. Pause the video, and when you're ready to see my solution, come back to it and I'll show you how to do it. So pause the video now. Alright, so the way to solve that would be select artists.name, albums.name from albums, inner join albums.artist equals artists._id, then order by artist's name. And I've got a typo there, and I forgot to use the word on there, and because I can't use my up arrow, I'm going to have to type it in again. So select artists.name albums.name from albums, then inner join artists is what I forgot to put before on, then albums.artist equals artists._id, then order by artist.name. This is better. Okay, there you go. That's the solution. Now what if we wanted to find out which artist produced a song though? Now the songs table doesn't have any direct links to artists. And if we just go back and look at the relationships between the tables again, it'll help us to see how we can get the artist for a song. Alright, so here's a representation. I'll just zoom in so you can see that a little bit better. So if we have a look at the relationships between these tables again, that's going to help to see how we can get that artist for a particular song. Now although we can't go directly to an artist from a song record, we can find out which album contains the song, and from there it should be easy to find out who the artist is. And we do that by joining songs to albums and then albums to artists. So let's have a go at typing in the code for that. So we type in select artists.name, albums.name, songs.track, songs.title from songs. And I'm going to press enter there. I'm going to type inner join albums on songs.album equals albums._id. Then another inner join, so inner join artists on albums.artist equals artists._id. Then we're going to finish the last line with order by artists.name, albums.name, songs.track. Semicolon on the end. So that's actually quite a long statement, as you can see. So it was good that SQLite allows us to split it over more than one line and doesn't try to execute the statement until it finds an ending semicolon. So what I've done here is just chain the inner joins together. So we have songs inner join albums inner join artists. Now of course we have to specify which columns to join on, but hopefully the syntax as I've shown it there does make sense. And we'll just run this to make sure it works. And you can see that we've got the results that we're looking for, the actual artist who produced the song. So the select statement is pretty flexible. We can include as many columns as we need, join in tables as we need them, and then sort as many columns as we need to produce decent output. And you can also nest select inside another select statement, but if you get to the stage of needing to do that, then you're really getting into more advanced SQL, and that's above what we have time to cover in this course. Just keep in mind that the SQL language is very powerful and really quite simple considering what you can do with it. Now, one thing that I haven't mentioned so far is that the ordering of the clauses is important. So you can't go putting the order by clause before the joins, for example. The order is strict in that regard, so the order that we've been doing things so far is actually the correct way to do it. Now, if you want to include a where clause, it has to go before the order by clause. So let's restrict that previous query to just the album Doolittle, which has the ID 19. Alright, so what I actually did was I actually copy and pasted it off screen, so you can ignore those little dots and the greater than sign. It's because I've pasted it all in the at the same time that it's actually come up with what would have happened if we had pressed enter. But the point is, so what I've done is I put the where clause, you can see, before the order by clause. And I've got a semicolon on the end there, so this should work when I press enter. So we're only getting the rows back for the album Doolittle, which again had the ID 19. And that's where the where clause came in. Now, splitting the command over several lines like this does make it easier to understand, but it does make calling the command back a little tricky. You have to do it line by line. So the trick would be that if this up arrow was working for you, is to actually keep pressing the up arrow to call back the first line in the statement, the select line here, then press enter. Then use the up arrow to call back the next line, and so on. I can't actually show you that because as I've outlined, it's not working properly on the Mac. But what I can do is paste in part of the command, like so. Then what I'm going to do is add the clause again. So where albums.name equals Doolittle, then order by artists.name, albums.name, songs.track, semicolon. So as you can see, the structure of the select statement is quite straightforward. You specify the columns that you're interested in, you join any other tables that are needed, filter the selection using a where clause, and finally you order the results. Now, sometimes you have a rough idea of what you want to find, but you don't know it exactly. Or perhaps you're interested in several rows that have similar but not identical names. Now, the SQL where clause can use wildcards to match on partial strings to cope with these situations. Now, I'm going to actually change SQL commands that span a few lines in this next bit. And as you've seen, editing the statements from within the SQLite shell is a bit fiddly. A useful tip when working with the SQLite shell is to keep a text editor handy and copy and paste between the two windows. And you'll also need to know how to copy from that terminal command line if you want to take the output from the .schema command and paste it into your code. So I'm going to digress slightly and show you how to do that. So I can just come up here and actually just copy these commands that I've typed in here, selected here. So doing it a line at a time, I can actually just select the part. You've seen me doing this in the previous videos. I can actually copy that, and what I can do is I can then drag that down with my mouse and put it into this line here, and you can see that's been added. Or I could have right-clicked it and selected copy and paste, which you also saw me do previously. Now, on Windows, you can copy the selected text into the clipboard after you've selected it by pressing Enter. And on Linux, you need to click the right mouse button and choose Copy from the context menu that actually appears. So it does depend on the operating system as to how you go about copying that. The bottom line is at that point, the text is now in the clipboard and you can paste it into the text editor that you want to use and manipulate the SQL statement on. Now, in the case of here, what I'm going to do is I'm just going to copy all of this here. And I can do a copy here as well if I wanted to do it that way. And I could open a text editor. In my case, I'm just going to open text edit. But you can use Notepad or Linux editor as appropriate. And I can just paste it in there. And notice that if we just zoom in there, we might have to clean a little bit of this up. So we need to just delete this part here, where those extra parts were added by SQLite when Enter was meant to have been pressed. And I can just press Enter at the relevant place to build up the clause like that. And eventually I've got the thing sort of working and ready to be manipulated. And what I'll do is I'm just going to put this to the side, and so we can see both things at the same time for now. So you can see we're now ready to actually be able to work in both windows. So I'm just going to close that off and come back here. And obviously I can just select this here. I can copy it and I can paste it directly in. And because it's got a semicolon on the end, I can press enter and I can get the results that I want. And then I can go back to my text editor and I can be manipulating anything that I actually need to do. So this is also useful when you're going to be working with code, because you'll be typing in a command interactively to make sure that it works, and then you'll be taking this code which I've copied into my, in this case, and text edit, which is a standard text editor that comes with a Mac, but you might also be pasting that into some code as well. So it's a good sort of thing to know how to do, because you'll be doing that. That would normally be the sequence of things. You test to make sure that the queries, the SQL code that you're typing, is correct and valid in SQLite first, and then once you're sure that it's working, that's when you copy the code and then put it back in the relevant file. Alright, so I'm going to finish the video here now. In the next video, we're going to talk about the wildcard where I started telling you about the fact that you can actually match on partial strings. So we'll actually have a look at how to do that in the next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Alright, so what I'm going to do now is we're going to have a look at wildcards. And I'm going to bring up the text editor that I actually used in the last video, because that's going to make it easy for me to make these changes. And I'll just bring that up on the screen so you can see it. So I've got a particular song that I'd like to hear in the collection, but I can't actually remember exactly what it was called, nor who it's by. The only thing I do know is that it's got the word doctor in the title though. So how would I actually go about retrieving that information using SQL code? Well, now that I've pasted this previous query into my text editor, I can just go in here and just edit this where clause, and where it's got Doolittle, I'm going to delete that out by leaving the double quotes in there. And instead I'm going to type in %, the word doctor, without any additional spaces, then another %. So this should list all the songs that contain the word doctor in their title. And actually one other thing I need to do, I put where album's name, no longer will it be equal, what it needs to be here is like. So let's actually just type it in. So it's where albums.name like, then the double quote, then %doctor %, and then another double quote. So now if I copy that and paste it in, and I think the problem there is the double quotes haven't been interpreted correctly by text edit. You can see these double quotes. This is what happens when you don't use a proper text editor. You get these funny little results here. So I'm just going to fix that and see if that actually works a bit better. And if it doesn't, no, we're getting the same problem. Well, let's actually try changing that to a single quote. Because the problem is the quote characters that are being typed here are actually invalid. So actually I know what I'll do. I'll just copy that. I've got this copied in another document, so I'm just going to copy that. And I'll just try pasting that in there again. Now notice how the double quotes this time are correct. So this is what sometimes happens when you're using and not using sort of a proper program editor. You can get these weird little characters that are appearing that aren't the true double quotes, and that's why we're getting this error that it couldn't be recognized, because that quote there is actually different to this one here, even though they look very much the same. So let's just run this and we'll go back and talk about it, because now this should work. Alright, so we actually got it to work this time, and you can see now that we've got a result of all the songs that contain the word doctor in them. And so just bringing that query back on the screen again, there's two things to note about the command, and three, I guess, if you count the fact that it worked. Firstly, we used the keyword like instead of the equal symbol. We want to match names that are like the text that we typed. Now, in fact, if I'd used equals instead of like, I'd only have got back the Wishbone Ash Doctor song, Doctor. The second thing is about that is that the wildcard character in SQL is the % character. Now, you may be used to using a question mark to match single characters or an asterisk to match any sequence, but in SQL you use the question mark instead of an asterisk to match a sequence of 0 or more characters. And actually there is a third thing. Unlike equals, which performs a case-sensitive search, like is not case-sensitive. So you can use like without a wildcard if you want to perform a search without worrying about the case. So that where clause matches any rows that have the word doctor in the song's title column. Now bands sometimes change their names. Think of Prince or the sensational Alex Harvey Band, and this collection contains at least one album by Jefferson Airplane, which later became Jefferson Starship. which looks like another good use for a wildcard search. So let's go ahead and change the like there. And where we've got songs title, let's come back and change that to artists.name. And this time we'll change that to like. Instead of the word doctor, we're going to go with Jefferson. But this time I'm going to leave the percentage off the start. So it's Jefferson without the double quotes. And I think I'm going to get problems with those single quotes again, so I'm going to copy this off screen again. And I'm just going to paste this in here. You can see those double quotes are now fixed. And incidentally, if you're doing this with Android Studio, so if you were copying to and from Android Studio or a proper text editor, then you wouldn't be getting these weird little things that I'm getting here now. Let's paste that in just to see that it works. Okay, and we'll just go back and look at the query again. We can see both on the screen now. And the reason that I left off the initial percent, the one at the start of the word Jefferson, is because I knew the band's name started with Jefferson, but the query would still have worked if I'd left it in. Now, SQL also allows an underscore to match a single character if you need to do that. Alright, so that's all working fine, and once you know to use like and the percent character, there shouldn't really be anything surprising about wildcard searches. Even using the ability to copy and paste between a terminal window or command prompt and a text editor though, it's still a bit tedious having to re-enter all those commands when all we actually changed was the where clause. Now the major client-server databases have what are known as stored procedures, which are a way to store SQL queries, amongst other things, and execute them when you want, often with parameters for things like the text to search for. They operate a little bit like functions or methods that are stored in the database and can be reused when you want. Unfortunately though, SQLite doesn't have stored procedures. And there's actually a good reason for this, and it's a result of the fact that SQLite is intended to be embedded in programs. So normal client-server SQL databases have the database server running on a remote machine that you connect to in order to access the data. A stored procedure runs on the server, so it's far more efficient than trying to work with a large data set on a remote machine. But as SQLite is not client-server and everything is running on the same machine anyway, the advantages of using stored procedures really don't apply. In addition, you don't generally use SQLite interactively like we're doing here. We're doing this because we develop applications and need to try things out and get queries working, etc. But ordinary users wouldn't normally interact with a SQL database in this way. It would all be done via the application itself. The bottom line here is the absence of stored procedures isn't really a drawback when you consider the way in which SQLite is intended to be used. But one thing that it does have in common with the client-server database systems is views. So a good way to think about a view is as a virtual table. It doesn't really exist as a table, but can be used as though it is one. Now you can't modify data using a view, at least not in SQLite, so you can't update, delete or insert, but you can query them just as if they were a table. And this will probably make more sense once we've seen a view in action, so I'm going to create one based on the query we've been using a few times and then talk some more about it. So we come back here, we start typing in SQLite, and what I might do is just quit out of it, clear the screen and start it up again, so we're coming in with a clean slate. So we create a view using the SQL command, using the SQL create view statement. So create view artist underscore list as, press enter. Then it's going to be select artists.name, albums.name, songs.track, songs.title from songs, inner join albums on songs.album equals albums._id, then inner join artists on albums.artist equals artists._id, then order by artists.name albums.name, and finally songs.track. A semicolon to finish the line off. Press enter. And that's now created the view, and we can see that this is now part of the database by using the .schema command. So .schema, and you can see the entry down the bottom shows us that we've got the view called artist_list and the commands to actually reproduce that. At that point, you could use that code if you wanted to. You could put that in your code, your application, or whatever you wanted to do, sort of with a copy and paste. To use the view, though, it's really quite simple. You treat it just as like you would treat any other table. So we can do a select star from artist underscore list. Oops, lowercase there. And you can actually filter it also just like a table. So select star from artist underscore list, where name, like, double quote, then Jefferson again, then a percent, double quote, semicolon. So we now effectively have another table called artist underscore list that contains the data from 3 related tables. And I think that's incredibly cool, and views are very, very useful things to have. Now you can also create views on a single table, perhaps to restrict the columns that are returned or to show the records in a specified order without having to use the order by clause every time. Now this can be a good way to include security in your application. The marketing department of a bank, for example, may need to know the contact details of customers so they can send out mail shots or emails, but they shouldn't have access to customer security questions or account details. So a view could be used to provide them with the details they need while hiding the details that they shouldn't be made commonly available, or that shouldn't be made commonly available. Now you also probably wouldn't want ordinary users seeing the link columns in our tables. They're interesting to us as developers, but the numbers at the end of this statement, select star from albums, order by name. So the numbers there would just be confusing to other people. And actually the primary key field is also confusing, so we can actually create a view that just returns the album names. So we could do something like create view album underscore list as select, start on the new line, as select name from albums order by name. And then I can do select star from album underscore list. And obviously at that point I'm only getting the names. Now ideally I'd have done a case insensitive ordering there, because we've once again got Whip Jamboree and Heavens to Betsy out of order as far as most humans would be concerned right down the bottom there. Now because a view doesn't actually exist in a way that a table does, we can actually delete the view and recreate it with the order by clause corrected. So the command to actually delete the view would be drop view, then the view name, so album underscore list in this case. And incidentally, you can also delete tables using the command drop table followed by a table name. But while deleting a view doesn't affect the data in the database, deleting a table obviously will. And yes, I've also done that by mistake as well. But now that I've actually deleted the view, I can actually recreate it. I'm going to paste the command in there to recreate it, and noting that I've got collate, no case on the end there. And then I can do a select star from album underscore list. And this time we've got things sorted in the right order. You can see here the lowercase Whip Jamboree is now where most humans would expect it to be sorted. So that's just about everything we need to know to be able to put a database in our program. Before I finish though, there's just one more thing I need to say about views. Now you may have noticed that when I selected the Jefferson Starship albums from the view earlier, I didn't have to specify which name column I was searching on. So I typed the command like this, select star from artist underscore list, where name like percent Jefferson. Whoops, there wasn't a percent at the end there. At the start was there, it was just Jefferson. Jefferson, then a percentage, double quote, semicolon. So that was the command I used. But if you haven't turned headers on, or you've had to stop and start circle like that I have, use the command to put them on again. So headers, dot headers on. Headers on like so. And let's type that command in again. I'm just going to come up here and drag it down. And now that I've done that, you can see here it's got name, then a comma, name colon 1, and title. Now because there were two named fields in the select statement, SQLite has renamed one of them so that the column names are unique. And .schema will remind us of the command we used to create the view. So if I type schema again, So because of the clash, SQLite automatically renamed the name columns from the albums table to be name:1. Now, not all database systems do this, and it's a good idea to explicitly name the columns when you create the view if there's going to be a name clash or potential name clash. So to put that right, what we need to do is drop the view and recreate it, and this time giving the two name columns a unique name. So I'm going to just copy in some code here that it both drops the view and recreates it again, just to save a bit of time. So there's the code. You can see that we're initially dropping the view, and we're creating it this time. Press enter, and that's been created. And now when I do that command again, the select command, and incidentally I've used as after the artists and album column names to provide a new name that the columns will be known as in the view, in case you're wondering what that was. So now if I paste this in and have a look at that again, we've now got artist and album, track and title. We've no longer got name and name:1. Alright, so that's the end of this introduction to databases in the SQL language. In the next video, I'm going to start going through to show you how we can use SQLite in our programs. But before we do that, there's a little bit of housekeeping that we're going to do in the next video, and then I'm going to set you a challenge, and then after that challenge we're going to go through and start putting this to use in application. So I'll see you in the next video. Alright, so as I mentioned at the end of the last video, we finished the introduction to databases in the SQL language, and what we're going to start working on in the next video is how we can use SQLite in Java programs. But before we actually get to that video, let's go through and do a few more things. We're going to start with backing up the database again. So I'm going to type in .backup, and I'm going to call this one music-backup2. So what I suggest you do now is experiment with the commands that we've used to search for different groups of records from the three tables. And also try creating queries that use joins as well as the already joined view that we created. And actually there's not much point showing you how to back up the database if I don't show you how to get it back should you need to. And I know we have restored it previously, but we're going to restore this music one. Now, a database is restored from the backup, as you saw, using the .restore command, but if we restored it right now, you'd have no real indication that it worked, so let's actually trash some songs first so that we can confirm that. Now, most of the albums have fewer than 50 tracks, so we can delete all songs whose track number is less than 50, and that should leave us with very few records. So let's go ahead and do that. I'm going to type delete from songs where track is less than 50. And we're going to do select star from songs. Obviously we've got a much smaller list than what we had before. In actual fact, we're left with songs from only 2 albums. And that is easy to see if we use the view. So if we do a look at the view, so select star from artist_list, which was our view. You can see there clearly there's only 2. Now, as you saw, for the condition in the where clause, you can use less than, greater than, less than or equal to, and so on, just like you'd expect. Now, SQL uses less than or greater than for not equal to, which makes sense when you read it and avoids having to introduce another symbol. Other than that, the comparison operators are the same as you'd normally expect in Java. So we can drop a song from the list, only selecting songs with a track number not equal to 71. So we could do that with select star from songs where track is not equal to 71. So you can see at that point now recycled vinyl blues, which was showing in the previous list, is now no longer showing. Now the other thing you can do, which we haven't talked about, is you can include functions in the select statement. Now I'm not going to go into a range of functions available, but one useful one is count. So you can do select count and star in parentheses from songs. It returns how many records are present. Select count star in parentheses again from albums. And select count star from artists. And you can see we've got 24 entries for songs, 439 records for albums, and 202 for artists. Alright, so let's now restore the database and actually see how many records we've got back. So I'm going to do dot restore music back up to. Remembering there's no semicolon because it's a SQLite command because it starts with a dot. So let's do the equivalent commands now. The select count star from songs. You can see we've got a much larger number there, so we've got our original records back, and select count star from albums, returning the same number because of course we didn't delete anything from there, and select star from artists should also give us the same number, 202, the same number as it was last time. So clearly the restore worked. Alright, so let's finish this video now with a challenge for you to help get you started. Alright, so I've got a number of things for you to actually come up with the SQL commands to return the results that I'm asking for. So first one here, number 1, select the titles of all the songs on the album Forbidden. The second one, repeat the previous query, but this time display the songs in track order. Now you may want to include the track number in the output to verify that it worked okay. Number 3, display all songs for the band Deep Purple. Number 4, rename the band Me Taboo to One Kitten. I hope I pronounced that right. And note that this is an exception to the advice to always fully qualify your column names. Set space artist.name won't work. You just need to specify name. And you'll see that when you give that a go. Number 5, check that the record was correctly renamed that you did in part 4. Continuing on. Number 6, select the titles of all the songs by Aerosmith in alphabetical order. Include only the title in the output. Number 7, replace the column that you've used in the previous answer with count title in parentheses to get just a count of the number of songs. Number 8, search the internet to find out how to get a list of the songs from step 6 without any duplicates. Number 9, search the internet again, this time to find out how to get a count of the songs without duplicates. And hint, it uses the same keyword as step 8, but the syntax may not be obvious. And number 10, repeat the previous query to find the number of artists, which obviously should be 1, and the number of albums. So that's it, that's your challenge, the 10 things for you to have a go at. So pause the video now and go away and see if you can figure those out, and when you're ready to see me come up with the answers, start the video again. So pause the video now and I'll see you when you get back. Alright, so how did you go? Hopefully you managed to figure it out. So let's have a go. So we're going to start with the first one. And if you recall, the first challenge was select the titles of all the songs on the album Forbidden. So to do that, we do select songs.title from songs, inner join, albums, on songs.album equals albums dot underscore ID, and then our where clause, where albums dot name is equal to Forbidden. Alright, so that's all the titles from the album Forbidden. Number 2 was to repeat the previous query, but this time display the songs in track order. And you may want to include the track number in the output to verify that it worked okay. So let's type that up. So it's going to be select songs.track, songs.title from songs, inner join, albums, on songs.album equals albums dot underscore ID, where albums dot name equals Forbidden, order by songs dot track. So we've got the equivalent to the previous query, but this time sorted in track order, and you can see we've got the track order on the screen there verifying that that worked. Alright, number 3, display all songs for the band Deep Purple. Alright, so select songs.title from songs, inner join, albums, on songs.album equals albums dot underscore ID, then inner join, artists, on albums dot artist equal to artists dot underscore ID, where artist.name equals deep purple. And that should have been artists underscore ID. So rather than typing that in again, I'm just going to paste that in this time. So you can see we've got quite a few entries there for deep purple. Alternatively, also, you could have used the artists underscore list view. That would have been acceptable as well. So that would have been much easier, actually. So if we just select star from artist underscore list, where artist equals deep purple. You can obviously see where a view there would be quite convenient when you've set it up. All right, continuing on now, number 4. We want to rename the band Mehtable, if I've pronounced that correctly, to One Kitten. And this was the one where I mentioned that there was an exception to the advice to always fully qualify your column names, because set artist.name won't work. You just need to specify name in this scenario. So to do that, we do update artists set name equals One Kitten, where artists.name equals Mehtable. And we should get nothing back like that, nothing to indicate there's an error. So now we can confirm that the update worked. In other words, select star from artists, where artists.name equals One Kitten. And we can now see that we've got an entry for that. So that worked okay. And checking it was okay, the record was correctly renamed was actually challenge 5, just to be clear there. All right, so that's the one we just done. So moving on now, number 6, we had to select the titles of all the songs by Aerosmith in alphabetical order, including only the title in the output. Well, that's actually quite a simple one. Select title from artist underscore list, which we created, where artist equals Aerosmith. But then we need the order by clause to sort it, so order by title. Okay. All right, so the next one we wanted to replace the column that you used in the previous answer with count title to get just a count of the number of the songs instead of the actual titles. So that would be select count title in parentheses from artist underscore list, where artist equals Aerosmith. And we should get the answer 151 there. 151, as you can see. Now, note that in this particular case, the order by clause is redundant here. Because we're doing a count, we don't need that. However, leaving it in there won't cause a problem. So if you left it in there, that's fine. All right, next one, we're getting to a couple of the ones that required a bit of research. Number 8, search the internet to find out how to get a list of the songs from step 6 without any duplicates. Well, hopefully you managed to find that. So to do that, the command is select distinct title from artist underscore list, where artist equals Aerosmith, order by title. And you can see there's no longer any duplicates there. Number 9, search the internet again to find out how to get a count of the songs without duplicates. And the hint that I gave you was it uses the same keyword as step 8, but the syntax may not be obvious. So to do that one, select count, but then in parentheses, distinct artist, which is a bit tricky, from artist underscore list, where artist equals Aerosmith. And the count comes back with 1. And whoops, we're getting ahead of myself here, because number 9, I made a typo there, so it should be select count distinct title, not distinct artist, so it's title, because we're going on the actual song title, so it's from artist underscore list, where artist equals Aerosmith. So that should actually give us the same count before, 128. That's better. All right, so that was number 9. And the last one was to repeat the previous query to find the number of artists, which obviously should be 1, and the number of albums. So the first one I already typed up there, so I'm just going to copy and paste that in again. This is the one that I accidentally typed in the wrong place. So that's going to give us I'll paste it in. So that's going to give us the number of artists, which obviously in this case should be 1 because we've got our where clause that's looking for Aerosmith. And you can see that returns 1. Then the last one, the number of albums by Aerosmith, effectively we can do select count distinct album from artist underscore list where artist equals Aerosmith. And that gives us the answer of 13, the number of unique albums by this artist. Alright, so that's actually it. So we're actually done now with the SQLite introduction and fiddling around and playing around a little bit with SQLite. So we're going to end the video here. In the next one, we're finally going to get to the stage of, and we're going to actually start work on our first SQLite application. See you in the next video. So we've seen how to work with a SQLite database from the command line. Now we're going to learn how to use a database from a Java application. And to do so, we're going to be using the JDBC API. Now JDBC stands for Java Database Connectivity. So using JDBC, we can not only work with databases, but also spreadsheets and flat files. So think of JDBC as a middleman that sits between a Java application and a data source. To use a particular data source from an application, we need the JDBC driver for the data source. For example, to access a SQLite database from an application, we need a SQLite JDBC driver. Now the driver is simply a Java library containing classes that implement the JDBC API. Now because all JDBC drivers have to implement the same interfaces, it's not difficult to change the data source an application uses. For example, if an application uses a SQLite database and then we decide later that we want to use a MySQL database, all we have to do is use the MySQL JDBC driver instead of the SQLite one, in addition to, of course, migrating the data to a MySQL database. Now in reality, unfortunately, it's not that simple. Nothing is ever 100% portable, but if we write our JDBC code with thought in mind that we may have to change the data source later, we can make our lives easier by avoiding the use of database-specific SQL code and also behaviors wherever possible. If we wanted to work with a spreadsheet or a flat file, that's fine, as long as there's a JDBC driver that works with that spreadsheet or file format. And if you're feeling particularly game, you can always write the JDBC driver yourself if necessary. Now the JDBC driver has to be written in Java, but it can consist of a thin Java layer that calls code written in other languages. So the current version of the JDBC API, as of shooting this video, is JDBC 4.2. For backwards compatibility, it contains all the methods that were in previous JDBC versions. Now there have been changes to the way that JDBC works, so make sure you're working with a driver that supports at least JDBC 4.0. And if you use the one we'll download in this video, you'll be fine. JDBC consists of two packages, java.sql, which is core JDBC, and javax.sql, which is optional JDBC. Now the APIs in the javax.sql package are required when working with database servers, and we'll talk about those a little bit later. Now all the popular databases provide JDBC drivers. The JDK ships with a database actually called Derby, which can be used for desktop applications or when prototyping. The Derby JDBC driver is also included in the JDK. But we're going to start by using a SQLite database. So we're going to use a SQLite JDBC driver. Now the driver that we'll use comes packaged with SQLite, which means we don't have to install the database separately. So we won't be using the SQLite command line tools that we used in a previous video. Alright, so let's swing back over now and download the necessary driver. Alright, so we need to download the SQLite JDBC driver. Now since we want to add the driver to the projects we create, when you download it, do make sure to save it somewhere that you'll actually remember. So let's just open a browser and paste in the link there. The link is in the resources section as always. Once we get here, we want to click on downloads over here to the left hand side. and you want to download the very latest version. Now don't click this top link here, this download repository, or rather come down here and choose the latest version. You can see in this particular case the latest version is 3.15.1, and the date over here that was added to the repository was the 11th of November 2016. Right, so we're going to click on that file and just save it somewhere where we'll know where it is so we can refer to it later. So I'm just going to put it in my downloads folder. It's actually a very small file. As you can see, it's already completed the download process. Now there are other SQLite JDBC drivers, but we're using this one because it contains the SQLite database and doesn't require any configuration. Now because we'll add the jar file to any projects, there won't be any conflict with the SQLite we installed to use from the command line. So our application will use the version that's in the jar file. Now we'll be wanting to check the contents of our database tables when we're coding our application to make sure everything is working as we expect. Now I guess we could use the command line version of SQLite to connect to the database that we're using in our application, but instead what we're going to do is we're going to use the DB browser for SQLite application, which is basically an application that's got a GUI interface that we can access SQLite databases for. So for the rest of this video, what we're going to do is I'm going to quickly go through the 3 operating systems, Windows, Mac and Linux, and show you how to go about installing that for each platform. And then in the next video, we'll continue on with creating a Java project using the SQLite JDBC drivers to access databases from within Java code. Alright, so let's start with the Windows version. Okay, so let's now download and install the SQLite browser for Windows. And just a reminder that there's following this part of the video, a little bit further on, I'm going to go through the same process for a Mac and then also for a Linux box. So we're going to start though on Windows. I'm going to go to SQLitebrowser.org. And once we get there, you can see over the right hand side we've got a download a 32-bit version of Windows, version of the DB browser, or a 64-bit. Now I've been through everyone showing you how to specify, or how to check rather, whether your computer is running a 32-bit or a 64-bit version of Windows. So choose the appropriate version. In my case I'm running a 64-bit, so I'm going to select that by clicking it. You can see the download has started in the bottom left hand corner, and it's quite a small file. It's only about 15 megabytes, so consequently the download's already finished as I've spoken. Now I'm going to run that executable. We're going to install it. Alright, just going to minimize the window now, we no longer need it. And let's go ahead and install it. So DB browser, I'm going to click on next. I'm going to click on I agree to the license. I'm going to choose or allow the default location to be selected here for the program to be installed, and leave that as the default and click install. And depending on your version of Windows, it may need to install this. You can see it's installing a runtime here, so that might take a little bit longer. You can click on show details if you want to see what's happening and what it's actually doing. So we'll just pause in any event and wait for this to complete, and then we'll come back and just fire up the DB browser to make sure it's working. Okay, you can see that it's now completed, and the checkbox I'm going to leave ticked so that it'll actually run the DB browser for us. So I'm going to click on finish, and there's our DB browser for SQLite utility that we're going to be using in future videos. So if you haven't got a Mac or a Linux machine at this point, you can actually move on to the next video. Alright, so that was the Windows version and how to go about installing that. Let's now swing over and do the Mac version. Alright, so let's go ahead now and download and install the DB browser for SQLite for the Mac. So to do that, we need to go to the website, which is SQLitebrowser.org. SQLitebrowser.org. Alright, so once we get there, we've got downloads are available for various platforms. We're going to choose the Mac DMG, so let's select that. I'm going to save it just to my download folder. It's quite a small download, as you can see, under 12 megabytes. So we'll give it a moment to complete. Okay, so I'm going to open it up, the DMG file, and we're going to install it. Just going to drag this into the applications folder. It's very small, so you may have missed it. It's such a small file. And now I can just go to either navigate to the applications folder or just do a command space and capital D, capital B rather, so capital D, capital B, and you can see that DB browser for SQLite showing there. So I can open that up. Select open because I'm opening it for the first time. And there's our browser, our DB browser for SQLite for Mac. Alright, so that's the Mac version. If you haven't got the need to install a Linux version, you can actually skip to the next video, because in that video we're going to start using the JDBC driver that we've downloaded by creating a new project in IntelliJ, as well as using this DB browser that we've downloaded and installed as well. So see you in the next video if you decide to do that, but if you've got a Linux machine that you want this installed on, stay tuned and we'll do that right now. Alright, so that's how to install the Mac version of the SQLite browser. And finally, let's go now and just install the Linux version. In this video, we're going to download, compile and build and install the SQLite database browser for Linux. The first thing, we need to go to a web browser. And we need to go to SQLitebrowser.org. Then we need to right-click this link, this download tar.gz file. So I'm going to right-click that. I'm going to copy the link location. Then what I'm going to do is open a terminal window. And I'm going to go to the location where I want to install ultimately this product. Now what I've done on my computer, I've got a software folder. As you can see there. And I've got a subfolder there that for two other products that I'm using in another course, my Java Spring course. So what I'm going to do is create it in here. So what I'm going to do is type wget. Then I'm going to right click and paste, which should give us the link that we copied from the browser. Press enter. It's only a small file, so it should download quite quickly. You can see that it's finished there. And I'll just close down the browser now because we no longer need that. Alright, so if we have a look now, we can see that we've got this file. But note the file name's a little bit funny, so what we're going to do is change that name. So we're just going to rename it. So I'm just going to type mv space v and press tab to expand the file name. And I'm just going to call it SQLite browser. So we've now changed or renamed that folder. Now I'm going to go into that folder, cd space SQLite browser. And I should have obviously added or kept the .tar.gz. So let me do that. So SQLite browser.tar.gz. That's what I was trying to do. Alright, so now we can extract that file, so tar space xvf space and just type SQL and press tab. The rest of the file name is shown and we've unzipped it. Now we want to go into the folder, so cd space sq, go into the folder that has been created. You can see it's that one there. And what we want to do then is we want to issue a couple of commands, a qmake, which is a tool produced or that comes with Qt, which you may be familiar with. So we may have to install that on your computer. And I'm going to show you how to do that if necessary. So we need to run these tools now to build it. So first things first, you can try typing in qmake. And if you get an error like we've got here, essentially that's saying it can't execute at no such file or directory. It means Qt isn't installed on your computer. So if that's the case, we need to install it. I'm going to show you how to do that now. But if you've got nothing, you've got no output at all, and you just got back to the prompt, that actually means that it worked okay and you can bypass this next command and move on. But in my case, I got an error, so I'm going to type sudo space apt-get space install space, and we'll start with qt4-qmake space cmake space, then we want lib sqlite3 -dev space lib qt4 -dev, and the last one lib qt4 -qt3 support. Press enter, type in your password, press enter there to accept the default of yes, and this will now download and install the various packages that we've selected. Okay, so the installation is now completed. So I'm just going to clear the screen so we can see the commands again. So now I'm going to type that command that we got an error before, which was qmake. This time it almost instantly returned, and that's what I was saying, that if you had this installed already, that's the output you would have seen. You wouldn't have seen any errors at all. So That's obviously telling us that we installed Qt correctly. And the last command now we're going to type is make. And that's actually going to now build the SQLite database browser. So that'll take a little while to build. It's going to take a minute or so to complete depending on the speed of your computer. But once we've finished, we'll end up with an executable file that we can run that gives us a nice GUI interface for SQLite databases. Alright, so at this point now it's finished, and what's happened is now there's been a source folder that's created. If I type in cd space src and have a look, and we've now got, you can see in green in the top right hand corner of this terminal window, SQLite browser. So we can actually launch that, /sq space, and I can just do an @ so it runs in the background. And you can see we've now got our nice little DB browser for SQLite utility. And at this point you can add it to the dash or do whatever you want to do if you want to add a shortcut to get it to start each time. Alternatively, you can just go into that folder and start it manually using the command line like I've actually shown you. Alright, so we've now installed the SQLite browser, DB browser for SQLite application for Windows, Mac and Linux. In the next video what we're going to do is fire up the DB browser and just have a bit of a look at it. And then we'll swing over and start working on our first project in IntelliJ that uses this JDBC SQLite driver that we downloaded in this video. See you in the next video. Okay, so moving on now, let's actually run this DB browser program. We started to do that at the end of the last video. So I'm just going to start it. So start it up on your operating system. This is what it looks like. Now it won't display anything obviously until we connect to a database. One thing to note about the DB browser is that if you use it to make changes to the database, it'll actually lock the database file and you'll no longer be able to access the database from a Java application. So if that happens, you can actually come up here and go to File, Close Database, and that will be enabled if you've got a database open, and that will release the lock. So you'll be able to use that again. So keep that in mind that if you're getting some weird errors in your Java code, it could be because you've got the database opened in DB browser and you need to close it, so you're releasing the lock. Now it's time to write some Java code. We're going to start by creating the same test database we created from the command line to see how to connect to a database using JDBC. So let's go ahead now and open IntelliJ and create a new project. And we'll call this one testDB. TestDB, and in my case I'm going to save it into the folder where I've got my other Java programs. Click on Finish, and I'll wait for that to start. Alright, so one of the first things that we need to do is we need to add the SQLite JDBC driver to the project. So let's do that by going to File, then Project Structure. And we need to select Libraries over here from the left hand side. Then we need to press the green button, which would be green on Windows, but it may or may not be on the Mac, which it isn't here, or on Linux. But in any case, you want to click on this plus button here and select Java from the little pop-up. Now we need to navigate to the SQLite JDBC jar file that we downloaded and add it. In my case, it was in the Downloads folder. We have the SQLite JDBC.jar, so I'm going to open that. And it confirms that it's going to be added to the selected modules, which is this currently open project. Click on OK. It's now showing, as you can see on screen, as a library, and we can click on OK. And we'll be able to now access that in our application. Alright, so the first thing we want to do at this point is create the database. Now in a real-world application, often a database will ship with the application or the database will exist on a server somewhere. But sometimes you might want the application to create the database the first time it runs, or perhaps the first time a user does something. Now when using SQLite, connecting to a database that doesn't exist will create the database. So we don't have to create the database in a separate step. We just have to try and connect to the database, and if it doesn't exist, SQLite will create it for us. Now, all JDBC drivers need a connection string that they'll use to connect to the database. Now, the exact format of the connection string will vary from database to database, but one thing they always have in common is that it starts with JDBC:. Now, for SQLite, we follow JDBC: with SQLite:, and then we specify the location of the database. Now, other databases may well require just additional information. For example, they might require a username and a password. Now, we can also specify database attributes with the connection string. For example, we may specify that we want a SQLite database to be stored in memory. So to find out what's required in a connection string for a given database, you can check out the JDBC drivers documentation. As I've previously mentioned, nothing is 100% portable, and this is one area that varies from database to database. Now, we don't want to connect to the databases we created in the earlier videos, so let's actually call this database testjava.db. So I'm going to start the program. I'm going to put in what you typically do on a Windows platform, but then change it to a Mac. So we're going to start with a try, and we want to actually catch a SQL exception. That's going to be the error. And we'll do a system.out, something went wrong, plus e.get message in the case where we're having a problem opening. Now the actual line we want, we're going to type connection con equals, I'll accept that import, that's java.sql, so it's going to be driver manager dot get connection. It's going to be JDBC SQLite and let's just say you had a file in Windows which was d:\databases, and you wanted that file to be accessed. You do something like d:, and you have to double backslash on Windows. You have to escape the backslashes in string. So you'd put //databases //testjava.db. So that's how you typically access it if your database is going to be on the D drive in the databases folder. So I'm just going to leave a copy of that line for Windows, but the Mac equivalent, what I'm going to do is put it in the path you can see at the top here. I'm going to put this in the actual root path of this project, for want of a better place. So what I'm going to do is just duplicate that path on the top there for the Mac. So I'm going to type volumes/production/courses/programs/java programs/testdb, making sure I've got my case hopefully correct. So that's going to create the database in this folder. Now, depending on what version of IntelliJ you're running, I've mentioned this before in the course, but the most recent versions are starting to add this helpful, although personally I think it's a bit annoying feature that prefixes all the method parameters with their names. Now, it's turned on by default, but luckily you can turn this off fairly easily by just going into settings. So let's actually go ahead and do that now, because I'm not sure about you, but I find it a little bit frustrating. So go into your settings or preferences in this case. Then you want to select editor, and then general, and then under appearance, there's this show parameter name hints. So I'm going to take the checkbox off for that to turn off that quote unquote feature, so we're not bothered with that anymore. And you can see that's now removed that, and I personally think it's more readable with it removed, but it's up to you as to which way you want to go. Alright, so what are we doing here? Well, we've set up a connection string. We've called driverManager.getConnection, and that accepts the connection string and returns a connection instance. Now, the method may throw a SQL exception. That's why we're trying to catch that and just printing out an exception message. Now, if the JDBC driver isn't on the class path, then you'll actually get a class not found exception. So this is the new way of connecting to a database when using JDBC 4.0 and above. When using earlier versions, we actually had to register and load JDBC drivers by calling the class.forName method with the driver class name. So you'll see lots of older examples around the internet that use this forName method, and that's just why I'm mentioning it here now. So in the older version, we would have had to do something like class.forName org.sql .jdbc, which is a little bit weird, but we certainly don't need to do that anymore. So I'll just comment that out. So there's actually two ways of establishing a connection using JDBC 4.0. So one is using the driver manager, as we've done here, and the other is using data source objects. Now, the latter is sometimes the preferred way, and that's because it allows advanced features like connection pooling and distributed transactions, and it's also more portable because of the way connections are established. Now, we don't need these features when using SQLite, and they require that a database administrator set up the database to enable use of these features. It's also a lot more complicated to use data source objects, and they're really only needed when working with large enterprise applications, particularly JEE or Java Enterprise Edition applications. Now, we're not going to cover using data source objects for that reason. We're going to stick to using driver manager, but I'm just mentioning data source objects in case you come across them, although you shouldn't unless you're actually working on enterprise applications. Alright, so let's go ahead now and run the application to make sure we're picking up the SQLite library that we've added and that it's working okay. And we'll just right click this and run it. And you can see that it completed okay. We've got no errors, no exceptions, and I'll just put this down to the bottom. But more to the point down here, over here to the left in the project pane, you can see there's testjava.db, and that's the file, the database being automatically created, meaning that I've obviously got the path correct, and it's been successfully created for us because it didn't exist. And again, if you recall, I said that when you try to connect to a database in SQLite, if it doesn't exist, it tries, or it actually creates the database for you. Now, if you're getting errors at this point, make sure the SQLite JDBC driver has been added to the project, and also check for typos in the connection string. So in the case of Windows, make sure you are escaping your backslashes and you've got the exact path. And also, just as a general rule, it's good to make sure you've got the exact case and don't rely on your operating system to figure out whether you meant the upper or lowercase version of a letter. All right. So next we're going to create the context table that we created when we were working with the testdb database from the command line in this section. Now, whenever we want to use SQL with JDBC, we use what's called statement objects. So to create a table, we're going to call the connection.createStatement method, and then we'll use the statement.execute method to run a SQL statement. All right, so let's look at the code. We'll type that in and then we'll talk about it. So we're going to start on the line after the connection. We're going to type in statement. Statement is equal to, that's going to be connection. I'll just accept that import, java.sql. So connection.createStatement. Then we're going to do statement.execute, and then we're going to type in the SQL code we want executed. In this case, we're creating the table, so it's going to be create table contacts, then it's name, text if you recall, phone, integer, and then it's email, which was text. Okay, so after getting a connection instance, we're creating the statement instance. And we're then calling the execute method on line 17. And we're passing the SQL command that we want to execute, in this case, the SQL to create the context table. So basically, we're passing the same SQL statement we've used in the past when we created that table using the command line. Now, notice that I didn't need to add the semicolon to the end of the statement. And that's because the driver understands that when we call execute, we've passed a complete SQL statement. And it's also important to note that we created the statement object by calling a connection method. So the statement as such is associated with the connection and can only be run against the database we connected to when we created the connection instance. All right, so let's actually run this to make sure that it actually works. And that we don't get any errors, and we're not getting any errors there. And notice that the database there has changed to the picture of a database icon. So that indicates there's some data in there, and IntelliJ is smart enough to figure out that that's relating to a database. All right, so let's go swing back over to the DB browser. And let's go ahead now and open the database. So I'm going to open it. So there's my testdb folder. I'm going to select testjava.db and click on open. And you can see there that we've now got a context table. And I can expand that now. You can see that we've got the various fields. We've got the name, the phone, and the email. All right, so that's good. Now, the connection and statement objects use database resources. So when we're finished with them, we should actually close them. Now, if we don't, the Java runtime will eventually close them for us, but it is actually good programming practice to close a resource as soon as we've finished using it and we're sure that we don't need it again. Now, in trivial applications like this one, it doesn't matter, but in large applications that use multiple database connections, if you're not closing resources that you don't need, it's possible that you'll run out of resources and the application will no longer be able to work with the database, or perhaps the performance of the application will degrade. So it's obviously very important to make sure that you are closing the connections once you've finished using them. Now, one of the things you could do, we've talked about this earlier in the course, using the newer style of the try statement, and we could get that to close for us automatically. So let's just change the code so you can see that syntax. It's going to be try, and we're just going to copy the connection line. So you recall this syntax, the newer style try, and we'll paste in the connection with driver manager, a semicolon there, then on the next line, we'll also add our statement line. And then within there, we're going to put just our statement.execute. And what I'll do is now remove that because that's now in the top part of the exception. And I've got this error here because I haven't got the right language level set for this project. So I'm going to just change that, going into File, Project Structure. Click on Project, and I'm going to choose version 8. Click on OK. Alright, so you can see I've used the new try with resources connection here, and the advantage of this is that the resources will be closed when the try catch block is exited. So that's an alternate way of actually doing it that I recommend. But for now, what I'm going to do is stick with explicitly closing any resource we no longer need to drive home that it must be done this way. So what I'm going to do is just take a copy of this, duplicate it, and I'll comment out those 3 lines, and I'm just going to revert it back to the old format. And I've got a problem here which I'll just fix as well. And let's just reformat the code. Alright, so we'll just stick to that version, but I'm leaving it in the comments anyway, so you can know that you can actually do the try with resources if you want it to automatically be closed. But I want to get us to get into the habit of just closing this manually because it's a good habit to get into as a rule. So basically after the execute, we want to do a statement.close and then a connection.close. And just a final note before I finish this video, the order in which we close database resources is important. You should close any statement instances before we close the connection. And if you think about it, that's logical, because if we close the connection first, then the database has been closed, and actually what will happen is the SQL exception will be thrown with the message SQL error or missing database. And again, that's because the connection's closed. So remember that a statement is associated with a connection, so it's sort of hanging on and using that connection. So if you're closing the connection, we can't actually use any statements that were associated with it. Alright, so now that we've closed the database resources in our code, let's just run it again. And whoops, we've actually got an error here. Now the message printed to the console down the bottom says that the contacts table already exists. Now we're trying to create the table again, which is an error. But let's start looking at that and how to fix this in the next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Alright, so let's try running this program again. So I'm just going to right click and run it. And as I mentioned towards the end of the last video, when we run it again, we get this SQLite error. Something went wrong. SQLite error or missing database, table contacts already exists. So the first time the user ran the application, or in our case we ran it, we want to create the table, but the second and subsequent times we don't want to do that. So how do we handle this when our application needs to create the database and tables? We don't want to drop the table every time the application runs because the user will lose whatever data they've added to that table. Fortunately, that is another way, and what we can do is we can tell SQLite to only create the table if it doesn't already exist by adding if not exists to the create statement. So in that scenario, SQLite will only try to add a table if the table doesn't already exist in the database. So to do that, we just come up here to our create table statement and add if not exists. And let's just break this into 2 lines, which can often be a better way of doing things, plus like so. I'll just tab this over a little bit. I like doing that with SQL statements because it just makes it easier to read. Alright, so let's just run this and confirm that we don't get an error anymore. So you can see the program's exiting normally now and not showing an error. Now I've said that we've broken the SQL statement up here for readability to make it easier to read, but right now we're hard coding the SQL, and that isn't the best way to do things, but we'll hold that thought just for a moment. So now that we have a table, let's go ahead and add some data to it. Now just as with the command line when we're using SQLite, we're going to use the insert statement, but once again in Java we need to use a statement object to make that happen. And let's just reuse the statement object we've already got, because we are able to do that. So below the statement that executes to create table by SQL, the SQL, we're going to add a couple of rows. So we're going to do statement.execute, and the code's going to be insert into contacts. So name, phone, email, right parentheses, then we'll add a space and then plus, and we'll just go into the second line again. Then it'll be values, and we're going to go ahead now and put the values in single quotes if they're strings, like in the case of Tim, because obviously we're in a double string at the moment. 6545678, comma, then my email address, tim@email.com. No, that's not my real email address. Okay. Right, so let's just run this to confirm that it works. We've got no errors, that's a good sign. We'll have a look at our DB browser again. And we can switch over here to the Browse Data tab, so click on that. And you can see it's now showing a record. That font's rather small, but I'll just size that up. You can see that it is showing that the record has now been added to the database. And just in case you're already on that screen, there's got a refresh button here. So you can click on that at any time if you're going back to IntelliJ and coming back to here, and that'll refresh the view and show the data. Alright, so let's add another 2 rows here to the database back in IntelliJ. But before we go and do that, it's probably a good time to mention that the JDBC connection class commits any changes we make to the database for us immediately after a statement is executed. Now we'll cover the ramifications of that and what this means in more detail in a later video in this section of the course, but for now though, understanding that depending on which database you're working with and what type of connection you use, sometimes you have to explicitly commit any changes you make to the database for those changes to persist. And if you don't commit them, closing the connection will also mean that we lose any changes we've made. In other words, they're rolled back. For example, if the JDBC connection didn't commit changes for us, then after we added a row to the database and closed the connection, we wouldn't see the row when we looked at the data table in the DB browser. Now the default behavior of JDBC connection objects is to auto-commit all changes. So let's temporarily set the connection to not auto-commit changes for us. What we'll then do is add another row to the table by changing the existing line of code to use new values. So after the connection string or the connection line, line 16, we're going to type con.setAutoCommit, and we'll set that to false. Then just for simplicity, what we're going to do is just overwrite the values in the insert statement, which will give us another record. So I'm going to make that Joe. And let's change the phone number just so we can notice that it's different. 45632 and joe@anywhere.com. Alright, so I've turned auto commit off and we've changed the values. So if we run, we should find we don't get any errors. And it's finished successfully. And if we swing over to the DB browser and we do a refresh, note now that we're not seeing the new record. So the new record hasn't been added. And that's because we turned off auto commit by calling the connect set auto commit method back in the code. And the connection is no longer automatically committing changes to the database for us. Now we can call a method to commit those changes, even with set auto commit off, and we'll look at doing that in a future video. But I'm mentioning this here now in case you may have expected the changes we're making to be rolled back because we're not committing them. In other words, if you've got some experience in another database, perhaps in another language. So now I'm going to comment out the call to set auto commit. And in addition to inserting the new Joe row, we're also going to add 2 more rows just so we've got a bit of data. So I'm going to comment out line 17. And let's copy and paste the statement that execute that inserts the records. And we'll leave the Joe one in there. Right, so for the first one, let's make that one Jane. 4829 484. Jane@somewhere.com. And for the last one, let's go ahead and make the email address for that one dog@email.com. The phone number 9038, and let's make the name Fido. Okay. Alright, so let's just run this code now. No errors, as you can see there. The set auto commit has now been commented out. We go back to the browser now, and now we do a refresh. We can see that the other 3 records are now showing. And that's obviously what we wanted to do. Alright, so inserting is working. Now let's go ahead and update Jane's telephone number using the update SQL command, as we learned to do previously when we were looking at SQLite in the command line. So what I'm going to do is just comment out these inserts because we don't want those to rerun. And we're going to do a statement.execute. And it's going to be update contacts set phone equals 5566789 where name equals Jane. Again, I'm using single quotes there for strings so that we don't have to escape them or make it any more complicated than what it is. Alright, so let's just run this to make sure that the update works. No errors. And we'll go back to DB browser. You can see Jane at the moment has got 4829 484. Refresh. You can see the phone number's changed to 5566789. Alright, so let's go ahead now and delete Joe. Now just before we move on, importantly, again, I have mentioned this before, but it's vital that we use a where clause when we want to update or delete. Otherwise, all the rows in our table will be updated or deleted, which won't be what we want to happen most of the time. And I can certainly tell you of a few stories where I've accidentally forgotten to put a where clause and deleted production data. So always good to check, especially when you're learning SQL, have you got a where clause to make sure you're not deleting or updating more things than what you wanted. Alright, so let's go ahead now and delete Joe from the table. Now I can leave that existing update in even though the phone is already set because of the where clause. So I'll just leave that in there, but I could have commented that out. Statement.execute, and we'll do a delete from contacts where name equals single quote Joe, double quote, and close off the line. And if I run that again now, no errors. Back to DB browser. You can see Joe's there at the moment. Refresh. The Joe record has now been deleted. Alright, so we've seen how to add, update, and delete data from the contacts table, or to or from the contacts table. Now, JDBC wouldn't be very useful if we couldn't query the data, Of course, we can do that by using a select statement. But how do we actually process the query result? So let's go ahead and retrieve all the data from the contacts table using the SQL statement select star from contacts. Now the statement.execute method returns a boolean that will be true if the statement we executed returned an instance of the result set class, and false if it returned an update count or no results. For example, when we execute an update statement, the execute method will return false because the result of the update statement is the number of records that were updated. Now when we query the database, the method returns the records that match the query as a result set instance. Now we can actually get the result set by calling the statement.getResultSet method. And once we've got that, we can then loop through the results. So let's go ahead and try this out. I'm going to now comment out the updates and the deletes, or the update and delete, because we no longer need those. And let's actually now add this statement that ultimately will get us back a result set. So we're going to do a statement.execute select star from contacts, so all the records. Then we're going to do result set results is equal to statement.getResultSet. Then we can do while results.next. Then we can do a print out of results.getString name plus a space plus, let's put it on the next line just for easier reading, results.getInt phone, remembering that phone is been defined as a number, an integer, plus a space then, and onto the next line. And finally, we'll get the email address, results.getString email. Okay, so we're printing that out. And then the only thing we need to do after the while loop is then do a results.close. So in this code, we call execute to perform the select and then get result set to get the results. And we're then looping through each record, and then we're printing out, or we're about to print out, the name, phone, and email. And as you can see, we get to the value for a column by calling the appropriate get method for the values type, string or int, depending on which column we're working with. So let's actually run that. And we can see we've got 3 records returned there in the run window, so that's telling us that that's worked okay. Now every result set has a cursor. Now this cursor isn't the same as a database cursor. We could have had several result set objects, and each one will have a cursor. However, and this is actually quite important, if we reuse a statement object to do a query, then any result set associated with that statement object is closed, and a new one is created for the new query. So if we want to work with several query results at the same time, then it's imperative to use a different statement instance for each query. Reusing the statement instance was okay when we were just doing insertions, updates and deletes, because we weren't using or checking the result. Now we can reuse a statement object to query, but only if we finish processing the results of one query before we execute the next query. Now keep in mind that a statement object ultimately can only ever have one active result set associated with it. Now when a result set is created, its cursor is positioned before the first record, and so the first time we call results.next, the cursor will be moved to the first record. Now when we call it again, the cursor will be moved to the second record in the result set. When there's no more records, the next method will return false. And when we call one of the result set's get methods, the values returned are those from the record at the result set's cursor's current position. Now we'll come back to the result set cursor when we work with a database from within a GUI application. Now note that result set is a resource, so we have to close it, and you can see that I added the results.close on line 35. And that's because it's associated with the statement instance. We have to close it before we close the statement. Now we're closing all our resources at the end of the try block. If an exception is thrown, it's possible that the close methods won't be executed, even though some or all of the resources have been created. Now for our small application, it doesn't matter. When the database objects are destroyed, they'll do the appropriate cleanup. The close method forces the closing of the database resource immediately rather than waiting for them to be automatically closed. Because of that, we don't have to close them ourselves, but it's actually good practice to do so. And if our code belonged to a large application in which there were lots of open connections and result sets and statements, we'd have to be a lot more diligent about making sure the resources were closed as soon as we no longer needed them. Alright, so let's finish the video here now. In the next video, I want to show you an easy way to perform queries and getting the results. So let's work on that in the next video. So we ended the previous video performing a simple select query and getting the results to the in the run window down the bottom, but there's actually an easier way to perform queries and to get the results. So instead of having to use the execute method, we can use the execute query method, which actually returns a result set. So let's just update the code to use that instead. And what we can do is here where we've got results, well, these two lines here, what we can actually do is comment those out, and the replacement line for that would be result set results is equal to statement dot execute query, then would be select star from contacts, like so. And if we run that, you can see we get the same results. But the advantage here is we're using less code. Now what we can also do is retrieve the values from a record using the column indices rather than the column names. In fact, using the column indices is faster, and so it's the preferred way to do it. Now we won't change the code in this application, but we'll use column indices in a future video in this section of the course when we start working with the music database. But what we do know now is how to do the basic CRUD operations, create, replace, update, delete, using JDBC, but frankly the code we've written can be improved quite a bit. Now when we were working from the command line, it was okay to hard code everything. In fact, we had to. Each SQL statement was executed in isolation, so we didn't have to worry about commenting out lines of code because only the SQL statement we just typed was executed. Working with a database from within an application, though, means that our statements aren't run in isolation. So we shouldn't have to type in the table and column names every single time. In fact, it's bad practice to do so. So just imagine that we've completed the application that works with the contacts table in the testjava.db, and then our manager or client tells us that we've decided to rename the name column to first_name. So since we've hard-coded everything, we'd have to find every instance of name and update it to first_name. Now that would be trivial in our tiny application, but there's still the possibility for typos or for accidentally updating the wrong column name in a statement. Now using hard-coded strings for our SQL statements also makes our application vulnerable to what's called a SQL injection attack. Now we'll come back to this security problem in a later video in this section of the course. So what do we usually do when we're using a hard-coded string in more than one place in our application code? Well, we create constants for the strings and use those constants. And if we want to rename something, then we only have to change the name in one place. But we can also improve the code in another way. When we were adding records to the database, we repeated the same code several times. Now, repetitive code should always provoke the thought that maybe we should write and use a method instead. So let's go ahead and update the code to use constants and a method for insertions. Now we could create a separate class for the string constants we'll define so that any class in the application will be able to access them, but just to keep things simple, we're just going to go ahead and define them within the main class. Now we're going to use a separate class when we work with the music database in a future video in this section of the course though. So what we're going to do is add constants for the database name, connection string, table name, and column names, and also update the code to use them. We're also going to drop the table when the application runs and uncomment all the code. So every time the application runs, we'll recreate the table from scratch and then perform the insert, update, delete, and select statements. At the end of it all, the goal is to see 3 rows printed to the console for Tim, Jane, and Fido. Now note that we're using the if exists when we drop the table, or we will be using that, to avoid an exception being thrown if the table doesn't exist. And I'll show you how to do that shortly. But let's go ahead and now actually make all those changes. So we're going to start right at the top And we're going to start now creating some constants. So just below the class definition, we're going to start with PSFS, public static final string, and we're going to start with the database name. So db underscore name equals testjava.db. Then we want a connection string, connection underscore string equals, that's going to be jdbc colon SQLite colon, then you need to paste in the location, well actually what I could have probably done was copy that entire string anyway, minus the DB name. We're going to put the last slash in there, but minus the DB name. So I'll just replace that for simplicity. But then on the end of that, I'm going to put plus DB underscore name. Okay, so next we want to do create a constant for our table name. So it's going to be PSFS, and we'll call this one table underscore contacts equals, and it's contacts. Then we want the column name. So PSFS, first one's going to be column underscore name, the name column, and that was called name, and PSFS column underscore phone equals phone, and PSFS, and the last one's column underscore email equals email. Alright, so that's all the constants we need at this stage. So let's now continue on. I'm going to just, as I mentioned, remove some of these comments. I'll remove those as we go through. So firstly, we're going to start now with the try, which we've got here. And the connection's now going to use the connection string. So I'm going to delete the hard-coded connection string and replace that with connection underscore string. I'm going to get rid of this auto commit to false. Statement equals con.create statement. Well, that's still correct. And we're going to add a statement now. So statement dot execute. We're going to add the statement to drop the table if it exists first. Drop table if exists. And notice how IntelliJ is doing an okay job with SQL keywords here. So it's actually finding a lot of them for us, which is pretty neat within a string. So drop table if exists space plus, that's table underscore contacts. Again, we're looking to avoid hard coding anything at this point. Alright, so we've dropped the table if it exists. Next we want to go ahead and create the table. So we can change this statement.execute create table if not exists, but then we're going to change the hard-coded reference to the table name and put plus table underscore contacts plus. Then for each field down here as we go along, we're going to, it's probably going to be easy if I just delete that and create it line by line, and I'll remove all these comments as well to make things a bit easier. Alright, so the lines we want to add here, and we're going to add space and then a left parentheses plus column underscore name plus, then the type, it's going to be text with the space there, important to put a space there, a comma, space, double quote, plus. Alright, so next we're going to add the column phone. So come over here to column underscore phone plus space, and then it's integer, comma, space, plus, and obviously we're adding double quotes there. The last one's going to be column underscore email plus space in double quotes text, and then plus, and then we'll close it off with a right parentheses and close off the string and close off the execute method call. Alright, so that's the code to create the create the table now if it doesn't exist. Next we want to write some code to insert an entry. So it's going to be statement, insert the first of the three records. So statement dot execute, we're going to start with insert into space, right double quote plus table underscore contacts plus, then we need to add our column names again. So it's going to be a space, left parentheses, double quote again, plus column underscore name, plus comma, space, plus. I'll just get rid of these other ones for the time being. Then we add the other two entries. Next one's column underscore phone, plus comma and a space again, and column underscore email, plus, we'll add our parentheses again, This time it's the right one to close it off. Space, but then we need to add the values. Plus, don't need to do a space here now because we've added a space at the end of the previous string. The values are going to be then Tim 6545678 tim@email.com. Single quote, right parentheses, double quote, right parentheses, semicolon. Right, so that's our first insert, record number 1. And rather than typing that all in again, we're just going to copy the entire record again. The entire set of strings, the entire statement, 2 times, and then we're just going to change the values this time. So the second time, it's going to be Joe. And by the way, these messages here, you can see that it's coming up saying no data sources are configured to run the SQL. There's a way to disable it. So that's just IntelliJ complaining about the fact that we haven't configured the data source. But we're not actually using a data source within IntelliJ at this point, so we can safely ignore those warnings. All right, so the second one was Joe. And Joe's phone number 45632. And his email, joe@anywhere.com. Okay, and the third entry there was for Jane. It's jane@somewhere.com. Okay, and the number we used for that, 4829484. And that was Jane. Actually, we had another one initially, didn't we? We had a fourth one, and then we actually ended up deleting it. And so we need to add Fido as well, because I think we deleted Joe at some point. So let's do that. So Fido is going to be dog@email.com. And phone number for that is going to be 9038, and name is going to be Fido. Right, so that's our 4 rows that we're going to be adding to the database shortly. And now what we want to do is do the update for Jane's phone number that we originally did when we were working in the previous video. So statement.execute, and it's going to be this time update space double quote plus table underscore contacts plus space set space plus, and we want it's going to be column underscore phone plus, then we want to set that equal to 5566789 plus, we need to add a where clause, double quote where, and actually we need a space first, so space where plus, and it's column underscore name plus double quotes, and it's going to be equals, and then single quotes Jane with a capital J, single quote, then we close off that line. Alright, so there's our update. We now want to delete the Joe entry, so it's statement.execute, and it's going to be delete from space plus table underscore contacts plus, then on the next line, double quote, and then where, actually we'll go put that back so it's in line with the other code, so where space plus column underscore name plus is equal to Joe with a capital J, and close off the line. That's our deletion done. Then the last thing here is we've got the result set to print out. At the moment that's hard coded, so we'll just change the hard coded reference to the table name and change that to table underscore contacts, like so. And also now for the get string, we're going to change that to column underscore name for the phone. I'm going to change that to column underscore phone, obviously. And the last entry, column underscore email. Right, so at this point we should have removed all the hard coding. There should be no SQL code that's got hard coded database names, connection string, table name, or column names. I think that looks pretty good. So note that I've sort of spaced out some SQL statements here over multiple lines. The intention there is to make them a little bit easy to read rather than sort of going from left to right across the page. As you start building up sort of long lines like these inserts, for example, it can become quite difficult to read. So by spacing it out and putting it over multiple lines and trying to also line up the columns, it does, I feel, make it a lot easier to read. It does get worse when you're creating SQL statements by appending constants and strings together. So it's really easy to miss adding a blank between two words, for example, or to miss a single quotation mark. So this will help, but also when we go to run this, the exception message we get will usually give us a good idea of where in a statement to look for in an error. So let's actually try running this now just to see whether it does work. And here's an example of this that does SQL error or missing database. Now what we've got is for our SQL statement, we've actually got a message there, but we should probably do a stack trace as well so that we can actually see the exact line where it crashed to help sort of us figure out where the problem is. So we can actually do a e.print stack trace. So if we do that now and then run it again, we've actually got some more errors, more information here now. And we can come on down here and eventually it tells us that the main.java line 23 is the problem. And we've got a trace of the other code, db.java. So that code is all part of SQLite's drivers. But let's go back to line 23 by clicking this. And we can see the problem's likely to be here. And you can see what I've done there. I put a left parentheses instead of a right parentheses. Let's fix that up and we'll try running it again. This time we've got the required result. We've actually got the 3 records again, which is good. And if we go back and just do a refresh, nothing's changed because, of course, we still ended up with the same 3 entries we did previously. All right, so at the moment, though, we'll notice that looking at this code, we've actually got some duplication of code here. This statement.execute, these 4 inserts are duplicated. So what I'm going to do first is show you the obvious way to do it, but it won't be the best way. We're going to revisit running the same SQL statement but with different values in a later video. So let's, for the moment though, add the method to main.java. So right down the bottom, I'm going to add that. I'll make a bit of space here. And the method's going to be private static. We need a static method because we're calling this from the main method, which is static. So public static void insert contact, we'll call it. And the parameters we're going to pass here is statement, string name, string phone, int phone because it's an integer, and string email. All right, then the code that we're going to use, I'm just going to grab some code from one of these inserts. I'm going to copy that. I'm going to paste that in here. So what we'll do there is to fix that up, we're going to throws SQL exception because we're actually catching the exception in the method that ultimately is going to be calling this. So we've got values there correctly. So we're going to do, we need a single quote, then a double quote, plus name being the first parameter, plus we need another single quote to close it off, comma, space, plus phone, plus we need another comma there, a space, then a double quote, a single quote, then a double quote, plus email, plus then we need our single quote to close off the email string, right parentheses, double quote, right parentheses, and a semicolon. All right, that should be it. So we've now basically put in here the 3 values that are called or are passed as parameters to this, and we're using the statement object that is passed to this method as well to update it. And now what we should be able to do is change our inserts here to abbreviate them, and it's going to be much easier. It's going to just be insert contact statement, and I'm just going to put a comma here, and we can go down and we can actually put these values in here like so. But what we'll have to do, of course, is convert the single quotes to double quotes to keep the Java compiler happy. Okay, and same for that one. All right, so that's going to be the equivalent of that first line. So let's go ahead and change the other ones. And what I'm just going to do is probably going to be quicker for me just to paste it like that and put in the values. Anywhere.com. Jane@somewhere.com. And I think the last one was dog@email.com. Okay, next entry there was for Joe, then it's Jane, then it's Fido, and lastly the phone numbers, change those. Joe's phone number is 45632, Jane's is 4829484, and Fido 9038. So that's our 4 inserts. So we can now delete all these inserts because they've been replaced with the method call to our insert contact method. So let's actually try running this just to make sure it still works. Okay, you can see we've got the same results. Now, as I mentioned though, this isn't the best way to do it, but I'm going to cover a better way in an upcoming video. But at least for now, we don't have all that repetitive code. And if we did have to make a change to, say, a column name, we could just come up here and change the column name once, and that would then change and be reflected throughout the rest of the code without us having to change anything else. Alright, so that's it for the introduction to JDBC. Next, we're going to switch to working with the music database and start performing some more interesting queries. And we'll also start taking a look at more features offered by the JDBC API. See you in the next video. Alright, so we're now going to switch to using the music database that we used in previous videos, so we have a decent set of data to work with as we look into more detail at performing queries using JDBC. So to make sure that we're all starting with the same data, I've already downloaded the database again from a previous lecture. That's that music.zip file. I've already unzipped it, and you can see here I've unzipped it into this project. And this is actually a new project that I've created in IntelliJ called Music. So again, I've just copied the music.zip file from previous videos in this section of the course when we were doing command line queries, unzipped the file music.db, and it's now in the same folder location as this new project. Alright, so let's now swing over to DB Browser for SQLite and open that file to just check it out. So I'm going to come up here and click on Open Database. I'm going to open the music DB, and that's in my music project. And you can see there we've got some representation of the 3 tables: albums, artists, and songs. And we can browse whenever we want to by clicking on Browse Data, which can be quite useful. And we can actually see the various records as we scroll down. And I can change the table that I'm looking at, artists or songs. And again, we get a pretty good visual representation of the data. Now, in the previous videos, we talked about JDBC, and we weren't really that fussy on how we wrote the code. And that's because I was more interested in teaching you the basics of how to connect to a database and how to perform the basic CRUD operations. But in this video, we're going to start paying more attention to how we structure our code, especially since we'll eventually want to work with the music database from a GUI type application. So what we're going to do first is start by connecting to a database, and this time we're going to use string constants from the beginning. We're going to create a new package in our project called model. So let's go ahead and do that. We'll expand out the source folder so we can see it. And I'm going to create a new package, and we'll call it model. And then we're going to right click model, and we're going to create a new class, and we'll call this one data source. Okay, now we're going to need constants for the connection string, the database name, the table names, and also the table columns. So let's go ahead and do that. So I'm going to start with PSFS, and it's going to be db_name. We know the name for that one, music.db. We can see that over the left hand side in the project pane. The connection string, PSFS, and it's going to be connection underscore string is equal to JDBC colon SQLite colon. Now, if you're on Windows machine, you type something like D colon backslash databases backslash, remembering that we're escaping the backslash character in a string, and put a plus DB underscore name. So you would do that if your database, your music.db, is in the on the D drive in a folder called databases. But in my case, you can see that I'm on a Mac, and that's the path to the file. So I'm going to change that. But what I'll do is I did in the last video, I'll just leave a copy of that there so you can refer to that just to get the right syntax. But in my case, on a Mac, I'm going to put /volumes, /production, /courses, /programs, /Java programs, /music. Then another slash there, and then the DB name gets appended to that automatically. And if you're on Linux, you do something similar because the path will be pretty much the same. Well, at least the path structure will be, obviously it'll be a different path for your computer. Alright, so moving on, we want to now add the table for album. So it's PSFS, it's going to be table_albums equals, and the table name was called albums. Then we want to define some columns. So column_album_ID equals _ID. PCFS again, column_album_name equals name. PCFS column_album_artist equals artist. Alright, let's do the other two tables now. So PCFS again, this time we want to work on the artists table. So table_artists is equal to, and have the name of artists in the database. Then we want column_artist_ID equals _ID. Then we want column_artist_name. Let's set that to name. And that's it for the artists table. And finally, for the songs table, table_songs equals songs. Then we want column_song_track is equal to track. Then column_song_title equals title. And the last one, column_song_album, album is the name. Alright. Now because all the tables have a column called _ID and two of the tables have a column called name, you might be tempted to have only one string constant for name and one for ID or _ID that we use for every table. But it's better to have one string constant per table. That way we can change the name of any column in a table without worrying about or impacting on other tables. This makes our code a lot easier to work with. Alright, so let's keep all our database code within the model package. So instead of connecting to the database directly from the main method, let's create a method within the data source class to do that. So we're going to declare a connection instance variable because now we'll want the user of the data source class to call a close method when it's finished working with the database. So we want to do a private connection. I'll just call it con. Accept that import, the java.sql. Alright, so the next thing we need to do is add an open method to open the database and a close method to close it. So public boolean open. And we could do a try with resources, but I won't do that here because I'm just trying to get you into the habit of opening and closing. But you could certainly do that if you wanted to, but then we wouldn't need the close method. So I'm going to actually code it the long way. So we're going to start off with that for a try. Then we'll do connection equals driver manager dot get connection, and it's going to be connection underscore string. And then we're going to return true, and then we're going to catch SQL exception, and we'll do a print out if there's a problem, and we'll just say couldn't connect to database. Then e.get message, so we get to see what the error is. Then we'll return false there. Alright, so obviously we're going to return true if we successfully opened the database, and false if we didn't. We've got a SQL error of some sort. Alright, so that's the open method. So the close method is going to be similar to what we've worked with before. Try. Then we're going to do a test first to make sure colon is not equal to null. No point closing it if it is set to null for some reason. Dot close. And then here we want to do a catch SQL exception again, and couldn't close connection. You don't get message, and should be public void close to keep Java happy. Alright, so in the open method we use driver manager to get a connection. The method returns true if a connection is successfully established and false otherwise. And in the close method, unsurprisingly, we close the connection. Alright, so going back now to main.java, let's actually test this out. So we're going to start by creating a new instance of our class. So data source is equal to new data source. Then we're going to do if not data source dot open. We're going to print out a message. Can't open data source. Return. And then down here we're going to put data source dot close. Alright, so let's just run this. And you can see we've got an error here, so let's just put this down the bottom again. And you can see the error message there, couldn't connect to database, no suitable driver found, and then for our SQLite JDBC driver, and of course the path as well. So we've missed an important step. We haven't added the SQLite JDBC driver and database classes to the project. So let's go ahead now and go to the project structure libraries and add the SQLite jar file. While I'm here, I'm going to change the project level to 8. Select libraries, click on plus, select Java. I'm going to select the JDBC driver that we used previously in this section of the course. Click on OK, click on OK again. Try running it again this time. And this time we haven't got any errors, so obviously the driver is now working fine. Now incidentally, if you get your path wrong, so in other words, back here in the data source, if you've accidentally typed that wrong, what you'll find will happen is if it's still a valid folder, the database will get created for you, but it will be an empty database. And you might be wondering at that point why you aren't able to see the various tables, and that's because you got the path wrong. So do make sure you double check and triple check that you've got the right path, especially if you've got any problems opening and getting any errors, because remembering that the SQLite driver creates the database if it can't find it. Alright, so let's now go ahead and perform our first query. So the artists table has the fewest number of rows, so let's select all the rows in the table and print them to the console. Once again, we're going to add a method to the data source class to do this. Now in large enterprise applications, we may well create a class in the model package for each table, and the connections might be coming from a connection pool. But for a small database like the music one, we're going to keep our database methods within the data source class. Now in this scenario, do we want the method to return a result set? Well, actually, no, we don't. Because we don't want classes that use methods in the model package to have to understand the implementation details of the model. That way, if we change databases later or change to something that isn't a database, an XML file for example, we only have to change the code in the model package. So instead of returning a result set, we can return a list of artists. And that means that we're going to need classes for the artist, the album, and the song. And we're going to create those in the model package, but let's actually start work on that in the next video. Alright, so I ended the last video by mentioning that we don't want to return a result set. And that's because we don't want classes that use methods in the model package to have to understand the implementation details of the model. So in other words, we need an alternative way to return the information, and we're going to return a list of artists. And to do that, what that means is we're going to need classes for artist, album, and song. So let's go ahead now and create those with the model package. And for each one, we're just going to use IntelliJ to generate the setter and getter methods. Now we may not get to use all these classes immediately, but we'll eventually use them all. Alright, so I'm going to open the project pane. Let's create a new class in the model package, And we'll start with artist. Alright, so artist, we've got private int ID and private string name. Let's create the getters and setters for both. Alright, so the album class next, let's create that. And for that one, we've got private int ID, private string name, private int artist ID. And then we're going to create the getters and setters for that. And lastly, the song class. Let's create that. And for this one, we want a private int ID, private int track, private string name, and private int album ID. And let's create the constructor, the getters and setters for all four of those fields as well. Alright, so now that we've done that, we can actually write the query artists method. We're going to add that to the data source class. So let's go back to there. Let's start by creating the class, the method rather, public list. It's going to return a list of artists, and we'll call that query artists. I'll accept that import, and we're going to start with statement. Statement is equal to null, and we're going to do result set. Results is equal to null. We need to add a try here, and we're going to catch SQL exception. Then we'll just print out a message to the console if it fails. Query failed plus e.getMessage. We also want to return null at that point. In addition, we're going to add a finally clause, and the finally is going to try and close things down. So we're going to do there, if statement is not equal to null, statement.close, and we also need to do a catch there. I don't want to bother putting anything there, we'll just put a comment, oh well, if that happens. Alright, so at the moment we're getting this error because we haven't thrown it, we haven't put in the code that can potentially throw an SQL exception. So let's add the code for that. We're going to start by putting statement is equal to connection dot create statement. Then we want to do results is equal to statement dot execute query. It's going to be select star from, then we're going to add table underscore artists to that query. Then we're going to create a list of artist objects, which we'll call artists. Set that equal to new array list. And then we're going to do while results.next. Then we're going to do artist is equal to new artists. Then we're going to do artist.setID, and it's going to be results.getInt. And we're going to use column underscore artist underscore ID. Then we're going to do an artist.setName to be equal to results.getString this time. It's going to be column underscore artist underscore name. Then we're just going to do artists.add artists. Right, so that's our query artists method. So we're creating a statement, and then we execute the SQL statement select star from artists, and that's going to return all the artist records with all column values. And you can see then that I'm looping through on line 64 through the result set, and for each record we create a new artist object, and we use the result set getter methods to get the values from the record and send them to the artist instance, and then we add the instance to the list. And once we've done looping, we return the list to the caller. Or at least we should do that. I haven't written the code for that yet, but let's add that now just before the catch, so that we haven't got any more errors in this method now. Okay. And this time I made a bit of a change. We're using a finally block to close the statement, and What I should really have done as well to be precise here is I should also be closing off the results set. At the moment I'm only closing off the statement. So I'm going to close that first. So we need to close the results set before the statement. So I'm going to do another try there. And it's going to be if results is not equal to null, results.close. And then we're just going to do a catch, SQL exception E, and we'll just put oh dear. But again, we shouldn't get errors there, but what we're doing is we're just covering ourselves here in a worst case scenario. Actually, let's do the right thing here. Let's just print out a message. So we're going to put error closing results set. I mean, it doesn't take more than a second or so to, or a few seconds to actually do it. And at least we'll have some indication that there was a problem. You can get yourself like stuck sometimes if you don't put anything in a catch and you're crashing, and you may not realize that because there's nothing on the screen to tell you that there's a crash. So for the sake of a minute or so to do both of these, it's well worth it. All right, so now we're trying independently to close the result set and the statement. Now, in case you're wondering why I've got two try-catch methods in the finally block, that's because either of those closes could actually catch or could throw the SQL exception. And if that happens, then the second one wouldn't be executed. So in other words, if we had it all in one try-catch block in the finally block, and say the results set through an exception, then we wouldn't get to test the statement closing. So it's best to do them both individually to make sure that we're ensuring that we're checking both of them and then ultimately closing both of them, whether there's an error or not, or whether there's an error when we're trying to close. One thing you have probably noticed though, that it does get a little bit messy here. Having like multiple try catches in the finally clause and then another catch above that for our normal processing can make the code a little bit messy. Remember that we could use the newer form of try and declare the objects as part of this try statement, or if you're not concerned about closing database resources immediately after we're finished with them, we could move the close method calls into the try block and not worry about the case when an exception is thrown and resources are still open, because the runtime would close them eventually. But generally speaking, it's better that you code with that intention in mind and to actually do this yourself, either with a try with resources where you know that the call to close is going to be executed, or as what I've done here where I've actually put in the close method calls myself. Alright, so now that we've seen the code to close the object in all its glory, let's actually modify the method to declare the resources as part of the try statement. So use the try with resources. So I really do think generally that's the way to go because it's more concise, and then we're sure that the close method is going to be called automatically for us. So how do we do that in the try finally? Well, we come up here first, and what we're going to do is put the statement in the first part. So let me just type that. So statement equals connection dot create statement. Then we actually put a semicolon there, and then we put result set. And let's just copy the rest of this line, like so. And we don't need a semicolon there though. What we do need is the left curly brace. And then we can actually delete this code down here. The other thing we then need to do is delete these two references, statement and result set, because we're now declaring both of those objects in the try with resources block. And of course what that now means is we can now do away with the entire finally clause. So we can actually go ahead and delete that. And again, the reason we don't need that finally clause is when we use the try with resources, as we're using up here with the new statement syntax, both the statement and result set will be closed automatically for us, though the close method will be called for both, whether there's an exception generated or not. And obviously in this scenario, callers of the method still have to handle a null return value however they see fit. So in other words, the process that's calling the query artist's method has to actually check to see whether what we're getting back is null or not. Alright, so let's go ahead and call the method now from the main method and print the results to the console. So what we're going to do is add the code in here just above the data source.close. We're going to put list artists equals data source dot query artists. Then we can put if artists is equal to null. We print a message no artists. Return. Otherwise, we can put for artist colon artists. So looping through all the elements of the list of artists that we've got to return from the query artists method. Then we'll just do a print out, and we'll put id equals plus artist.getID plus, then we'll put name equals plus artist.getName. That's cycling through all the entries we've got back in our list, and then we're closing off the data source. So you can see here that we're checking the return value from the query artists. If we get a null, we're exiting with a message saying there's no artists, otherwise we're printing out the artists in the list. Alright, so let's now just run this to see that it works. And you can see we've got a list back of all our artists. A total of 201. Now note that the main method code doesn't make any assumptions about how or where the data is stored. So the data could be coming from an XML file, a spreadsheet, a MySQL database, or even a flat file. If we change how and where the data is stored, as long as we don't have to change any of the method signatures in the data source class, then we won't have to change any classes that use it. And obviously in this case, the main method would remain unchanged in that scenario. But a couple more things to note. Firstly, the statement.close method closes the statement and any result set objects associated with it. So we don't have to explicitly close the result set. Now that won't make a difference to the code we've written, but if we were explicitly closing resources, closing the statement would in fact close the result set. Now second, we can make a quick improvement to the existing code. Now right now we're using column names to get the field values, but we can use the column index instead, and that's usually more efficient. But with that said, there is a trade-off. Now if we use column names, we won't have to change any code if the positions of the columns change within the table. For example, we might add a column to the artists table and position it between the existing _ID and name columns. Now if we've used name columns, we won't have to change any code. But if we've used column indices in our code, then we would have to change them. However, this is easily handled if we use constants for our column indices, which of course we will do. Now it's important to note that when working with result sets, the index we pass to the result set getter methods is the index of the column in the result set, not in the table. I'll just say that again. So the index we pass to the result set getter methods is the index of the column in the result set, not in the table. Now when we retrieve all the columns, the result set indices will be the same as the table indices, but if we only retrieve a specific column or set of columns, then the result set indices may not actually match the table column indices. And we'll see an example of this later. Alright, so let's finish the video now. In the next video, we'll make those changes like we talked about. We're going to start by adding column index constants for all the tables. So see you in the next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
This video is over. Go to starfreelance.eu to download these videos, materials, and sources. Watch more videos to get premium videos and ebooks. We'll be a star freelancer.